बहुत बहुत स्वागत, बहुत बहुत आभार. Good morning, ladies and gentlemen. I extend a very warm welcome to each one of you to this promising seminar on critical minerals extraction from mine tailing and waste, opportunities and challenges. Jointly hosted by the Indian Bureau of Mines and National Mineral Development Corporation. It is an honor for us to have with us distinguished dignitaries, eminent experts, industry leaders, government representatives, and academic partners who have traveled from across the country to be a part of this crucial conversation today. I am Srishti Singh, your host for the day, and I am delighted to accompany you through an insightful day of dialogue, discovery, and dynamic exchange. यहाँ आपकी उपस्थिति एक ऐसे भविष्य को आकार देने की साझा प्रतिबद्धता को दर्शाती है जो संसाधन कुशल, पर्यावरण के प्रति जिम्मेदार और रणनीतिक रूप से सशक्त हो. I welcome you once again to this seminar, which is not just an event, but a national mission. A mission that closely aligns with the vision of Viksit Bharat at 2047. This gathering is graced by the presence of distinguished dignitaries. We have among us Mr. Piyush Narayan Sharma, Controller General, Indian Bureau of Mines, and President of today's function. We also have the graceful presence of Mr. Pankaj Kulshresht, Chief Controller of Mines. We are joined by our distinguished guests, Mr. Jaipal Reddy, Executive Director, National Mineral Development Corporation, and Mr. M.M. Abdullah, Director, Production and Planning, MOIL Limited. We also have among us Mr. S.K. Adhikari, Chief Mining Geologist and the architect of this seminar. मैं हमारे सभी माननीय अतिथियों से निवेदन करती हूँ कि वे कृपया मंच पर स्थान ग्रहण करें और इस कार्यक्रम की गरिमा को बढ़ाएं. आपका बहुत बहुत अभिनंदन, बहुत बहुत आभार. थैंक यू. सबसे पहले मैं हमारे अतिथि श्री जयपाल रेड्डी जी का स्वागत करने के लिए आमंत्रित करती हूँ श्रेयसी दास को. कृपया आएं और उनका अभिनंदन करें. प्लीज गिव अ ह्यूज राउंड ऑफ अप्लॉज फॉर आवर डिस्टिंग्विश्ड गेस्ट मिस्टर जयपाल रेड्डी. अब मैं श्री M.M. अब्दुल्ला जी का हार्दिक स्वागत करने के लिए श्रीमती ज्योति माथुर से अनुरोध करती हूँ. प्लीज जॉइन अस इन वेलकमिंग मिस्टर M.M. अब्दुल्ला. हमारे बीच हैं श्री पीयूष नारायण शर्मा जी, जिनका अभिनंदन करने के लिए मैं श्री कुमार नीलांकर से आग्रह करती हूँ. प्लीज गिव अ ह्यूज राउंड ऑफ अप्लॉज. मैं श्री पंकज कुलश्रेष्ठ जी के स्वागत के लिए आग्रह करती हूँ श्री सुमित जैन से. प्लीज वेलकम मिस्टर पंकज कुलश्रेष्ठ. श्री S.K. अधिकारी जी के स्वागत के लिए मैं बुलाना चाहूंगी श्री विकास सेठ को. थैंक यू। हमारी संस्कृति का एक अहम हिस्सा है कि किसी भी कार्यक्रम की शुरुआत, किसी भी शुभ कार्य की शुरुआत हम दीप प्रज्वलन के साथ करते हैं। मैं हमारे मंचासीन सभी अतिथियों से निवेदन करना चाहूँगी कि कृपया दीप प्रज्वलन के साथ आप आज के इस कार्यक्रम का शुभारंभ करें। तो आइए चलते हैं अज्ञान से ज्ञान की ओर, अंधकार से प्रकाश की ओर, पदार्थ से सूक्ष्म की ओर।
शुभं कुरुत्वं कल्याणं आरोग्यं धनसम्पदः। शुभं कुरुत्वं कल्याणं आरोग्यं धनसम्पदः। शत्रुबुद्धि विनाशाय दीपज्योतिर्नमोऽस्तु ते। दीपज्योतिर्नमोऽस्तु ते। शुभं कुरुत्वं कल्याणं आरोग्यं धनसम्पदः।
दीप प्रज्वलन के साथ हम अपने उद्देश्य और अपने सपनों की दिशा में एक नई यात्रा की शुरुआत करते हैं। What has drawn us all to this important conversation today? A commitment, a visionary step towards Atmanirbhar Bharat, built on the bedrock of mineral security and green growth. We are here because what was once considered as waste after ore processing, mine tailings, is now emerging as a treasure trove of critical minerals that could power our nation's sustainable future. In a world racing towards net zero emissions, achieving the sustainable development goals, and building resilient circular economies, mine tailings and waste are untapped reservoirs of high-value critical minerals. The question is no longer, can we afford to extract value from mine waste? The real question is, can we afford not to? This seminar, jointly hosted by the Indian Bureau of Mines and the National Mineral Development Corporation, is a strategic platform to explore how India can recover critical minerals from mine tailings and waste, while also scaling up domestic production, recycling, and strategic partnerships abroad under the National Critical Mineral Mission. I'd like to mention that as part of its effort to recover critical minerals from mine tailing and waste, Indian Bureau of Mines has launched an ambitious project involving sampling of around 300 mines, generating approximately 3,700 samples. Over 1,500 samples have already been collected, and the analysis is currently underway. Today's conversation invites us to think innovatively, act responsibly, and collaborate extensively. And to set the tone for this important dialogue, it is only fitting that we hear from someone who has been at the forefront of India's mineral regulation. We are thankful for the graceful presence of Mr. Pankaj Kulshresht, Chief Controller of Mines, IBM. A mining engineer, Mr. Kulshresht brings with him over 3 decades of rich experience in the sector. He had an impressive 20-year tenure at Hindustan Copper Limited, where he served as senior manager, contributing extensively to mining operations and leadership. This was followed by a 2-year stint at NMDC. Mr. Kulshresht's journey with the Indian Bureau of Mines began as the regional controller of mines, first at Nagpur, then at Ajmer. He then took charge as the Chief Controller of Mines East Zone. Today, as the Chief Controller of Mines, he stands at the helm of India's mineral oversight, championing sustainable mining practices, technological advancement, and policy-driven growth in the sector. Sir, I invite you to kindly deliver the welcome address. Thank you.
Thank you, Srishti. Namaskar. A very good morning to all of you. Distinguished guest on the dais, Shri P.N. Sharma Sahab, Controller General IBM, who is chairing today's inaugural session. Shri Abdullah Ji, Director Production, Moil Limited. Shri Jayapal Reddy Ji, Executive Director, NMDC, and my colleague, Shri S.K. Adhikari Ji, the key person behind this conference. Of the dais, officials of IBM from all over the country, state DMG officials, mining engineers, geologists from the industry, processing industry experts, experts from the research and academic institutes, and all others present here who have traveled extensively to join us in this one-day seminar on a subject which is very vital in today's context at Nagpur. I understand you have traveled a lot, particularly in this hot summer, and maybe due to the disruption in the flight schedules, some of you has to face a lot of difficulties also. But your presence shows your commitment towards India's commitment for enhancement of critical mineral in the country. The objective of this national seminar is to recover critical minerals from mining tailings, mining waste, with the objective to explore opportunities and to identify the challenges associated with this. We try to bring together all of you, experts, your expertise, your insights, your experience, to a platform where you can share your expertise and experience for sustainable development of these critical mineral resources. As we all aware, critical mineral is playing a key important role in global transition towards the net zero targets set by numerous countries in the world. India also set a very ambitious target of 2070, by which we have to achieve the net zero targets. It is a very important element for generation of the renewable energy sources. As most of the countries are trying hard to enhance their renewable energy sources, the demand of the critical minerals is increasing significantly in all parts of the world. Government of India, Ministry of Mines, recognizing this, and in the last couple of years, made significantly policy changes towards this. Initially, we have removed minerals like titanium, lithium, and niobium from the list of atomic minerals. We have also listed 24 strategic minerals in Part D of the first schedule, and introduced the concept of exploration license, which is specifically meant for strategically and deep-seated minerals. Later on, Act also empowered central government to provide exclusively right to auction the critical mineral blocks. All these efforts are made to enhance or increase the critical mineral production in the country. Despite all these efforts, due to the certain issues, mainly the insufficient data regarding the exploration and the long gestation period in the production of the critical minerals, whatever the success we should get, it is very slow. Recognize this, Government of India search the alternative methods to secure the supply of the critical minerals. Latest technology, advancement in the processing technology have paved the way to search the alternate routes. Minerals which were stacked maybe years back as a waste or subgrade is been exploring for want of critical minerals as practiced in other parts of the world. Indian Bureau of Mines, who is devising strategies for enhancing the critical mineral production in the country, tasked with the analyzing the dumps, tailings, mineral waste available in the country in order to identify the potential mineral resources available in that. For the purpose, IBM has already intensified its processing capabilities by procuring around more than 20 crores equipment in last 1 year. In last 2 months, we have sampled around more than 250 mines and collect around 1,500 samples. But that is just an initiation. We have to work a lot. Value chain of critical minerals, right from exploration, exploitation, beneficiation, processing, recycling, and end-use project. I have personally opened that whatever the theme we have set for this seminar, and whatever the expertise and experience you people share today with us, because we have planned around 15 lectures, delay talks, and the presentation, will be beneficial and create a milestone in the journey which we have begun just 1 month back. I'm very much optimistic that definitely after this seminar, we come up with a solution that will provide, not only will provide a milestone in the history of critical mineral production in the country, but also benefits you people who have large number of stacks of the waste, overburden, tailings, and the slags in your mines and occupied your spaces and also damaging the environment. With these words, once again, I welcome you all in the city of Nagpur, popularly known as Santra Nagari, and wish you a very good stay. And it's a very hot day in Nagpur, but I am very much hopeful that your stay will be comfortable and you will enjoy today's conference, and whatever the learnings you will gather here, you will go back in your minds and will implement this. With these words, I once again welcome you all. Thank you very much.
Thank you so much, sir, for an enriching start to the event. Mr. S.K. Adhikari has over 28 years of extensive experience in mine exploration, mine planning, inspection, and regulatory compliance. He joined IBM in 2001 and has since held key positions across various regions such as Goa, Ajmer, and Nagpur. Prior to joining IBM, he worked as an exploration geologist with Ambuja Cements Limited. He is also the visionary, the driving force behind today's seminar. I would like to invite him on stage to set the context for today's event and deliver the opening remarks. Please give a huge round of applause.
Thank you, Madam Srishti, and good morning to all the delegates who have come all over from the India to attend this one-day seminar. And to begin with, I welcome the dignitaries on the dais, Sri P.N. Sarmaji, who is the Chief Controller General of IBM, and also Sri Pankaj Kulshrestha, Chief Controller of Mines. Along with them, we have our distinguished guest, Sri Abdullah from MOEL, who is the Director of Production in MOEL, and also Sri Reddy from NMDC. And the basic context why we have gathered over here for this seminar is that in the recent budget speech of our Honorable Finance Minister, she delivered it, she assured the people of the country that India will be soon having a policy on tailings, recovery, how to recover critical minerals from the mine tailings. And as a sequel to that speech, budget speech, we have all gathered here to discuss and know and understand whether we will be able to really recover anything out of the waste that is lying in our country. As you all know that many commodities which are basically mined as primary commodities, they also hold significant quantities of other companion metals. Just to give you certain examples, in lead and zinc, we are having a lot of other critical minerals such as molybdenum. We do have cadmium, and we also have many other components in that lead and zinc. Similarly, with copper also, till date, as I understand, as we go through the data that is available with us, we understand that tellurium and selenium was being produced from the Ghatsila mines of Hindustan Copper Limited up to, I think so, 2013 and 14. But since then, somehow or the other, we are not producing selenium and tellurium from those mines. So there are significant opportunities that are available that we can recover critical minerals from the mine tailings and mine waste. It's not only mine tailings, even the smelter slags, they also hold significant opportunities for us. And I do hope that in these slags also there could be some commodities which can be recovered efficiently. So the entire value chain of this extraction of critical minerals starts from exploration, then we have the stage of exploitation, and then we have the stage of extraction. So exploration, government has taken a lot of efforts, and we are doing a lot of work in exploring new deposits for critical minerals. As already told, we have declared 24 minerals as critical minerals, and after declaration of these critical and 24 commodities as critical minerals, we are actually doing a lot of work. Lot of emphasis has been given by the government of India to start exploration of these critical minerals. Earlier, our thrust was mainly restricted to the bulk commodities, but now, last 4-5 years, most of the exploration agencies, particularly GSI, MECL, they have shifted their entire thrust towards exploration of the critical minerals. Similarly, exploitation, as many blocks have already been auctioned as critical mineral blocks by the central government, but exploration, exploitation, there is a huge gap in between that. Just from a greenfield project to bring it to a brownfield project or to make it a exploitable project, it takes more than 10-15 years, and we do not know actually when the project will be on stream. And that is the reason why the focus of the government has changed, and we believe that very soon we'll be able to start extracting some critical minerals, critical elements from the mine tailings that are lying in our country. And as you will see over the full day's progress, you will see that we are having papers not only for this from the solid mineral sector, where IBM is dealing, particularly the MCDR minerals, we commonly call them as MCDR minerals, but we are having people, we are having experts from Atomic Mineral Directorate who will be deliberating on atomic minerals. We are having people from the SIMFAR who will be deliberating on coal minerals, and we are also having people from the oil industry who will be talking about how to extract critical minerals from the crude oil also. So over the entire day of the deliberations, we will be deliberating from across the value chain, from across the sector, from all the types of commodities where there are scope, from where you can exploit or you can extract the critical minerals. And the government of India thinks that it is a much easier way to extract the critical minerals from the mine waste rather than from the greenfield projects, which may take a huge time to actually make them productive. Because any project that you know that once exploration is complete, once you give the deposit on auction, once the deposit is given to a preferred bidder or you can say the successful bidder, but the time lag or the gestation period that is there between grant of a block to finally producing commodities from that, it's a huge time. And we hope that since in our own country there are a lot of deposits that we are working on, particularly we are having copper deposits, we are having lead and zinc deposits, we are having gold deposits, we are having atomic mineral deposits, particularly UCL is working on that also. So there are huge dams which have been created, huge tailings which have been created over a period of time. Maybe some dumps are more than 50 years old or more than 70 years old, and huge dumps are lying there, and significant opportunities are there where we can work. Of course, there are challenges. We don't have the extraction technologies available. That is the reason why we have also invited the metallurgy people, particularly from VNIT. I think so some of our professors are also available here. They will be sharing their insight how to actually extract the commodities from the tailings profitably. So with this background, I once again welcome you all to this one-day seminar of the that is being organized by IBM. The title of the topic is Critical Minerals Extraction from Mine Tailings and Waste. Welcome you all once again. Thank you.
Thank you so much, sir, for setting a thoughtful tone for the day. We will now have the honor of listening to our distinguished guest, Mr. M. Jaipal Reddy. Mr. Reddy is currently holding the position of Executive Director, looking after resource planning, research and development, mine planning, environment, production, and coordination and safety in NMDC Limited. He had a vast experience of more than 30 years. He played a pivotal part in getting numerous new mineral concessions. He also has a critical role in obtaining all statutory clearances of diverse greenfield and brownfield projects. He has been the face of NMDC in many national and international seminars and conferences, and contributed extensively to the mining industries in the areas of environmental conservation and sustainable development. I would request you to kindly address the gathering, sir. Please join me in welcoming Mr. M. Jaipal Reddy.
Thank you, madam. A very good morning to all of you, and welcome to this Orange City, Nagpur. Respected distinguishes on the dais, Sri P. N. Sharma, Controller General of Mines, Indian Bureau of Mines, Sri Pankaj Kulshrestha, CCOM, IBM, Sri M. M. Abdullah, Director, MOIL, and Sri Adhikari, Chief Mining Geologist, and Regional Controller of Mines from various regions, and IBM officials, and my dear industry representatives, and my friend Dr. Sanjeev Sinha, Director Operations, Hindustan Copper Limited, and my officials from NMDC who are attending this conference. I am very privileged to occupy seat on this dais and sharing with IBM officials for this valuable seminar on critical minerals extraction from mines, tailings, and waste. We have received, one day we received a call from IBM for associating NMDC for this seminar. So without any second thought, we readily accepted for sponsoring this seminar. Sir, NMDC will continue to associate with IBM, and NMDC is also having a very established research and development center at Hyderabad in Patancheru, spread over 20 acres. So we can also have a collaboration work in the areas of the critical minerals. That is now a burning topic. So what I understood from the theme, initially for critical minerals, for greenfield projects, it takes a lot of time. Still, we have not yet fully established the reserves. Lot of exploration has to be gone. And also the process technology, which is also not currently available with India, it is available with other countries. And extraction is also very challengeable. So this seminar is setting a tone from the secondary sources, from the already accumulated material from the waste tailings and the dumps. So I hope, I have seen today's various seminar programs. A lot of industrial experts are there. So we'll hear from them and we can find a solution so that in a short time, in near future, we may be able to get some critical minerals from these old mine dumps and tailings. And this seminar setting.
Production and Planning, MOIL Limited. He is a gold medalist in mining engineering and a certified first-class mine manager. With over 36 years of hands-on experience across nearly all MOIL mines, he currently serves as Director, Production and Planning. Mr. Abdullah was actively involved in transforming the mining operations. His contributions span from mine planning to mineral conservation, earning him multiple national recognitions. Sir, I'd like to welcome you on stage to address the gathering. Thank you.
Thank you, madam. A very good morning to all of you. नमस्कार. आज के इस सेमिनार के इनागरल सेशन में मंच पर आसीन आदरणीय पीएन शर्मा साहब, रेड्डी साहब, पंकज कुलश्रेष्ठ साहब, अधिकारी साहब और मंच के सामने उपस्थित सभी सम्माननीय अतिथिगण, आप सभी का मैं आज के इस सेमिनार में हार्दिक स्वागत करता हूं और आईबीएम और एनएमडीसी को बधाई देता हूं कि इतना इम्पोर्टेंट टॉपिक के ऊपर आज इस सेमिनार का आयोजन यहाँ पर हो रहा है। जहाँ तक मॉइल का सवाल है, मॉइल के जो अंडरग्राउंड माइंस और ओपन कास्ट माइंस दोनों में मिलाकर बहुत सारे हमारे पास में वेस्ट डंप्स भी हैं, सब ग्रेड मिनरल्स भी हैं। हम लोग भी क्रिटिकल मिनरल्स की एक्सप्लोरेशन के लिए, प्रोसेस के लिए सैंपल्स लेना, उसका एनालिसिस करना, ये सब काम कर रहे हैं। और साथ ही साथ विदेश में भी कुछ एरियाज़ यदि हमको मिलते हैं क्रिटिकल मिनरल्स की माइनिंग के लिए, उसकी संभावनाएं भी हम लोग तलाश कर रहे हैं। और आप सभी का एक बार पुनः मैं आज के इस सेमिनार में स्वागत करता हूं और आशा करता हूं कि इस सेमिनार के बाद में जो रिकमेंडेशंस आएंगे वो डेफिनेटली इस देश की आगे मतलब क्रिटिकल मिनरल्स की ज़रूरत को पूरा करने में काफ़ी बड़ा सहयोग करेंगे। थैंक यू वेरी मच।
सर, आपका बहुत बहुत धन्यवाद। Ladies and gentlemen, it is with immense pride that I welcome Mr. Piyush Narayan Sharma, the Controller General of the Indian Bureau of Mines. An accomplished mining engineer, Mr. Sharma's illustrious career spans over 35 years. Starting from PPCL, a Government of India undertaking in 1988, he has consistently been at the forefront of modernizing India's mining ecosystem. Having joined IBM in 1997, he has held several key positions across the country, contributing immensely to mineral regulation, environmental safeguards, and policy development. Notably, he was instrumental in creating the star rating system for sustainable mining, for evaluation of footprints of sustainable mining and subsequent development of online portal, which was launched at the first national conclave on mines and minerals. His pioneering initiatives include the adoption of space technology for mine monitoring in collaboration with NRSC and the digital transformation of IBM through the mining tenement system. It is a landmark step towards transparent, tech-driven governance. We are truly honored to have you with us today, sir. May I now please request you to share your thoughts with us. Thank you.
Thank you, and very warm welcome to one and all. And Srishti, it is always difficult to follow up wonderful words, such a decorative invitation, because it is all up to me how I can really follow it up, which is very difficult anyway. So, with me on the dais, my old childhood friend, Pankaj Bhai. I have with me Mr. Reddy Garu. Thank you for being with us. Mr. Abdullah, who is always with us with just a phone call. And I still remember Mr. Adhikari joined in Ajmer when I was there. I have with me Dr. Agnihotri, a long time associate with us. I have Dr. and Professor Pradhan. Pankaj Satija Sahab, I really admire the way he brings in the touch of his spirituality in his endeavor of mining. It's wonderful. I had the youngster from PwC, the old person. I met him in Jaipur. I have all my controller of mines, resilience and the bravery, and towards the very will there is anything in the larger interest of this society, which is the most important. The first thing which comes into my mind when I speak to you, despite all said and done about the critical minerals, its mission, the way we must go ahead, the first thing which comes to my mind is the kind of retribution is being shown by our armed forces. What is that? If you look at the footprints of all these things, we are so precise, we are so pinpoint, and we are so accurate. What is the genesis of all this thing? Is the technology, is the will to innovate, is the will to create an ecosystem within our own country, is the will of the common Indians, is the will of the entrepreneurs, those who have contributed to bring our country up to this stage. That is the first thing which comes to my mind and to many of you. The second thing is the will of our leadership, the resilience, the decisiveness with which, in the larger interest of the country and in the nation, one must take a call, which is again the best route. Now, the will is another most important part. Will to do it, and will to do it for our society, for our nation, for our community, is another most important part. If we look at our own efforts which have brought all of us together here, these two main ingredients are very important, vital, and the core to what we are here. So these two important pillars will lead us where we can stand and tell the coming generations the success story with aplomb and with utmost pride. For that, these two things are very important. The innovation in the technology and our will to do it. So these are the two most important part. Now, if we look at the entire gamut of the issues which are there as far as these critical minerals are concerned, everyone knows now the era of fossil fuel-based energy is gradually going away. Now, for the world to survive and survive beautifully, it is most important that we must explore the alternate means of energy. Energy is one of the most important and one of the biggest need of the humankind. And we being the most populous nation, it is more so for our society, for our nation. Again, we are one of the leading economy, coming up fast, so energy is very critical to us. And that too, a clean energy. And that ought to be a mineral-based energy. So now when we talk about the criticality of all these minerals in our growing aspirations as a nation, growing economy as a nation, and a wonderful society as a wonderful nation, puts all these things at the forefront. What we understand that there are few pillars which are very important. The exploration, of course, into finding the potential which is available in our hinterland. Then, of course, the extraction of all these minerals. The beneficiation techniques which will produce the concentrate. Then the extraction or the processing technology to extract all these minerals. And of course, one of the most important aspects is the reuse and recycling of these minerals. What I understand is that it can be a short-term strategy, a medium-term strategy, and a long-term strategy. As a professional, what I understand is that we are entrepreneurs available here. We are researchers, those who are here. So the most important part is that the low-hanging and the short-term goal can be the recycling and reuse of all these critical minerals. Specifically, the electronic gadgets which we use. A huge electronic waste which is generated in our country is an important source of all such critical minerals. We can create an ecosystem very quickly in a short term. If we concentrate upon it, then it can yield good results for our country. The second, which I always understand, is a medium to long-term goal is what not only the theme of this today's seminar, which is important, that we need to identify what is available in our already working leases. Short to medium-term goals, coupled with the development of the extraction technologies, how we can really process all these critical minerals, all these minerals from these concentrates or from the beneficiated ores. These are because processing technology and to establish it and to do it. So our mineral processing division, all the other laboratories, CSIR and otherwise, those Hindustan Zinc is working, Hindustan NMDC is working. And of course, I should not forget the wonderful work done by the Lloyd recently in the Gadchiroli area. I cannot forget the Tatas. All these industries, those who are working in this field, they can really focus their efforts and can bring out something which is constructive. Then we have the long-term aspect where we can really establish the reserves. We can bring in the later on the various mines and various deposits to the production level, and then we can extract the minerals. So this is a sort of a chain. And parallelly, we can develop the entire processing industry, the entire recycling industry. So the entire value chain can be developed. So this is the multi-pronged strategy with which probably we can do it. The only thing is that it is my firm belief, as all of you know, that whatever happens at any part of this world, there are, I should say, Indians at the background. You find out anything, you'll find the Indians everywhere, be it in NASA, be it in Meta, be it in anywhere, you know. Indians are always there. So there is absolutely, this gives me the belief and the confidence that yes, we can do it without any doubt. More so, if I remember our own history and more so the mythological history, I have a reason to be so. Look at the, you have heard the S400 Sudarshan Chakra, isn't it? At least since last couple of days. The great Sudarshan Chakra was the main weapon of Lord Krishna. We are using some kind of technologies for the spacecraft where it is the reusable vehicles, reusable capsules and everything. But you might not have heard about the reusable astras, reusable weapons. And those reusable weapons were there. The Sudarshan Chakra was a great invention of that time, which could have been launched by the minimum of the force with certain codes, whatever you call it today. It destroys everything and comes back to the person like a boomerang. Boomerang is not so lethal, but Sudarshan Chakra was like it could have killed the entire army. There was a technology. There was a special alloy. You never saw that something is being worked upon the Sudarshan Chakra by Lord Krishna. It was always ready, 24/7. There were the Agneya Astras. There were the Brahmastras. There were the Khadags. There were so many things, you know. All these weaponry used two things: the technology and the special alloys, which probably we call today are the critical minerals, which may result into some other special alloys which may not wear, tear, and can prove lethal, and at the same time may prove very beneficial, like atomic energy, which can be very destructive and which can be very productive as well, depending upon the use it is put to. So this is what I just wanted to express. These are the times where our armed forces are united, they are protecting us. This is the right time for all of us, the mining people, the processing industry, the industry around us, and the research people to come, stand united, to fulfill what is expected from us. A mission has been given to us. We have to march like a military precision, and I understand that together we will be able to do it. Once again, many, many congratulations. Again, welcome, and let us rise together. Thank you very much.
This calls for a resounding round of applause. That's really unconventional, sir. We are grateful for the depth of perspective you have shared with us today. We are also immensely grateful for your leadership. With that, we now move to a moment of appreciation. I would once again like to extend our heartfelt thanks to our distinguished guests for their gracious presence and invaluable insights. As a token of our deep appreciation, it is now time to present a memento to honor their contribution and presence here today. May I please request Mr. Pankaj Kulshresht to present a memento to Mr. M.M. Abdullah as a symbol of our heartfelt appreciation. Thank you for gracing us with your presence, sir. I now request Mr. P.N. Sharma to kindly present a token of our gratitude to Mr. Jaipal Reddy. Your presence has made this event truly special. Thank you. Well, we have much more in store for you in the upcoming technical sessions. From red mud to fly ash, from lithium in oil fields to nickel in chromite overburden. Each session explores a different facet of India's critical mineral potential. With over 15 technical presentations and vibrant discussions, today is not just about knowledge sharing. It's about laying the groundwork for India's self-reliant and sustainable future. But before we move forward, let's take a short tea break before we reconvene within 15 minutes, let's say, for the technical sessions. So stay tuned, stay engaged. Just one more announcement before we proceed. Those speakers who will be speaking during the first session are kindly requested to submit your presentation to the designated area on my right side. Let's now proceed for the tea break to the dining area on my right side. Thank you. steel industry. Joining him as co-chair is Mr. Rama Satpathy, Mr. Rama Raman Satpathy, Executive Director, Exploration and Beneficiation, Lloyds Metals and Energy Limited. I invite our chair and co-chair to kindly occupy the seat on the dais. Thank you so much. I extend a warm welcome to both our session leads. Now, to set the stage for today's discussions, I welcome a visionary voice from the consulting world. Please join me in welcoming Mr. Aditya Singh, Manager Consulting at Deloitte India. Yeah. Mr. Singh will be presenting on Deloitte's recent thought leadership publication on critical mineral recovery from mine waste. Thank you.
Yeah, good morning, everyone. We still have 18 minutes to go post-lunch session. We have galaxy of speakers, right from industry, from consulting, Deloitte, PwC, and many stalwarts. So what we have thought, myself and Mr. Satpathy, that we'll have Q&A after everyone has spoken. You can always be ready for the questions. You can note it down, and then towards the end of when everyone has spoken, you can raise the questions. I can assure you on behalf of the panelists that we will answer all your questions. For the questions we know the answer will be brief. For the question we don't know the answer will be long, so that you will forget the question. But I urge you to ask the question so that all can answer. Sharma Sahib has already elaborated on critical minerals. So I just wanted to place one story of Lord Vishwakarma and son. So Lord Vishwakarma has a daughter called Sanjana, and she was married to Bhagwan Surya. So as every father is worried about the daughter, so he also asked Sanjana how your married life has been. So she said that you are married to someone who is so bright, so luminous that I am not able to sit beside him. So Bhagavan, Lord Vishwakarma reduced the billions of sun by 1/8 or 1/10, and he created many weapons, Sudarshan Chakra or Trishul. And as Sharma Sahib was mentioning that it was recyclable. So all those fight of good over evil either culminated by Bhagavan Shiv using his Trishul or Bhagavan Vishnu or Krishna using his Sudarshan Chakra. So point what I'm making here, that that time also Bhagavan Sur was the rescuer. And today if you see the demon, what it is present before us is carbon, and we all are fighting on decarbonization. And the rescuer is again Bhagavan Surya. So the critical minerals is one such aspect where we are harnessing the solar energy, or if you go for further downstream, green hydrogen, which is also based on solar energy. So that's the way the journey which is going to be, and the different industry, different consulting organizations, they are working on this direction. So with that note, I invite Mr. Aditya Singh from Deloitte to make a presentation. I request him to be within 10 minutes and present the salient points.
Hello. Many thanks, sir. Thanks for your kind words, and definitely a start of the session with a spiritual story, as Sharma Sahib has already indicated in the first session. And once again, very warm welcome to all the delegates and session host IBM and NMDC, Sharma Sahib, Kulshrestha Sahib, and Adhikari Sahib for organizing this thought leadership seminar, where we all are essentially highlighting why this entire exercise is being done, and the timeline has already been discussed that within a month we are discussing all these important facets of critical mineral recovery from the mine waste. Now, as sir has instructed, I'll keep my presentation very short. I'll try to wrap it up in 10 minutes and maybe 5 minutes for Q&A. Okay, so recently we have published a report on critical minerals extraction from mineral wastes and what are the opportunities, challenges. I'll just present this entire discussion in 5 broad themes. What are the demand drivers, and what is the economic potential from this opportunity, and what all technological advancements we have done in India and abroad, and what the world is doing in this regard, especially from the point of view of technological advancement as well as policy support, and what are the challenges which we are facing in India, and summing up it with what we need to do moving forward, because just technological advancement without economic viability is not going to yield much results. So moving on, we are severely aware of our expanding EV revolution, as well as reliance on crude. So mobility is definitely one of the key area where critical minerals are essential. We also are expecting rapid urbanization. We have already increased. Increase the per capita income of the domestic population, and currently we are at third largest on PPP basis, and we are also increasing our power consumption. All these avenues ultimately are going to create demand for these critical minerals which have been imported in India, and a lot of these minerals are completely imported. India does not have even 1% of domestic availability. And recently we have seen how the advancement in aerospace and defense technology is completely essential for India's self-reliance as well as domestic security. And even in the recent trade wars, we have seen that how China has restricted their exports of critical minerals to USA. And it was a show of strength from one country in the entire trade war landscape. So moving on, what is the economic potential of these mineral waste? And first of all, why we are talking about mineral waste? The 3 things which essentially are avoided by looking into this regard is the long gestation period of developing a greenfield project and extraction. And the third thing is liberation. If you are already getting a crushed product, a lot of work has already been done. It's a ready material for you for further extraction. Now, if we see about what different avenues in India so far has been recognized, so in slides you can see about chromite overburden. About 70 million ton of stockpile is there, and nickel, cobalt, these kind of materials can be extracted, and there have been lab scale studies, and pilot project is also going on. In next slides we will see how CSIR is moving in this direction. So about 2.4 to 5.4 billion dollars of opportunity is lying there just in the overburden. Same as with the case with tailings. You see zinc tailings, copper tailings, or even the waste from this red mud. So that is also a great avenue for tungsten, for titanium, vanadium, REs, and a lot of which are completely imported in India. We do not have resources. Same goes for fly ash. Now, about 250 million ton is a great quantity, which is yearly generated in India only, and it's about, I think, less than about a third of the world's fly ash generation, and where REs are economically extractable. About, I think, 450 ppm is the average concentration there available in India. And there are a lot of pilot projects across the world which are going on. In India, it's also started, I think, since 2021. Now, as far as policy is concerned, National Critical Mineral Mission is already there. We have already announced, I think, upwards of 16,000 crores for this entire value chain support. And for the extraction itself, I think about 100 crores of funds are already allocated for the next 7 years. And moving on what currently various institutions are doing in this regard. So in the first row, you can see the success stories which are of Indian relevance. CSIR and CMPDI have identified these potential in various mineral value chain wastes, from mine overburden to fly ash. I'll give a moment to just have a look at it, and then I'll start again. So if I just relate it back to the numbers, about nickel and cobalt, if we talk about their pricing only, about $15,000 per ton, and cobalt at $21,000 per ton. These are kind of economic potentials we are talking about, and we are seeing that technological development have been supported by Indian research institutes, and various institutes like CSIR and CMPDI, CSIR, IMT have developed lab scale processes. I think in the bottom left section you can see that 75% of nickel recovery and 35% of copper recovery has been achieved in this modified carbon process, and these concentrations are very low in these overburdens. I think about 0.3 to 0.9% of nickel is there in these overburden, but still that has been recovered. Now we are seeing what various countries across the world are doing in this regard in terms of R&D as well as policy support. If we see in Australia, an entire 5 million funding is available only for one of the states, that is Queensland. And apart from that, in USA, if you see the Earth Mapping Resource Initiative, they have a similar funding available, and they are doing it with USGS. That entire exercise is about mapping the inventory of these critical mineral wastes across United States. Now, can there be something done in this regard in India as well? These are the questions which these various initiatives help us ponder. Beyond that, what our challenges are, we know that critical mineral content in these wastes is low. We are only at a lab scale. And there are other impurities in mine waste. That is why we are facing challenges in developing circuits for these processes. The energy usage in this process is substantially high. And there are mineral losses. For example, even if I give you an example of lithium, in China, 10% of lithium which they generate, it is purely from mine tailings and mine wastes only. I'm not talking about the lithium recovery from battery wastes. It's only from the mine wastes. But they still face substantial losses in recovery. However, their economics are somewhat different. We all are aware of the cost economics which is followed in industrial applications in China. Apart from that, the other challenges which we have is availability of skilled labor. Now, do we have sufficient skill set in India? Yes, we are. Yes, we are developing rapidly in that regard. And what kind of skills are required? Has those skills been identified, and has those been incorporated in the upcoming curriculum? Are the curriculums updated? Those kind of challenges we need to address. So, delving a little deeper on what can be done in this regard. So, as I was saying previously, development of a relevant curriculum of various branches, for example, mineral processing, metallurgy, mining, whether the upcoming generation is being sensitized about these new avenues in their curriculum, or it's up to us and the industry stakeholders while we are discussing this, but that has to be transferred to the student learning as well. Apart from that, policies and incentive, we have seen this lately at that MMDR amendment, inclusion of critical minerals in schedules, 24 critical minerals, and starting of exploration license auctioning. So those kind of efforts are being done. Royalty rationalization of these critical minerals. These are some of the initiatives which definitely we have done. However, we also need to keep a continuous watch whether they are yielding substantial results or not. Same goes for supply chain development. Now we are talking about critical mineral recovery from mineral wastes. Our argument is that this is relatively faster as compared to developing a green field domestically or abroad. But we also need to be cautious about developing the downstream value chain. If we do not have customers of the end product, we are ultimately going to export those, and the entire discussion of domestic self-reliance is not going to help us much. So, involving those stakeholders, downstream producers, in the investments related to extraction of critical minerals, so that they also see certain security of supply, and they are on board with this initiative. Those kind of avenues can be explored. Apart from that, international collaboration and dedicated processing hubs, we have about, I think, 500 crores allocated for this critical mineral stockpiles, and in recent times we are reminded of how these critical mineral stockpiles are needed for resource security, as well as dedicated recycling hubs. We can follow a hub and spoke model that is being followed in Chile, or a similar model for extraction of critical mineral at mine head, and then further downstream processing at a certain centralized location. So those kind of initiatives definitely should be thought upon by the industry stakeholders. And with that, I'll try to sum it up that while critical minerals recovery from mine wastes gives us the opportunity, we also need to develop the ecosystem in line with what industry is demanding. Otherwise, our efforts will not yield the results which we strive them to be. Thank you.
Thank you. Thank you, Aditya. You can take seat. We'll call you when the question comes. So it was a very elaborate presentation, and I thank the audience also, except one or two who were in Gautam Buddha mode, probably meditating upon what he has told. Eyes were awake. So thanks to the audience for listening to the speaker. That's the respect we can give.
Thank you, Pankaj. Now we are inviting our second speaker. He is speaking in a very, very important subject, which was almost hinting to the core value what we are expecting from today's seminar. He is Sri Keshav Chandra Mandal. He is the General Manager, Concentrated Plant, Hindustan Copper Limited. Yeah. You are ready? Oh. Mr. Mandal, please. Please welcome Mr. Mandal. So all over to you. Ground rules are already set by Pankaj.
Good morning. Myself Keshav Chandra Mandal, General Manager Concentrated Plan. My topics is evaluation of MCP mines, tailings and waste as a potential resource base for recovery critical minerals. This location is Balaghat district, Madhya Pradesh. Significance is largest copper mines in Asia. Our ore results 300 million ton expected to increase with depth. Annual production 2.75 million ton of copper ore. Concentrate capacity 2.5 metric ton million ton per annum. Product is soluble copper concentrate. Tailing management, large quantity of tailing generated, stored in the tailing dam about 2.5 to 4 kilometers from the concentrated plant. Our aim is from waste to resource. The term tailings generally refer to mining waste. However, nothing is truly waste, whether on the surface or underground. Modern technology enables the transformation of waste into economically viable products. Mine tailings from copper mining may contain valuable critical minerals such as rare earth element, cobalt, zinc. These materials remain in the tailings as they are not fully extracted from initial processing. Tailings offer a prominent secondary resource base for critical mineral recovery. Our tailings reserves about 80 million ton. Current use is filling of the mine stopes, and the composition is country rock, chemical reagents from concentrated plant, and processed water. Possible traces elements are in the tailings: cobalt, zinc, nickel, selenium, indium, tellurium. These elements are present in small quantities, but they are not extracted economically due to low concentration and processing limitation. Mines mineral present depend on nature of the ore deposit and method used in the processing plant. Generally, our MCP deposits are types of porphyritic copper deposit, hot rocks, biotite granites, granodites, adamelite. Our tailings generally uses to fill up the mine stopes. Our tailings plant utilizes the paste filling as a backfill technique used in the underground mines, which are fired with a mixture of tailings and binder. And binder is a group of ground blast from GVFS and cement. GVFS about 90%, 9% GVFS and 1% cement. The paste fill in the MCP plant was started successfully 17 July 2024. The capacity of the plant is 3 million ton per annum. The major requirements plants are thickener, horizontal bale feeder, mixer, and PD pump. PD pump is a paste pump, paste discharge pump. The design paste production is 364 dry tailings and 260 million metric ton per hour of paste, white paste. Our major requirement: thickener systems, mixer, and PD pump, paste discharge pumps, and bale feeder systems. This is the photographs. It's a really, we are successfully operation the paste. About 10,500 metric ton we fill the paste in the mines. demand of critical materials, technology advancement. With increasing advancement of technology, the demand for critical minerals are on the rise. Government plans are being developed to extract critical minerals from tailings of various minerals. Economic development. Critical minerals play a crucial role in the growth of various industries that contribute significant economic progress by supporting technology, infrastructure development. National security. Critical minerals are vital for defense application and national security, usually the manufacturing or advanced defense technology and infrastructure. Economically sustainability. Extracting critical minerals from tailings helps reduce waste and promotes sustainability. The process contributes to eco-friendly practice and reduce the environmental impact of traditional mining. The main uses of the critical minerals are battery technology. We are using lithium, nickel, cobalt, manganese, and graphite in the battery technology, and renewable energy and electrical vehicles such as rare earth element, and also essential and permanent magnets in the wind turbine, electrical vehicle motors. Electronics and technology, we use mobile phones, semiconductor, such as electronics device, and example silicon is used in the smartphone screen and processor. Cobalt uses rechargeable batteries. In defense and national security, we use aerospace technology and nuclear applications also. In the foods security, where vital food production and processing as a fertilizer. In the medical field, we use advanced medical imaging and technology such as MRI machine and X-rays. We have actions, different actions have taken by ACL. As per Directors of Mines, Government of India, ACL is prepared collective monthly composite samples of MCP copper ore, copper concentrate, and product, main product, and byproduct tailings. All copper composite samples are quarterly where we are supplying MECL laboratory at Nagpur for analyzing and for future action also. So, opportunities, the recovery of resource from waste and reduce carbon emission and promote circular economic principles also. There is many more challenges. The low mineral concentration and the low-grade materials have high processing cost, profitability, and technology limitation. The advanced technology like bio-leaching and nano-leaching are required, and there are developed, many methods are still developed or not sellable, limited practical applications due to high complexity and cost also. And toxic and hazardous waste components such as tailings may contain arsenic, mercury, and radioactive elements. Reprocessing involves environmental health hazards, requires strict safety and treatment protocols. Economic viability such as profit and highly sensitive to global economical price, lack of long-term incentives, data investment, financial risks makes secondary extraction projects uncertain. Infrastructure deficiency. Tailing sites often lack transport, water, and energy infrastructure, remote locations, and infrastructure investment adds total project cost. Actually, the tailings are waste product of our copper extraction during this beneficiation plant. Some minerals pass down during beneficiation plant. We cannot achieve 100% recovery. We achieve recovery about 90 to 92% maximum, but some ore along with its associated minerals may escape and process and end up in main tailings. It is due to the reason that tailings from Mines-GoI copper project so presence of minerals in lab analysis, the concentration are often very low, leading any extraction effort uncertain. Though there is a now recent result about molybdenum and cobalt is higher in the range. About molybdenum is 400 to 600 ppm, and cobalt is about 80 to 90 ppm. Unfortunately, low concentration technology know-how of untested technology is still in development stage, and in this market scenario, volatile and current geological environmental. Perhaps SLA realize this potential, a more detailed and comprehensive studies are needed to assess the technical feasibility and economical viability for the recovery of the precious critical minerals also. Thank you.
Thank you, Kesavji. We also appreciate the effort of ACL to bring waste to wealth. And I will request audience to park the questions for the end of the session. And thanks for being time. Please keep it up. Thank you.
Thank you. So before I invite Dr. Abdul, who is from Bhubaneswar, I am reminded of one of the stories from Bhagavad Puran. And the stories of King Parikshit when he was returning from a battlefield. King Parikshit was the son of Abhimanyu. What he could see, a very unusual thing. He saw that one cow and bull, they were talking in the language which is understood or spoken by humans. And that made him very curious to go towards them. And when he went towards both of them, what he could see that the cow has tears in her eyes. And bull was on only one leg. The cow symbolizes Mother Earth, and tears in her eyes were the sufferings what she is going through because of the activities humans do. The bull 3 legs which didn't have, the first one was austerity. The austerity which we don't follow. So all of you who are here, please open your cupboard in your house, look at the clothes what you have. You will find at least 4 or 5 clothes which you think that once you become slim, you will use that. You make a plan that tomorrow I'm going to walk, and this shirt or this, dress will fit me and I'll use it. And there are plenty who will be in your cupboard, and similarly with the shoes also. So the austerity leg was not there, which is prevalent today also. The second leg was cleanliness. So what we do all today's time also, Modi ji has been speaking a lot about Swachh Bharat after Gandhi ji also, but still we have a long way to go. And we don't keep our area or the backyard clean. And third one was compassion. We are not compassionate towards, and even about human being. So there's a data which I wanted to share with you. A child smiles 400 times a day. An adolescent or a female, जिसको हम लोग कहते हैं homemaker who is in the house, she smiles 60 times a day. An adult like me and Mr. Satpathy, we smile 20 times a day. So the question is that a person who is coming to this world, he is finding this world very beautiful. He is smiling 400 times. What kind of world we are making? That the smile has reduced from 400 to 20. The responsibility lies with all of us. So the third leg of compassion was not there. The only one leg which the bull had is the truth. And today's truth is climate change. वो होना है, वो होके रहेगा. In Bhagavad Gita also it is written, Bhagavan Krishna says to Arjun, Sarvabhutani Kaunteya, Prakriti Yanti Mamikam, Kalp Chhay Punastani Kalpadyo Virsijamyaham. जब भी कल्प का विनाश होता है, खत्म होता है, कल्प means a billion years, then everything goes out of me, and when everything comes to me, and when a new Srishti is created, I manifest in all the different species. So this was there, but only thing what we have done, we have increased the frequency. So what we used to see is 600 years or 700 years, we are seeing in every year. So my colleague who is going to present, Dr. Abdul, he is from land of Lord Jagannath, so I presented the story of Krishna here. And he also from Bhubaneswar, who sees the cyclone every year. So the climate change happening is also very common and very real in Bhubaneswar, and thankful to the government of Orissa. The resilience in Bhubaneswar, after they learned from Andhra, they are very quick in disaster management. So I request Dr. Abdul to make a presentation. So there are two common things before he speaks and he sets his tune. So webinar, there is a very common thing. Most of the webinar starts with, am I audible? This is the first thing which any webinar starts. And the speaker asks. And most of the seminar, there is a technical glitch, which happens. So we are going in the right direction. There is nothing unusual.
Yeah, thank you. Good morning, everyone. Good morning, sir. Thank you for making us smile today. So we got one out of today's quota. And I'm Abdul Rauf Sheikh. I'm a principal scientist from CSIR Institute for Minerals and Materials Technology, Bhubaneswar. I'll present some of the technologies and ongoing work we are doing in terms of recovering critical minerals from both low-grade resources as well as ores. A small introduction about CSIR. CSIR has got 37 different laboratories working on different fields. And it's also split into different directorates, theme directorates, healthcare, aerospace, etc. I am from the 4M thing, which is mining, minerals, metals, and materials. And CSIR IMMT is a nodal lab for the theme. Along with us, there are several other labs too, like NML Jamshedpur and Simfer Dhanbad. Some of my colleagues are here as well. And this is a list of 24 critical minerals that we have right now, the latest list from the Ministry of Mines. Even though some metals like copper is not in the list right now, it is still very important and it is still very essential for both India's growth in terms of traditional sectors like infrastructure as well as EV sectors. I don't have to talk in detail about why it's important, but we can see even for 2030's demand, the ramp up that is required from 2022 to 2030 is about 30 times in nickel and about 80 times in cobalt. And copper and manganese is about 4 to 5 times, which is both a challenge as well as an opportunity because the demand is really healthy. And in terms of resources we have compared to global benchmarks, nickel's global benchmark is about 1.2% grade. In India, our resource is Sukinda chromite overburden, which is between 0.5 to 0.9% nickel. Cobalt is about 0.3%. Here again in India, we don't have a cobalt resource as such, but what we have in Sukinda is 0.03 to 0.04, about 10 times lower than the global benchmark. Copper, India, we have some resources, about 0.8 to 0.9%, and we are utilizing them, but for the demand, we are still consuming a lot of international resources as well. India is the 7th largest producer of manganese, but our grade is a little bit lower. Manganese Ore India Limited here could talk more on that as well. But because our grade is lower, the more low grade we produce, the more we have to import from high grade and blend it up. And that is one of the challenges here as well. So what are the options for India? Obviously, overburden is an option, and we've been looking into it, and a lot of people are looking into it as well. Besides that, we have seabed minerals, polymetallic nodules. India has a contract to explore at the moment, not quite exploit. But this is a better resource in terms of the concentration. Cobalt is 0.1% and nickel is 1%, copper is 1% and manganese is 24%. So when we look at a holistic approach of recovering all of these metals, this could become quite important. In terms of overburden, we have earlier put up a pilot plant at 10 tons per day capacity, which was based on a modified Cairns process, which basically utilizes ammonia as one of the chief reagent. But this has its own issues. So at the moment, most of the plants that's coming up, greenfield projects in nickel laterites are all high pressure acid leaching projects, which is based on sulfuric acid leaching, which is a much cheaper reagent compared to ammonia. And we have now started working on high pressure acid leaching for the overburden as well, even though the grade is significantly lower compared to global benchmarks. We are trying to essentially optimize the sulfuric acid consumption so that we could come up at a viable process even using HPAL. With polymetallic nodules, we have earlier put up a plant to recover copper, nickel, and cobalt at 500 kg per day capacity. Manganese was not that important back in the day because manganese was not focused back then. But now manganese is as important for battery materials as much as cobalt and nickel. So we are now developing processes which can recover all the 4 metals while we are also keeping a focus on both the energy as well as the emissions that comes out of the process. And the third thing is we are also looking to enhance the product portfolio. Manganese in the form of both manganese carbonate as well as electrolytic manganese dioxide, because these go into different battery applications depending on the kind of battery that's being produced. Other metals, besides copper, cobalt and nickel demand, I would say it's about cobalt demand particularly, 50% is in the materials demand, the other 50% is in about metals demand. So we're looking to develop processes which can generate different products downstream. These are some of the other cobalt and nickel technologies we have done earlier using different kinds of ways. The 300 TPA cobalt for Rubamin and 135 TPA cobalt for Shalina trading, both of these are cobalt based, essentially scraps or sludges. And 1200 TPA nickel for the Nicomet plant is right now with Vedanta, and they're operating that plant, and they're also looking to expand that plant as well, using some imported raw materials that could come their way. Besides this, we have done pilot scale demonstrations for chromite overburden nodules, and also nickel recovery from copper refinery effluent from Hindalco's refinery. Of course, we have worked on battery recycling from both lithium-ion batteries, recent lithium-ion batteries, black masses, as well as from Renault Nissan's older batteries from Nissan Leaf cars. These are some of the other copper and zinc technologies using spent catalyst, brash ash, these kinds of materials. But sticking to copper at the moment, this is an Indian company who wanted to produce copper from copper ores in DRC Congo. They wanted to set up the plant there based on the ores available there. And this plant will produce about 12,000 TPA copper and about 1,000 TPA cobalt as byproduct. Not in metal form, it's quite infeasible to produce cobalt in DRC because of the reagent consumption. The main challenge in this plant is the cost of reagents. Sulfuric acid here is about 8 to 10 rupees, but in Congo it's about 45 to 50 rupees. So the entire optimization scenario changes. So we have just about finishing this project right now, and we're looking forward for it to come up. Similarly, this is also a copper tailings and a dump site in Queensland, Australia, in Mount Isa. This was also for an Indian company who was looking to buy these sites, but they came to us to evaluate how much copper is present and to check the feasibility, whether the copper can be leached out, either through reactor leaching or through heap leaching. Australia is a very good partner for India in terms of critical minerals, and we are working with them. With CSIRO Australia, we have started a project to work on V2O5 recovery and titanium dioxide recovery. Besides this, using the AISRF grant, we are working with University of South Australia in Adelaide. We've got multiple materials from them, including spodumene concentrates, nickel laterites, as well as low-grade copper ores. And we are working alongside University of South Australia and their knowledge based on their work with the industries to develop a process where we could either implement this process in Australia by an Indian company, or we could do half processing there in Australia and bring concentrates over to India and work here. This is a work we did for Manganese Ore India Limited for their EMD plant. They had a capacity of 1,000 tons per annum, which was producing BIS grade batteries, which contains a little bit higher impurity profile, suitable for dry cell batteries. So we came in and we worked on process innovations, which will allow this EMD could go into lithium-ion batteries, essentially increasing the purity. And this was also demonstrated in their current plant in Dongri, Buzurg. Speaking of manganese, 50% of China's selenium consumption is used in manganese metal production. Selenium is an additive in manganese metal production. Besides this, selenium is also used in defense applications, in high-temperature electronics, etc. And tellurium is also an essential component of photovoltaics and other electronics. But selenium and tellurium comes from copper ore. It's present in ppm values in the copper ore, and as copper is produced, it gets concentrated. And from the copper refining process, we get anode slimes. These anode slimes then contain about few percentage of tellurium and about 15 to 20% of selenium. Earlier, we have worked with Hindalco, focusing on tellurium recovery. At the moment, we are working with Vedanta in collaboration with Ministry of Mines as well, to work on recovering both selenium and tellurium from their processed anode slimes. Low-grade ores, speaking of low-grade ores, tungsten is also a very important metal for defense applications, for making armaments, for making, how do you put this, sort of protective layer around tanks. And India does not have a tungsten resource as such. Hatti gold mine tailings contains 0.02% WO3. And another resource is a scrap produced from HAPP plant, which is also a defense PSU basically. That contains about 90% tungsten. From these two materials, we've developed a process to extract 99.9% tungsten. tuned specific to the defense specifications. So tungsten being a powder metallurgy metal, the particle size, the porosity, these kinds of parameters become as important as the purity there. Coming to fly ash, so when we started working on fly ash, our interest was initially on aluminum, so to produce alumina from fly ash. But as we worked, we understood that for it to become viable economically, we need to look at all the products. So fly ash has got 25% alumina and about 60% silica. Half of that is in quartz form, and the other half is in amorphous form. So alumina is produced as smelter grade or chemical grade alumina here. The silica values are split into two products: calcium silicate, which can go into ceramic making, or impure quartz, which can go into these kinds of glass making. This is a little bit of an impure quartz, so it produces a color when you make the glass, because it's got some iron oxide and some aluminum oxide associated with this. While we can't make traditional glass with this, we can continue to make building glasses with this. And finally, of course, alumina can either go into chemical grade applications or to smelter grade applications. Fortuitously, what we found is the rare earth values are getting concentrated into a small byproduct here in iron hydroxide. Initially, we have about 450 ppm total rare earths, which gets concentrated to about 7,000 ppm in the enriched iron hydroxide product. Of particular interest is scandium. Starting at 15 ppm, it gets enriched to 300 ppm, wherein feasibility was established with 400 ppm in scandium ore, which will require mining, high pressure acid leaching, etc. This being already a byproduct, already a process material, it will be much easier to develop a process from this. But more importantly, this is Nalco's bituminous fly ash containing 450 ppm. But there are other fly ashes in the country which already contains a high amount of rare earth to begin with. NLC's lignitic fly ash contains about 1,000 to 2,000 ppm of RE. So we are right now setting up a pilot plant about 50 kg per day capacity at Nalco's premises. And we are looking to compile a lot of different fly ashes there and basically upscale the process there. So what happens is that from this fly ash, we'll get enough iron hydroxide material, which contains the REs. And from this, we'll develop the downstream process to recover the REs. A similar holistic approach is also used for red mud. We work in a consortium. We've got JNRDC Nagpur, NML Jamshedpur, and IMMT, along with Nalco, Vedanta, and Hindalco. Here, our target is essentially to produce pig iron, titanium dioxide, and alumina, and finally, the rare earths get concentrated in the bottom. Besides these two materials, obviously, we've got spent magnets, nickel metal hydride batteries, and different kinds of secondary resources for rare earths. But there's also ample work going on here to both regenerate these resources as well as recycle these resources. So we are developing infrastructure here to develop the RE technologies here. For example, to separate cobalt and nickel, you need 7 or 8 stages of solvent extraction. But to separate lanthanum cerium from neodymium and praseodymium, you need about 80-90 stages of solvent extraction, mixer set less. So we are putting up a facility at our place, about 200 stages, low throughput, but more number of stages. And down the value chain, what we require is once we make RE chemicals, RE chlorides, fluorides, or oxides, we need to convert them into metals and alloys to be able to use them in permanent magnets, particularly NdPr and Dy. So we are developing a 3,000 ampere capacity molten salt electrolysis cell for conversion of these oxides to metals. Thank you very much for the opportunity, and I'd love to talk to you when you have the time.
Thank you very much. It was like poetry. I didn't want to stop you. The presentation was so good, but because of the
Thank you.
But because of the time limit, I have to say. Sure. So if I have to summarize what Dr. Abdul has told, I would like to borrow one shlok. Mantram aksharam nasti nasti moolam manoshadham. Ayogya purusha nasti yojaka tatra dullabh. There is no letter from where a mantra cannot start. There is no plant which doesn't have medicinal value. There is no person who is useless. What we lack is the enabler. And today what we could see in this presentation and the upcoming presentation of SIMFER, CSR, NML, or the different R&D department of Hindalco and others, we are very confident that these enablers will help us not to call anything waste, either as a product or a co-product. So thank you very much, Dr. Abdul.
Thanks. Now, welcome our women's power of this country. And the next speaker is Mrs. Chandrakala ji from Hindalco. And the subject is also very interesting, metal values from Edmond and copper slag. So over to you, madam. Please take it.
Kind invitation. Yeah, I am Chandrakala. For a brief introduction, I am a chemical engineer from IIT Bombay, and I have 20 years of industrial experience from Tata Steel and also Aditya Birla Group. And I have covered in expertise in R&D from ferrous to non-ferrous by being transferring from Tata Steel to Aditya Birla Group. And I hold 5 patents in the area of alumina research, and among which 2 already granted, and 1 we extended the patent for 5 internationals, other nations. So here, this talk I am giving on behalf of Dr. Vilas Tatwarkar, CTO Hindalco. Today overview is, I will be covering brief about Hindalco and Aditya Birla Science and Technology, supporting ABG group of industries, and also critical minerals, today's talk, and the importance are from my perspective, what could be the gap areas, and the case studies of Hindalco, like we have both copper and aluminum as a value-added chain. So where are the scope for these critical minerals in our value-added chain, and the way forward. Hindalco is the flagship company of Aditya Birla Group. We have from Novalis overseas presence to Indian strong operations in copper and aluminum. 3 key facts, if I can give for Hindalco, is Novalis is the largest aluminum recycle company in the world, and Utkal Alumina International Limited of India is the most economic alumina producer in the world. And copper, we are the single location largest custom smelter and in Asia. And if you see Aditya Birla Science and Technology, by being a researcher, I am more, I acknowledge myself as a ownership to Aditya Birla Science and Technology. We are the corporate R&D. We support Aditya Birla Group of industries, not only metals, but also graphene chemicals, which works for pulp and fiber. And we also extend our research to cement, materials, carbon black, and other things. And we also do extensive collaboration with our Indian research organizations. Not only that, we also worked with CSIRO Australia and others, eminent research organizations, to develop the process on the new technologies. On the critical minerals, today's topic, if we see, the industry is fastly changing. This is the backbone for all the modern technologies of smartphone and communication and all, but the industry is rapidly changing with the disruptions in these technologies. This is not only with the pull from the technological needs of the communication and other things, it is also the criticality of the supply chain and the availability, that is also. For example, if I say, if we see semiconductors, earlier it was gallium nitride or silicon carbides were the major source of the semiconductors. Now, because of the availability, we are shifting towards aluminum nitrides or looking for alternatives in these areas. So the supply chain is utmost critical for these technologies disruption also. So while we are, there is we don't have natural resources, we are highly depending on the geopolitical sensitive countries like China. So most of the 95% of the supply is from these countries. So that is where there is a need to look for alternative resources, and while taking up the challenge of today's availability, non-availability of original resources, we are creating opportunities for tomorrow by developing alternative resources. If we see the sustainability point of view, it is more utmost critical, especially for the critical minerals, because since these are present in ppm level, we need long value-added chain to develop for this. While doing so, we need to keep an eye on sustainability. If we see, it is a Earth Overshoot Day is the day when we exhaust that year's budget of the minerals while we are maintaining it. And it was declared as a 2nd August in 2024. This year, it is coming by May end. Means entire year's budget we are able to consume within the half of the year. So this is a crucial concern for the mining of natural resources. So there is utmost important to develop secondary resources from where there is a scope and we can be a leader in providing the critical minerals. Being Hindalco in the value-added chain of copper and alumina, I will be explaining what are the source for these critical minerals in these two industries. If you see the copper, we are producing almost 5 lakh tons of copper, and we have end-to-end value-added chain. We are procuring copper concentrate from overseas and making copper sheets. Not only that, we are also reaching up to the end customers by making copper wires and copper tubes. And while making copper, there is a huge generation of byproducts. If we see sulfuric acid, we make almost 3 to 5 times to the copper generation. So there is a huge concern on its disposal and utilization. And while focusing on the economy in terms of copper and precious metals, we neglect the other valuable resources which are present in the copper resource. And half of the periodic table is already there as a source in the copper concentrates. And we extract copper, gold, silver, almost we produce around 12 tons of gold, 80 tons of silver, and selenium also we produce almost 50 tons per annum. But other elements, there are, while focusing on these things, other elements we try to lock them in the slag, or this will be reporting to gaseous effluents. If we see the value-added chain of the downstream from anode slime, it is a long flow sheet containing like a roasting of the anode slime, converting them to oxides, amenable for pyrometallurgy. Then we have electrometallurgy to recover silver from it. And then further, there is a long process for again separation, purification of PGM metals. And at Birla Copper, we have entire value-added chain at our Birla Copper. So in this long chain, we generate huge effluents. And also, if you see gold converter, we generate lot of lead-based slag. And in electro-refining, we generate spent electrolyte. So lot of waste is generated and lot of chemical intensiveness is there. There is a need to re-look back to the process and make it more economical with less effluents, and also scope for concentrating these minerals while we are redeveloping the flow sheet. And if we see the primary aluminum industry, we have our captive bauxite mines, and we have a presence up to the end user like Eternia, where window sheets are made and used by consumers. So we have our captive power plant, so we end up in generating lot of CO2. We are working heavily on decarbonization roadmaps and other things. And apart from that, at each stage of the value-added chain, we generate lot of waste. Bauxite mining, we have overburden and upgrades which are generated. In alumina production, for every ton of alumina, we generate 2 tons of red mud, huge source of critical minerals. And we are already extracting vanadium, and we are also looking for gallium production. And smelting, we generate spent potline, which is hazardous waste, and same with the dross, which is fluoride content. And semi-fabrication products, we generate with lot of scrap, which we already recycling back to our process. Little bit, I will give glimpse on how we are doing validation in terms of vanadium, gallium from liquor, and bauxite residue treatment. For the vanadium recur, our refineries are very old, almost 65 years old refineries are there. For Muri, and Muri is already 75 years old, and 65 years old refinery is the Renukot. So over the period, our liquors are enriched with the vanadium values. So we already reached to 1 to 1.5 GPL concentration in the vanadium. So it is making us economical to recover them. So without destructing our liquor, we are able to generate vanadium sludge, which is having almost 14 to 15% vanadium pentoxide, and it is processed by our own sister company, SL Mining Group of Company. So where we do a value-added chain up to pure vanadium pentoxide, and also we are making ferrovanadium production. So, and we are also working in the way forward for generating battery-grade vanadium oxide for vanadium flow redox batteries. And gallium, gallium is present in very low quantities in the bauxite, almost in the ppm level, 300 to 600 ppm. And over the period, although it is enriched in the liquor, still there is a technological gap is there. Earlier we used to produce gallium 5N purity metal, 99.999 purity metal at our Renukut industry, but the technology is based on mercury amalgamation. So because of the environmental concerns and these things, we have stopped producing gallium metal in the year of 2004 and 5. And now we are working extensively on revamping with the own technologies, or we are also partnering with the global research institutes. And these are the 3 critical technologies available for gallium recovery. One is fractional precipitation, very old method, which is used by, from the carbonate liquors actually to produce the gallium, wherein we generate huge waste of calcium related sludges because lime milking is used. And in the second process of carbonation method, it is again spoils enter bare liquor. These 2 methods are not useful for integrating with existing alumina industry. So the last one, which is amicable, is solvent extraction. But in this one, recoveries are very low, and we are already evaluating these technologies. We have done few lab scale studies, and we are trying to make the pilot plants. And if we see the Nalco, Hindalco, and Vedanta's red mud is a huge source. If you see vanadium presence is up to 0.1 to 0.15%, and is a huge source of titania. And lanthanum and rare earth metals are also, there is a good source from red mud. Under Niti Aayog, all these 3 industries of Hindalco, Nalco, Vedanta together came and shown the unitedness to support to take the support from our research organizations like JNRDC, CSR IMMT, CSR NML. We all together worked in this agenda of the flow sheet to recover all the rare earth metals. And in this one, we have already developed integrated flow sheet with the togetherness, and now it is going for the bench scale demonstration of 100 kg level. This is supported by all the industries. And to conclude, there is a need to revisit. Technically, the extracting of all critical metals are possible, but economical is the major concern, and sustainability with producing less hazardous waste while we are recovering the critical minerals is utmost important. To making it more precise, it is the need of the day. So this is, and there is, as said by others, there is a skill professional gap also because of the academia and the gap, because we could see in the primary copper and aluminum production itself. So there is no surprise to see the gap in critical minerals. So this is, I think we are started there. So I hope we will work in this strategic scope, and we will come back with some strong presence in the world in the critical minerals. Thank you for.
Thank you, being time. And we really appreciate the effort made by the Hindalco in this regard. And I'm very sure that in future it will add a lot of value to this country. Not only you, but all the scientists, whether it is from the government sector, public sector, private sector, and there are a lot of scientists are here. We must give a big round of applause to all our mineral scientists, because really they are in the right path. After the government has come up with policy, now they have already increased their speed. And I'm very sure that in the world, like space science scientists, mineral scientists also bring their name in this world, Indian mineral scientists. Thank you, madam. Thanks.
So the next speaker is Abhinav Sen Gupta. He is a celebrity in mining because the kind of fan following he has on social media, वो 5-6 लोग मिला के भी नहीं होगा उनका. So, and he's very avid reader. Excluding you or not? And he is going to present on policy issues. So I was also in policy making, advocacy for some time. Policy making, if I have to summarize, मिर्जा गालिब का शेर है कि हजारों ख्वाहिशें ऐसी कि हर ख्वाहिश पे दम निकले. So हमारी जो ख्वाहिशें हैं वो एंड नहीं होती. Whenever you see a government officer, we say कि ये भी बोल लो, ये भी मांग लो, ये भी हो जाए. And the logic, sometimes we always are the loggerheads. So I have narrated one story of father and 2 daughters. I'll present again here. So the father has 2 daughters. Both of them were married. So once he went to the first daughter, and his son-in-law was a farmer. So he asked his daughter that, I see everything is good, but as a father, if I have to do something, please tell me what I can do. His daughter told, no, I have everything. I don't need anything from you. But if you want to, please pray for good rains so that my husband can make good harvest. He told, okay, I will do so. Then he went to the second daughter. He asked the same thing. I am also saying very thing good. If as a father, if I have to do something, please tell me what can I do for you. Second daughter husband was a potter. She told that, you pray for good sunshine, no rainfall. So the father got confused what he should pray for, sunshine or rainfall. The mining industry is very fragmented. PSU, non-PSUs, private, leases till 2030, leases through auction. Each one goes to the father for a different set of expectation. And it becomes very difficult for a policy maker or bureaucrat कि करना क्या है बताओ आप लोग सब मिलके एक मेरे को बताओ क्या करना है. So that is the challenge which I have personally feel whenever I interact with the government officer. So over to you.
First of all, thank you, sir. Thank you so much for those words. A warm welcome to all of you, all the dignitaries on the sides and off the side. So without much ado, I will start the presentation. So I'll talk about the policy issues related to the critical mineral sector, and this is now a very burning topic as of now, and we'll quickly see why and how. So going forward, I'll just talk about setting the context. I'll talk about why it is important, why the focus on the non-traditional sources, which you just spoke about, what are the challenges in recovery of these materials, then what is the way forward, and what IBM should do. So just quickly get started. It all started when our Honorable Finance Minister said in his budget announcement that there has to be a policy with respect to the extraction of the critical the critical minerals from the tailing and waste. It got started there. But if you see, our energy transition is highly mineral intensive. By 2030, we'll require so much of minerals as compared to a conventional, on-course vehicles, renewable energy. I would say solar plants. Everything requires highly mineral intensive. So you require a lot of minerals in place to extract, and also those are required in terms of energy transition. But if you see the mining presently, the mining are very geographic specific. As you can see, these are the only 5 minerals I'm talking about. These are the battery minerals. As of now, you can see the concentration of present mining and the resources are very concentrated. Mostly China, then you have Indonesia, you have Chile, Australia. These are the few areas where the predominance of these minerals are happening. The mining is happening. Surprisingly, if you see the processing part of it, the processing are happening again in the very geographically dispersed areas. So it makes the supply chain very fragmented. So this is cause of worry. We are building it, but yes, it's a cause of worry. So then India formulated this, and they form a conceptualized note that which are the few minerals that should be focusing upon, and that's the genesis of this critical minerals, and the 24 critical minerals comes in. And you can see that in the screen that the zone 4, which we are focusing about in the zone 4, then these are the minerals which government is now as of now focusing on in terms of high import dependent and very much importance. But as a policymakers, we are in much of worry. If you plot that some events which are going to happen and the probability or the impact of that event is going to happen, there are few worries that the policymaker that needs to think of. First of all is the delay in energy transition. If some delay in energy transition happens, then the requirement of these minerals will again fall back. So again, we have to make the timing appropriate. Also, then there's the resource nationalism risk, there's the market volatility, prices. All those things are impacting. Even it is highly geopolitical in nature. So taking this cue, if you could see that there are many challenges as of now, the supply demand of critical minerals falling in place. That's why now we have to go beyond the traditional means of extracting these minerals and go towards the non-traditional means. Now, if you could see the non-traditional means, I will not speak about much because all of you are already aware of it. So there are 6. These 6 are main sources of non-traditional areas from where the critical minerals can be extracted. They are mine tailings, anode mud, red mud, fly ash, and the minerals we can see in the last column. These are the few minerals which, as per the pilot study, has been found out. Many more studies are being going on, so you may discover some few more. Apart from this, there are other minerals like other areas like acid mine drainage, phosphogypsum, industry catalyst, as well as the end of life electronic waste. They are also a source of genesis. But this taxonomy has not been defined yet. So what needs to be done is something which is very important. But where the problem comes is, as you can already see, the challenge of recovery of these minerals is very difficult. First of all, their concentration is very minimum and they are scarce. That's number one. Number two, there is no data available as of now. If data is available, they are very sporadic in nature. Third number, the technological gap, which already has been spoken about. The technological gap in terms of institutional building, also in terms of capability and capacity building. Both of things are lacking. Fourth, there's a regulatory, definitely a regulatory gap you require to solve in, like which regulation will fall in place, how they will pay the royalties and all. That has to be very much clearly. Fifth point is low public awareness. Definitely, as we are graduating, day by day, we'll be getting more aware about this extraction from the non-traditional sources. And lastly, how to integrate the present operations, which are already having these kind of resources in place, and to make sure that economic viable extraction of these minerals or these critical minerals from the tailings should happen. So for this, we need a robust policy in place. So we could see that if you are a government, let's say if I'm from the government side, how I would think about putting this in right place. First, I will try to develop a taxonomy in place. There has to be a proper taxonomy that these are my defined, quoted, non-traditional sources from where I will be extracting these critical minerals. Number two, there has to be a robust database that from just you log in and you get that. You get the database of all the minerals from where you want to, or the areas from these particular specific minerals can be recovered. Third, there has to be some kind of law, rules, regulation which should govern that environmental friendly tailing extraction should be done. And lastly, as already aware, the pricing part plays a very important role, because India is a mining based economy, and we need to have a proper pricing in place of these critical minerals. That's what government should do. Now, if you see as a financer, how you should think about, as a financer, there has to be some kind of fund which should, promulgate this kind of exploitation of this mineral, so that investors should, get attracted to this. Number two, the multilateral agencies like World Bank, ADB, they should take up some kind of projects for the viability purpose. Number three, in terms of, you have to build up some kind of innovative business model so that offtake arrangements can be properly and it can be simultaneously, it can be maintained. So these few things, and also, it has also been recommended that critical mineral extraction from the tailing and waste could be, given a status of infrastructure, so that they can extract they can expect a low cost of capital. Now, as a mining player, what you should do, first of all, there has to be some pilot study. You should take up some pilot study in conjunction with the Indian Bureau of Mines, as well as CSIR, IMT, and then try to get some your hands into it. There has to be a proper technology transfer. A lot of R&Ds are going on, so that focus needs to be done. And also the viability of financial assessment, or the financial viability of their ongoing mines, their ongoing operations needs to be evaluated, so that as of now, the present mining players, they can do this. Lastly, the academic institution, they need to play a very important role in this. There has to be proper awareness. Very few institutions are, as of now, they are teaching mining, mineral processing. The mineral processing coming up a very important subject, and going forward in future also, this will take a very important role. So a proper impetus needs to be given. Also, the academic institutions should support Government of India in building this database, which I already spoken about. And lastly, the communication has to be done. Without communication and without awareness, there is nothing going to fructify. So this is what, in overall, you could see should be done. But if you see what role IBM can play, so I would, I mean, apart from this finances and tax subsidies and all, the IBM should play, and it should focus mostly on the building a national tailings and waste geoportal. A portal is required in sense like there is an easy accessibility, because a lot of data comes every day in life, and with IBM, they have in IBM, and once they link with the proper GIS, then a proper mapping of this database can be done. So this is one area where it could be thought of. Second, they should, more focus should be given towards issuing guidelines towards remining of these tailings and waste disposable, and again in consensus with the global benchmarking, the global practice. So some kind of guidelines should also come in place. Thirdly, there has to be again some incentivize. Already star rating some mines is already there. There has to be some added chapter that could be added, and it should incentivize the players who are actually extracting these critical minerals from these tailings. Fourth, fast tracking of approvals. Again, these are already in place, but there has to be some addendum along with the existing mine plan that recovery of critical minerals from the overburden could be added as a chapter, recovery of critical minerals from tailing could be added as a chapter, and then it should be given a speedy approval. Next, definitely, has to be a technological survey and technological and R&D provider. Like in this case, there are lot of incentives are there. Government has already started their S&T program. So yes, IBM can play a role in this, and presently they are also demonstrating some kind of pilot projects here and in other PSUs, but this could be done in a more large scale basis. Then again, have a strong, robust governance mechanism. Presently, you have a mine surveillance system that also can play a very important role in terms of giving a confidence to investor that all the operations and whatever happening in terms of recovery of this critical mineral should be eco-sensitive as well as environmental friendly. So these kind of surveillance will help them a good amount of confidence. In this, IBM can play a very important role. And again, this is again a bone of contention, as you can see, that royalty, the mapping of royalty, ownership of land and the assets, tailings, all those things need to be defined. So yes, the definition of all these things and properly laying out of this, regulations needs to be done. Initially, at the first 10 years, there should be, freebies, relatively freebies, and after that, it should be more concrete. Then you again also have to play a very important role in terms of hand-holding the state governments. Respective state DGMs needs to, congregate with Indian Bureau of Mines, and they should play an important role in terms of laying out the methods of, how the sampling can be done from these tailings, what area they need to choose up, and what best practices they need to adhere. So that's one important role they can play. And lastly, as you already published Indian Mineral Yearbook, there could be a new book like critical minerals recovery from the secondary sources. There could be these kind of mineral yearbook can also be put in place. And lastly, I want to say that mining tomorrow's essentials in yesterday's waste is something which is going to see a light of the day, because you never know tomorrow's lithium, tomorrow's rare earth you could find in the waste which is already piling up. So with this, I would like to finish up within the time. Thank you so much. Thank you.
Thanks, Abhinav, within the time. So, it is an interesting and some meaningful way forward. Now, we'll request our next speaker, very interesting futuristic perspective. Sri Neeraj Kumar Panda Sahab is the Head Planning and Management Service from Atomic Mineral Deposit. Please, Panda Sahab.
Good afternoon, sir. Good afternoon, everybody. Hello. Yeah. Today's the topic that you have given, that critical minerals extraction from mines, tailing and waste, opportunities and challenge. If anything is going to the mine tailing, where it should be? First, it is a geologist who has to identify the resource. That means the geologist or exploration agency, they will first find out what are the critical minerals that is associated in the primary ores, and ultimately that goes to the mine tails. So this is the opportunities in this gathering. Just I thought of sharing what are the critical minerals that is associated in the atomic mineral deposits of India, so that you can plan and you can see how to develop the flow sheet for these minerals. I have given this topic as the futuristic perspective, because most of the critical minerals that we got it in the exploration stage, this is the future. What I see it in the future, these are the critical minerals that will be available if somebody is going for the mining of the primary minerals. That is likely to be in the tailings. So let us see how we can extract it. That's the challenge. And now we are talking of the 3 E's. Everyone is talking about the 3 E's. That is economy, energy, and environment. We are talking about the 5 trillion economy, for which we require the energy, and that energy should be environmental friendly. For that, what we need, the critical minerals as well as the atomic minerals. Slide down. Yeah. It's not going. Thank you. Thank you. When we talk about the, now we have number of minerals that we see it. If we'll see, that is one is critical minerals, strategic minerals, atomic minerals. There are 3 things. Just I would like to just give a brief overview of what are these 3 minerals basically looks for. Critical minerals, it is basically they are the economic drivers. As on date, there is no substitutes, and they are having the risk of supply chain disruption, whether it is the scarcity or it is the extraction problem. And nowadays we are talking about lot about the REs and lithium. These are the 2 critical minerals. If I'll see, this is the global distribution of RE resource. We are having 110 million tons of the RE resource in the world. And 94% of this resource is confined to only 5 countries. If you'll see, this is China is the first, followed by Vietnam, then Brazil, Russia, and India. And out of that, 40% of the resource is confined to China. India is having the RE resource, it is close to 7 million tons. But our resource position is roughly 6%. But you now come to the, what is the production? If you see the production, 97% of the production is coming from the only 5 countries. And 68% of the production is coming from the China. And though India is having the RE resource, we are having 6% to 7% of the resource, we are contributing hardly less than 1% to the production. Similarly, lithium. Lithium, you see, 105 million tons of the lithium, that is the world over. And it is basically the lithium triangle, ABC. That is the Argentina, Bolivia, and Chile. These are the 3 countries which contribute roughly 56% of the resource. If you add another 3 countries, that is China, USA, and I think Australia, then this resource position will go to 86%. But what about the production? If you see the production, 90% of the production that is coming from the 3 countries. Here you see Australia, Chile, and China. Whatever the resource that is containing that 56%, that is Argentina and Bolivia, they are not producing the lithium. Now, this is a 2016, there is a report that is CEW, that they had enlisted 49 elements that will be critical, that will have the supply risk, as you see, towards the 2030. Here, they have, based on the supply risk and economic, they have divided these critical minerals into 4 sectors. Mostly critical, moderately critical, and least critical. And this is the, what you see it in this diagram, that is Zone 1, Zone 2, Zone 3, and Zone 4. The elements that has been highlighted in particularly the yellow one, these are the elements that Atomic Minerals Directorate for Exploration and Research that we are searching. And this we are searching since 1950s. Secondly, the associated elements that we get along with this main mineral, that is HRE, LRE, then beryllium, tantalum, zirconium, niobium, and lithium. Apart from that, the associated elements that we are getting it, strontium, vanadium, molybdenum, cobalt, and barium. You see the strontium, it is high risk, and it is also economic. This is that supply position. So what we are thinking now is the critical, and these elements are already there in the list of exploration since 1950s by the Department of Atomic Energy. Now, second is what is strategic mineral. Now, one thing is critical mineral, and the second is your strategic mineral. What is strategic mineral? Is basically that is used for our today morning. Sarma Saab was talking about the our brave fighting that is going on. So it is basically we need it for our nuclear, defense, and space sectors. And secondly, they are not like the critical mineral, it is limited to few regions, or it is the extraction to the few regions. It is available. But their supply again depends upon the geopolitical scenario. Just I would like to just bring one notice here. 1963, if you see the first reactor that we had established, that is 1963, that USA had given us the assurance that he will provide us the enriched uranium for 30 years, Tarapur. 1974, we had the Pokhran. Then there was a technological denial. USA did not supply the enriched uranium. We looked for the countries like China, Russia, France. So what happens? Finally, we succeeded in getting this enriched uranium, and our nuclear program started. So that is what I'm telling. Strategic is a different importance. Critical is having a different importance. Strategic minerals, basically, they will be dependent on the prevailing geopolitical scenario. This is the identified resource. Again, I'll just 95% of the resource is confined only to the 15 countries. Now, what is atomic minerals? Atomic minerals till 2023, it was basically the 12 group of minerals that already I have listed here. Out of this, if you'll see the first 6 minerals that has been delisted because it has come to the critical mineral, because the government has seen that the private participation should be there, and this mineral sector has been opened up. And these are governed by the different rules and regulations. That is nothing to tell here. And these are the 24 critical minerals, or that is the critical and strategic minerals. But I don't see any uranium. Uranium and thorium are basically the strategic mineral. If you'll see, it is a strategic mineral, but you don't find it in this list. There must be some reasoning for it, because till now the uranium and thorium has not been opened up to the private sectors. Still it is under the government control. The main aim of opening this sector to the critical and strategic minerals for the private participation, so that will be self-reliance. And still it is in the, ho sakta hai ki it is a paradox, but still uranium and thorium has been placed under the atomic minerals, they are not placed under the strategic minerals. And there is not a clear-cut distinguish which are the strategic minerals and which are the critical minerals. Now, for the critical raw material chain, there are, okay, sir, then I'll just skip up some of the things. Then these are the resources that has been established. That is 47 uranium deposits, 4,28,000. Then BSM deposits, that is containing your monazite and zircon. Then we are having the first lithium deposits, that is 1,800 tons of the lithium that is established. And we are having 2 RE deposits from the hard rock. That is the largest, that is the Ambadongar, that has gone to the GMDC. They will be taking up the, and the rest 2 are in the Sivana ring complex. So what are the critical elements that is associated in the different uranium deposits? If you'll see, it is basically the 5 geological domain that we get it. And molybdenum, vanadium, copper, lead, REs, invariably all the deposits you will get it, sir. But I would just like to highlight one point in the molybdenum that is invariably associated with all the uranium deposits. This is some data I am just showing to you. Molybdenum, if you see the crustal abundance, it is 1.2 ppm. But most of the uranium deposits, they contain up to 200 to 300 ppm. And it goes up to 890 ppm. So molybdenum is one of the things that can be looked for the recovery of the critical minerals from the uranium deposits. Second, in the monazite, we are having the REs as well as the thorium. That needs to be, again, that R&D has to be taken care of, and we can go for it maximum. And the RE resources from the carbonatite and RE resources from the Sivana ring complex. There are 2 deposits. Ambadongar, if you'll see, it is a LRE rich deposit. But when it is a Sivana ring complex, it is the HRE rich deposit, where you are 30 to 40% in the RE, it is basically the HRE. And most of the deposit, if you'll see, it is LRE deposits. Even if for China, that is Bastanosite, that is LRE deposit. And most of our, what I am telling, the 13 million tons of the monazite that we get it, that is basically the LRE rich. But the Sivana, that is containing 30 to 40% of your HRE, that is very strategic deposit for us. And this deposit is going to be for the auction. We have already submitted the report, and it is going to be the auction. Again, I'll come here, strontium, niobium. This is basically, we are dependent on the import, and we don't have the resource, okay? But these deposits contain substantial amount of your strontium, as well as your vanadium and niobium. All these 3 elements that we are depending upon the import, and these deposits contain substantial amount, more than 1 lakh ton of this mineral commodities are there. So these are the already tailings of what are the different countries are doing, and this is the different methods that is following. Now I'll come to the what are the tailings, what we are getting. And all the critical minerals, they don't form the deposit of themselves. They will be associated with some primary mineral deposits. And we have done some assessment of the mine tailing, that is of the uranium, that is in the Tumlapalli, as well as the Singhbhum Shear done deposits. And it's very challenging, that sampling is very challenging. And we have found a lot of difficulties while going inside, and it is a waterlogged area. It is a challenging task. So this is how I'll show it, some of the data that I'll just show it, and this has been shared with the Ministry of Mines to formulate their tailing proposals. That here I'll just point out one thing. If you see the tailings and whatever that critical mineral that is associated with the deposits, lot of tailings are showing basically there is some milling loss, and you have to accept it. Then what is the way forward? The last slide, I'll just take 1 minute. What is the way forward? Now, first is as a geologist, first the quantification has to be done, and what is the identification of this critical elements that is present. And what should be our target? Should we go for the target for the recent mine dumps, or should we go for the old mine dumps? In my opinion, we should go for the old mine dumps. Because as the technology is improving day by day, we are processing the low grade ores. So previously, if you see the 50 to 60 years back, higher grade ores were mined. So these tailings should contain more critical elements as compared to the recent one, that is my view. So you should put the thrust particularly on the old mine dumps. Second, the R&D efforts should be there to develop the flow sheet, which Ministry of Mines has come up with very nicely. They have come up with some proposals which is very much reflected in that National Critical Mineral Mission. Then mineral concession proposal should consider the complete recovery. Here these are some of the suggestions that we have given it to the Ministry Mines. What I'm telling, okay, mine tailing is your short-term goal. It should be your short-term goal. If I'm giving a mining lease to any person for the uranium, he's not recovering rest of the things. And IBM is the authority for the non-atomic minerals, and AMD is the authority for regulating aspects for the atomic minerals. And in this context, I would just like to bring one Rule 58 of MCDR, where this IBM and AMD can give the instructions to develop the flow sheet for the associated elements. And if it is viable, that can be included. Because what I see, if you see the, particularly this tailings, it is containing the less what is in situ as compared to a lot of losses are going. So first, okay, for the initial stage, we can go for the recovery of the critical minerals from the tailings, but our medium to long-term goal should be there, and Ministry of Mines is going on a very large way, encouraging the R&D sectors. My point of view will be to establish the R&D sectors and see that if it is economic, let it include in the mining plan, and let us develop some pilot plan to recover this critical before dumping it to the tailings. And most of the tailings, if you see the underground mine, we are filling it up. We are also losing the critical minerals. Then regulatory aspects, that is what I am already told, and bulk resource. And when you are going for the tailing processing, if you see the Singhbhum Shear zone, there is number of, whether it is SCL they are mining, UCL they are mining. So it may not be small if you give it outsourcing to some persons to recover the metals, it may not be economic, but if you give it in a bulk, all the mine tailings in a single platform you give it, it may be economic, because processing of a large quantity may be economic, but if you process the small quantity, it may not be economic. This is the view of our directorate, and we have given this feedback. Thank you, sir. Sorry, I have taken a little bit more time.
Thank you, Panda Sahab. Thank you for bringing a new dimensional view, critical minerals from atomic waste and short-term, medium-term, long-term, your advice to the policymakers. And thank you very much. We appreciate. Thank you.
Thank you. The next speaker is Sri Gajanan. I thought you should be the first one. The name symbolizes Sri Ganesh. So, but anyway, this also is quite useful. Before Gajanan comes, he is going to represent on area called Sukinda. And a very famous story related to that mine. So 1950s, there was a person who was working in Tata Steel from that area. And when he had come for a holiday to his native place, being a tribal, he moved to the forest area and he got a shining piece of a stone in the hand. He was very curious to know what it is, and then he gave it to R&D department of Tata Steel in 1950s. And then Gajanan, the department he is currently now, they worked on it and they found out this is chromite. And that way chromite mining in India started, with Tata Steel getting the lease in 1953 with 1800 hectares. In 73 it was reduced to 1200, 93 it was reduced to 400. So it's a very classic case study of starting the chromite mining and policy advocacy, the Supreme Court judgment. I mean, one place, but many perspective, many learning. And Gajanan is going to present on how we can recover nickel. So maybe what Katepurti did in 1950s, Gajanan is trying to do in 2020. Thank you.
Yeah, good afternoon to all of you. First of all, I want to thank to the organizer for inviting me for and giving opportunity to present at such a prestigious forum. It is also a privilege for me because I have on the dais my current customer and the ex-customer, and also few of my ex-colleagues here. So I am really excited to show some of the good work which we have done at our R&D Tata Steel. So my topic of presentation is technology development and challenges in process scale-up to extract nickel and cobalt from indigenous low-grade lateritic chromite overburden. So I have my co-authors here, Neel Madhav Sahu, Dr. Asim Kumar Mukherjee, Dr. Siddharth Mishra, Mr. Vinay Mahashabde. They are from R&D. Dr. Rajesh Mukherjee, and he is from Natural Resource Division. He must be there in the audience. Then Mr. Pankaj Satija, who is on the dais. He is my current customer. And Mr. D.B. Sundaraman, who is the current corporate services vice president and ex-VP Raw Materials. Yeah, so this is an outline of my presentation. So I will try to brief a little bit about criticality of nickel and cobalt, then introduce you to the Sukinda nickel, which is the only identified source of nickel in the country, the major source. Some mineralogy, then some nickel flows, the sources and destination, that how the materials flow is happening currently. Then I will touch upon few extraction technologies, and then I will present some of the work which we did to develop the technology for the low-grade chromite overburden and what are the challenges we have faced in that. Then some of the key policy recommendations, because I am also a member on the special nationwide team which is formed by Niti Aayog on nickel and cobalt. So we get a frequent opportunity to make suggestions in consultation with our customers. And then I will conclude. So I will try to complete my presentation in 15 minutes. Okay, so 10 minutes. So please excuse me if I drop few of my slides. So criticality is known
So
that any...
what you can do, I'll just give you a hint. So the slide which you want to skip now, you can say, already you know, and then you can move forward.
Okay, I will try, sir. So any mineral or element which is in a supply risk, but at the same time its impact is very high, especially for the strategic sectors. So that is what we call as a critical minerals. Now this is a critical mineral matrix for Europe. So if you see on the x-axis there is a minerals of economic importance and the y-axis on the supply risk. So there is some sort of prioritization they have done actually. You can see that the rare earths are highly critical, so they follow extremely at the top. Whereas on the right hand side, the economic minerals, they are in abundantly available like chrome, manganese, iron and all. This matrix actually varies from country to country. So you can see here nickel is not critical for them. But for India, it is critical. So in 2023, we have got a 30 list of critical minerals. So I will be talking on nickel and cobalt. So nickel and cobalt, it is mainly, there are two major sectors for which it is important. One is a stainless steel and another is a batteries. So why stainless steel? Because about 30% of the total stainless steel, if you see, it is used in the metal goods and kitchenware across the world. So it is a very important material for all the kitchens across the world. And then you can see that in the developed countries, the major applications are for construction, for transport and all. Whereas in the Asia region, mainly the China and India, it has to come up to 2020 to realize some technological benefits which shows some promise. In Tata Steel, we did in 2010, for the first time, we tried to extract all chromium, iron and nickel from this material. But if you see historically, the effort was only on extracting the nickel. So we have a big responsibility now to make the nickel available for the country from this material. So I will not touch upon, I will not go through in detail because you already know this, the mineralogy of overburden. So the idea is, if you see over the years, since the overburden contains less than 1% nickel or around 1%, it is generally perceived as that the nickel cannot be extracted in a techno-economic manner. I think that is the only message I want to give. And historically, the efforts were made only to extract the nickel, whereas there is a value in that, in iron as well as chromium. And that is the aspect which is the stainless steel and especially China, which has leveraged this. And around 2010, there were developments on nickel pig iron. Similarly, in the same period when we developed our RHF process. So currently, you see Philippines is the largest exporter of nickel materials to the world, and China is the biggest importer. The another country is New Caledonia. So ferronickel and nickel pig iron, they are generally reported together. So you can see that Indonesia is currently the largest producer of ferronickel as well as nickel pig iron, and China is the largest consumer. If you see the import of nickel materials, most of the or all of the nickel is imported in the country currently. So we are making an effort to replace or try to minimize this import from the other countries and find out a product which can provide as a import substitution. So these are the two major minerals. So you know that sulfide and laterites, these are the two major minerals which contains the nickel. So in India, we have the nickel in the laterites in the Sukinda Valley, which is around 1%. And if you see the technologies, the pyrometallurgy is generally more practiced for the laterites. So about 20% of the total nickel which is used is in the form of nickel pig iron and another 20% in the form of ferronickel. About 5% comes from the hydrometallurgical process, which is whether it is a HPAL process or a combination of pyro and hydro, which is a Caron process. So, but the major substantial chunk is coming from the ferronickel production, which is a pyrometallurgical process, ferronickel as well as nickel pig iron. So, rotary kiln electric arc furnace is the major technology currently worldwide, wherein there are two major steps. In the first steps, the ore is pre-processed in the form of preheating or pre-reduction, dried, and then subsequently it is melted in an arc furnace. So adopting this technology directly for our ores, it is challenging because the nature of our ore is different. So I will not go into much details. You are aware that then there are many different technologies, as I said, hydrometallurgical and pyrometallurgical. But their major application depends on the nature of the product which is formed. Like there are technologies which target the battery sectors, whereas there are technologies which targets the major stainless steel and pyrometallurgical industry. So these are the different flow sheets. So if you see Sukinda overburden, it is a good material as far as the iron content is concerned, but the nickel content is about 1%. Therefore, this technology development becomes challenging. If you see the mineralogy wise, so the nickel is present in the hematite, goethite form. The other two major minerals in the ore are chromite and hematite. So these are some of the mineralogical studies. If you see the deportment in the material, so most of the iron, about 95% of the iron is present in the form of goethite, whereas about 98% of the silicon is present in the form of quartz. And there is also minor chromite in that. If you see the nickel deportment, about 80% is with the goethite, whereas the balance 20% is with the manganese minerals. But for the cobalt, almost all of the cobalt is present as expected with the manganese minerals. So it is a very fine material. So DET is about 0.75 micron. So that makes it the pre-processing technology challenging. We cannot feed this material directly to the established technology, which is the RKEF process. So we have to go for agglomeration. So these are some of the images of the nickel pig iron, which we produced first time in a rotary arc furnace in the year 2010. And subsequently then there were efforts to develop this technology and take it forward. Recently we did a large scale trial, which is 1,000 ton of low grade chromite overburden, which we agglomerated and smelted. And we got a very encouraging results where we have seen that we can produce a nickel pig iron which can contain nickel up to 1.5 to 2%. But the major challenges will be in the techno-economic of the process, because the energy consumptions are high, the specific consumptions are very high. So we have requested ministry for certain support in this regard. So, and now going forward, we have planned to validate this material in the actual stainless steel production process. So there are some stainless steel production trials we will be doing this year. So with so these are the three major technologies which Tata Steel is trying to scale up. For the current need, we are working on the submerged arc furnace route. But if we have to meet the scales which are desired in to meet the nickel requirements of the country, we may have to go for a blast furnace technology. So parallelly, there are developments being taken up to develop the blast furnace technology. And to make it green, we are also customizing the rotary kiln electric arc furnace for this technology for this material. So we have faced challenges mostly in the form of the material nature. It's very fine, so agglomeration of it becomes a challenge. Then during the smelting, it is the cost which is the major challenge, how to minimize the cost and make it techno-economical. So on the right hand side, you can see there are some of the product picture, which is a nickel pig iron. It is actually country's first nickel pig iron produced from an indigenous material. And then we are also developing some further value-added products from this, which are for the battery segment. So some of the policy recommendations which we have given, we have requested ministry to support. So to make the process economical, we have seen that this bead premium, which is generally imposed on a chromite material, it should not be applicable, and it is more or less ministry is kind enough, they have accepted this suggestion to waive the bead premium. Then we have environmental clearances to make it to enable the ease of mining, ease of scale, and the speed. We have requested that there should be waivers in the environmental concerns, because already to mine a 1 ton of chromite, about 5 to 10 ton of this overburden is mined. So kind of environmental things are already being taken care. So we have requested that there should be waivers in environmental clearances in the entire value chain of nickel. Then if the value addition is done at source, then that can encourage for the mining, basically distribution of mining benefits and job creation. And we also requested that since this is material, the specific consumptions are very high, so there should be subsidy on the power tariffs, on the investments, because this infrastructure needs to be customized. The current infrastructure of ferroalloys or iron making units, there is a requirement of investments like AOD, pig casting machine. Iron making in a submerged arc furnace is actually challenging and not practiced worldwide. There are only 1 or 2 incidences where this is being done, but the raw materials are different. So these investments will be required. So there can be some support provided for this. Then existing plants should be allowed, submerged arc furnaces as well as blast furnaces plant. With minimal regulatory clearances, they should be allowed to produce this, because the nature of the product is not changing much. If you see critical minerals, and especially if you want to bring a focus on the indigenization or encouraging the use of indigenous material, there is a need to support the technology developments, and therefore we have said that government would like to sponsor the pilot and demo projects for this type of technologies, which will help us to make the indigenous materials for the real value addition as a reality. Then, this I already covered, that the existing producers with minimum environmental clearances, they should be allowed for producing this material. If you see this material, since more than 95% of the nickel is present in the Sukinda Valley, and it is generally an area which is not much developed. Historically, it is a road transport which is a prominent mechanism for transport. So there should be some effort done to make the ease of logistics, and if there are some investments required, those initiatives should be taken, so that the scales which are desired, because it contains only 1% nickel. So if even if you have to meet only 10% of country's nickel requirement, about 20 million ton of this overburden needs to be moved. And these volumes will go up. You can imagine for total requirement how much we have to mine. It's close to 200 million ton. So road transport may not be a solution. So those initiatives can be initiated from government. And secondly, we have seen that mostly the stainless steel industry is not able to grow because it is highly dependent on the imported nickel. So it is actually the nickel which is restricting the growth of a stainless steel industry. So nickel is imported in the form of scrap. So if there is any material which contains less than 2% nickel and it is in the form of nickel pig iron, so there should be an effort made to discourage import of such materials, because we can have indigenous materials then in that place. So that is the last suggestion. So I think I have covered all my conclusions. So we have faced challenges mostly on the technology development, which are the material specific. So we are going for a combination of the agglomeration technologies. If you see sector-wise, then there can be a combination of technologies, hydro and pyrometallurgical, one needs to think, to cater to different product segments for stainless steel as well as batteries. So thank you.
Thank you. Thank you, Gajan. So usually it is said that you should have two type of friends. One is like Krishna, who always guide you for the right path. And second is like Karn, who stands with you even if you are on the wrong side. And third is Gajan Kapure, who always writes your name even if you have not contributed. So he has written my name in the presentation, but I have not contributed.
No,
So
we got on the policy, we got sirs, because it is in Tata Steel we have a customer team. So as a EIC, he has given us many suggestions which we need to make for the ease of mining, basically.
That's your greatness. I can only say that you all should have one friend like Gajanan. Thank you. Thank you very much.
Now, without any delay, we would like to invite Mr. Sudhir Kumar Panda, again with an interesting subject. Please welcome. Come, Sudhir. We first, now we are already running 15 minutes delay. So, floor to you. Thanks.
So, good afternoon, ladies and gentlemen. I am Sudhir Panda, Superintending Geologist from Oil India Limited. We'll take you through this topic, lithium prospectivity in hypersaline formation water of oil field, a feasibility study from Rajasthan Basin, India. So, I will quickly take you through the overview of our company, Oil India Limited, and its initiative in the field of critical minerals. And then I will explain why we have chosen this Rajasthan Basin as a suitable candidate for lithium exploration in formation water, and then the methodology adopted, and finally we will see what are the analytical results and findings, and we will compare it with some global examples and then the future actions. So Oil India Limited, our company is a Maharatna PSU company and an integrated energy company. So it's having a legacy over 100 years legacy, starting in the year 1889 when the Digboi oil field has been discovered, the first oil well in Asia. And also we have discovered the first independent oil field in Naharkatia in the year 1953. So we have a vast presence in the upstream, midstream, as well as downstream sector of oil and gas industry. So in the midstream sector, we have 1157 kilometer strong pipeline, crude oil pipeline. And in the downstream sector, we have almost 70% stake in Numaligarh Refinery Limited and 49% in Assam Petrochemical Limited, 20% in Brahmaputra Cracker and Polymer Limited, and in city gas distribution, we have 50% stake in HP Oil and 20% in Purba Bharati Gas Private Limited. So apart from this oil and gas sector, we have also presence in renewable energy and green energy sectors. So as far as renewable energy is concerned, we have the presence in solar energy in Rajasthan, 14 megawatt power plant, and in case of wind energy, we have 174 megawatt in Rajasthan, Gujarat, and MP. And we have also explored to green hydrogen. We have installed 100 kilowatt capacity of green hydrogen plant in Jorhat, Assam. So apart from this, we have diversified our portfolio in the field of critical mineral, geothermal energy, and natural hydrogen exploration. So this map indicates our strong domestic footprints in India. So in several sedimentary basins, like in the northeastern corner, we have the Assam Shelf and Assam Arakan Fold Belt in Tripura, Mizoram, Assam and Arunachal Pradesh. In the western side, we have covered the Rajasthan basin, and we have also ventured into the offshore business, oil and gas business in the Mahanadi, Krishna and Godavari basin, Kerala Konkan basin, and also the Andaman offshore basin. So as far oil's initiative in critical mineral is concerned, we are the pioneer of critical mineral exploration in the oil PSU sector. We are the first oil PSU ventured into critical mineral domain. We have identified a few critical minerals based on the use in clean energy. And our primary focus is India and also abroad in Australia, Argentina, Brazil, Chile, and African nations. As far as the auction round is concerned, we have participated in the round 2, 3, 4, and 5 auction round of critical mineral by Ministry of Mines, and we have declared as a preferred bidder in FOB graphite and vanadium mineral block in Arunachal Pradesh on 7th November 24. We are going through the strategic partnership with global and domestic organizations also. So this right side figure shows part of the FOB block and the mineral rights, graphite mineral rights zone. So now coming to the present study, why we have chosen Rajasthan basin as a suitable candidate for this study particularly. So Rajasthan basin, as you all know, it is a category 1 sedimentary basin. It's subdivided into 3 sub-basins: Bikaner Nagar sub-basin, Jaisalmer basin, and Barmer Sanchar sub-basin. The Bikaner Nagar sub-basin is the largest geographical extent in Rajasthan basin, having 70,000 square kilometers, followed by the Jaisalmer basin, which is 45,000 square kilometers. So among these 3 basins, Oil India is strongly pursuing the exploration and production in Bikaner Nagar sub-basin and Jaisalmer sub-basin, as you can see in the given map. So the present study is limited to Bikaner Nagar sub-basin and Jaisalmer sub-basin, as we are operating there. So maybe the stratigraphy is not visible because the combined stratigraphy of 3 sub-basins is given. But the right side image, you can see the stratigraphy of Bikaner Nagar sub-basin from the drilled well evidence we have given. So what are the factors mainly we have considered why we have chosen this basin as a potential candidate? Because as you know, the Rajasthan basin, all the sediments starting from the Paleozoic, Mesozoic, and Cenozoic, all the sediments are resting over the Malani igneous volcanics, the rhyolites. So these rhyolites can act as a potential source of lithium. Also, we have a huge thickness of Hanseran evaporite groove. So this HEG groove is a strong evidence of the arid or subarid climate in the past in this area also, which is favoring the lithium concentrations. So as far as the hypersaline formation water is concerned, the salinity in the range of 1 lakh to 2,50,000 in Jaisalmer basin and up to 3 lakh ppm in Bikaner Nagar sub-basin. So this hypersaline formation water indicates the prevailing conditions for lithium concentration in this basin. And also the short fluid migration distance. What is short fluid migration distance? It is basically the basement, and in the above we have the HEG evaporites. So in between we have the reservoirs in the form of Jodhpur sandstone and Bilara sandstone dolomites also. We have a Nagaur sandstone. So all these reservoir rocks having the crude oil, gas, and the formation waters. So this short migration distance also favoring the lithium concentration. So when we see the Jaisalmer basin in comparison to Bikaner-Nagar sub-basin, we do not have the evaporite sequence presence there. So Bikaner-Nagar basin is having the upper hand in this study. So now, what are the oil field brines? Oil field brines are nothing but the saltier saline wastewater that is produced along with the crude oil or gas, whatever we are producing. So as you can see in this pie chart, there are different sources of lithium. So the hard rock pegmatite contributing 25%, and the continental brines, salar, salt lakes, contributing the most 59% of lithium. Apart from this, we have also lithium concentrated in the sedimentary clay formations. So those are hectorite and jadeite, those contributing almost 10%, and the geothermal brines and oil field brines individually contributing the 3% for lithium resource. So why we are choosing the oil field brine? Because it can diversify the source for lithium. Also, as we are exploring in the oil and gas fields, we have several sedimentary basins, so we can explore lithium in these basins also. So the geographical flexibility is always there, and the technology like the direct lithium extraction technology is evolving technology which is facilitating the process. Apart from this, we don't need any traditional brine evaporation pond which takes a huge area for brine evaporation. So all these factors are facilitating the oil field brine exploration. Apart from this, whatever challenges we face in terms of concentration, so these oil field brines have very limited concentration, means not that much high as comparison to the hard rock and the continental brine, but it can be economical with technology. And as far as the complexity in the chemical composition is concerned, due to the different chemical composition, the formulation, the formula design in the direct lithium extraction technology can differ or can be somewhat difficult also. And in the technology development front, although direct lithium extraction technology is developing, but need to work on the cost effectiveness and the and its effectiveness, efficiency. Yes, sir. So in the Bikaner-Nagar sub-basin, we are producing the crude oil, the heavy crude oil having specific gravity degree API less than 10, along with formation water. As it is very heavy, we are producing through cyclic steam simulation. So due to cyclic steam simulation, we have a very limited formation water available in Bikaner-Nagar sub-basin. Also, we are producing from only one reservoir, Jodhpur sandstone. Although we have proven the upper carbonate as a producing reservoir, but as can be potential reservoir, but we are producing so far from the Jodhpur and formation of Baghewala field only. But in Jaisalmer basin, we are producing gas from different formations as Sanu, Goru, Pariwar, and Kuyala from different fields like Tanod, Dandewala, and Baghewala. So this diagram indicates that while we produce the oil or gas, that we produce it along with some formation waters, and we take them to the separator and we separate them, separate the formation water. After separating, we treat the formation water and again we inject it into the reservoir. So this is the process. And as far as the methodology is concerned, we have collected 20 discrete samples from different wells of Jaisalmer basin and Bikaner-Nagar sub-basin. From among these 20 samples, we have collected 18 samples from Jaisalmer basin and only 2 samples from the Bikaner-Nagar sub-basin because of the limited formation water availability, and also we are producing from only Baghewala field and Jodhpur formation. So these samples are taken care to avoid the contamination also, and then we have analyzed through ICP OES and ICP AES. So let's see the results. So these results in the Jaisalmer basin indicates that the most of the samples are in the sub 5 ppm range, but the maximum recorded ppm is in the range of 15 to 26 ppm that are from the lower Cretaceous clastic Parivar formation. So it indicates that although the lithium is present in the Jaisalmer basin, but it is very unevenly distributed. But in comparison, the only two samples from Bikaner-Nagar sub-basin, from the Jodhpur formation, we have analyzed. Both the samples show very encouraging result, having a maximum concentration of 64 ppm, which can be extractable in the economic condition. So this concentration is significant, making the first recorded potential of lithium from subsurface formation water in India. So now let's compare it with some global oil field brine deposit. So just one slide more. So this is the Smackover formation from the Jurassic oil field brine deposit that's having lithium concentration of 50 to 500 ppm that is explored for extraction, and we are also having our Baghewala field in this range. Similarly, some Chinese oil field brines, that is also our highest recorded 64 ppm is in the lower side, maybe in the lower side from there high, but it's higher than there are many recorded lower potentials. So along with that, also we have the Permian salt basins brine, where also we have a comparable result. So as far as the positive outlooks in Bikaner-Nagar sub-basin is concerned, so it's having, we can explore more, we are now exploring in the Baghewala field only, we can explore more extensive throughout the 70,000 square kilometer area, so it can give a higher resource volume. So based on all these studies, what is our future action? We will analyze as these formation waters we are producing only from Baghewala field and very limited formation water. So we are now targeting the reservoirs which do not have any crude oil or any gas, which is having only formation water. We can analyze them, we can analyze the volume also. So we will analyze the ICPS analysis of formation water, ICP-MS analysis of the clay-rich samples can be also taken, and the mineralogical analysis of the Malani igneous suite will also be analyzed to know the source of lithium in our basin. Along with this, we will pursue the spectral gamma logging to identify the presence of evaporative condition in the basin. Accordingly, we will prepare a base map for lithium with the reservoir age and the depth also. And similarly, we will correspondingly we will build the experimental simulation and empirical relationship based on the pressure, salinity, pH value, and comparing all the results. So these are the future perspective. Apart from these studies, Oil India is pursuing the geothermal exploration also, and we are also analyzing the geothermal hot spring brines in Arunachal Pradesh also. And in the future, geothermal when it will be drilled, we will also analyze the geothermal brines for the lithium concentration analysis. So thank you for your kind attention and giving us the platform to present our case here.
Thank you, Pandaji. Next.
I have one observation, Mr. Panda. In the map, what you have shown, the truncated map of India is shown. So that is not allowed. Maybe in future you can take care of it. This is illegal, that's why I pointed out, because many of us, when we present in conference, we show India map without J&K. So, yeah, so we as Indians should avoid, and that's what I am. So, I mentioned the story of Katepurti, who was a tribal person, and he was helpful in getting the chromite mining in India. The presentation was on oil, and we all know that elephant was the one who helped us to know the oil field in Assam. And so why I brought this together, because the next speaker is from a very reputed think tank, CEW, and I know personally Dr. Arunabha. It is Center for Energy, Environment and Water, and he is going to present on opportunities and challenges in critical minerals processing in India. Yes, Sunil.
7 minutes. So, hello everyone. My name is Sunil Kumar and I work as a research analyst at the Council on Energy, Environment and Water. Today my colleague Vibhuti is also here and I will be making a presentation on the opportunities and challenges in the processing of critical minerals in India. Before that, it's my duty to just give a brief introduction about the organization that I am representing. So, CAW is one of Asia's leading policy think tanks impacting sustainable development at scale with data, integrated analysis, and strategic outreach. To effect transformations in a sustainable manner, we have teams focused on a low-carbon economy, energy transition, power markets, industrial sustainability, and sustainable livelihoods. To enhance the quality of life, we have teams focused on clean air, sustainable water, sustainable food systems, sustainable cooling, and sustainable mobility. To enable these transformations and improve quality of life, we have teams focused on sustainable finance, technology futures, circular economy, climate resilience. We also have special initiatives such as CAW Green Finance Center, Powering Livelihoods, Emerging Economies, and the UP State Office. We are a team of 350 multidisciplinary researchers and are involved in active engagement with 20+ Indian state governments. We are also the official knowledge partner to the Ministry of Mines, and from more than a year, we are working actively with them in the development of policies related to critical minerals. Moving on. So, as suggested by Pankaj sir, I am assuming that you already know, and I will skip the context setting slides and spend just a minute on this slide to highlight what we have conducted the research on. So, we have conducted a detailed study wherein we have focused on analyzing global as well as domestic supply chains of the critical minerals, existing global processing technologies employed at commercial scale, India's current capabilities on processing of the critical minerals, and identifying where what we as a country need to focus on for building a robust supply chain and fulfill the rising demand of critical minerals. We examined mineral deposits and global processing routes of these 15 critical minerals. The selection of these minerals was based on the specific factors as mentioned in the right side of the slide. So out of these 15 critical minerals, 7 minerals are already being processed and produced domestically at commercial scale. However, based on the analysis, we have identified some gaps, challenges, and opportunities in India. In the upcoming slides, I am going to present just only 5 challenges which are cross-cutting in the nature and are also relevant for today's seminar on critical minerals recovery from mine tailings. So, and these gaps are needed to be addressed soon to build a robust critical mineral supply chain in India. So the first challenge is the limited domestic technological know-how, specifically related to the commercial scale. So India is traditionally good at pyrometallurgical operations, which are suitable for bulk minerals. We have a well-established iron and steel industry, along with copper industry. But critical minerals are different. They are often found in very low grades, complex mineralogical compositions, and have multiple metals in a single deposits. So to process these minerals, hydrometallurgical technologies are considered to be more appropriate. Unfortunately, we don't have enough expertise in some very important hydrometallurgical operations. For example, high pressure acid leaching, Gajanan sir has presented on the same before me, which are employed to process laterite minerals for nickel, cobalt, and platinum group of elements. Focus should be on developing skill related to these technologies at commercial scale, such as solvent extraction and ion exchange, which are important for cobalt, nickel, and platinum group of elements. So the figure presented in the right side of the slide is part of the flow sheet of platinum group of elements. And from this flow sheet, you can see that high pressure acid leaching and solvent extraction both are relevant for this case. Naturally, platinum group of elements are present at very low grade, and so recovery of these minerals from their deposits is very challenging. And so if we develop capabilities to process this mineral, this will build the institutional capacity and the memory, which will be also be relevant to process other minerals at commercial scale. The next slide is on the underdeveloped secondary resource recovery framework in India, to which the today's seminar is focused on. So, as you all know, significant amount of critical minerals like cobalt, nickel, and rare earth elements are present in tailings, slag, and fly ash. Right now, we are not recovering them to their full potential because of a lack of awareness and proper policies in place. These valuable minerals are further dumped in dams or minefields. So the flow sheet that is shown here represents the processing of molybdenum, which was also shown by Chandralekha ma'am in her slides. I am glad to hear that they are recovering molybdenum as a co-product, but unfortunately, the molybdenum production in India is almost negligible, and we are dependent on imports for these minerals. So we need to develop capabilities on the recovery of critical minerals from these secondary sources. The next challenge is about getting the right purity of the critical minerals at commercial scale. So processing the critical minerals need very precise control over the thermodynamic and operational parameters, and all these small parameters combined decide the purity of the product after processing. If we don't control these parameters very carefully for each specific type of ore, we don't get good recovery, and the product won't be good enough to be used for clean energy technologies. So the flow sheet represented here represents the graphite processing. In India, we do mine and process some graphite, both the natural as well as the synthetic graphite is produced in India, but these are of lower grade and are used for making some products such as pencils or crucibles or furnace electrodes. But for batteries which require very high purity graphite, right now that high purity graphite is not produced in India, and it is difficult to produce both technically and economically. So the same problem of achieving high purity is there for other critical minerals as well. Those are commercially produced in India, such as silicon, rare earth elements, and other metals that go into batteries. So this is lack of a capability to get high purity outputs at the commercial scale. So the next challenge is on the gap in the perspective of transitioning of technologies from lab scale to the commercial scale. So we have many good research institutes in India and working on critical minerals, developing technologies in different part of the whole supply chain of critical minerals. But the problem is there is a big jump from what happens to the lab scale processes to be implemented at commercial scale. So it's a different ballgame together. In the last few years, the number of ongoing projects focused specifically on critical minerals processing has increased significantly. In the morning, Abdul sir from IMMT was presenting some of IMMT's work on the critical minerals. So this shows that the number of projects has increased significantly compared to 2 or 3 years back. But still, most of the focus on these labs are on the ferrous metallurgy. That's logical as well, considering we have a huge ferrous industry in India. But to boost the production of critical minerals at commercial scale in India, it is required to increase more number of projects in these labs and to scale up to the commercial scale. Also, India doesn't have a lot of past experience or the institutional memory of the necessary research facilities that help in scaling up these critical mineral processing technologies. We need to build this up so we can become self-reliant in this important sector. Now, to do this, more partnership between the research institutions and the industries is required, and the research need to be focused on the applied research instead of academic ones. Thank you. This is the last challenge I will highlight today. So one of the biggest hurdles in developing our critical minerals processing is that we have heavily dependent on the imports to buy the equipment or the machinery that is required to establish a plant, even at a pilot scale or at commercial scale, or the machineries that are required or the equipments, lab scale equipments important for the mineralogical assessments are completely imported. What this does is that this creates delays in delivery times, and we need to wait for a longer period. Secondly, it increases the cost, overall cost. Buying from other countries is expensive. And third, it makes us vulnerable. Suppose if those countries from which we are importing have problems with other countries, or let's say with India, it affects our ability to set up new processing plants in India. Now, another issue is that the equipment and the processes available in other countries may not be suitable for the specific type of minerals reserves that we have in India. So in some cases, the most efficient processing routes could not be implemented to process a specific mineral because we don't have adequate infrastructure. Our minerals might have unique characteristics that require tailored solutions, and for those, we need specific equipments, which could not be fulfilled by those countries. So this problem is not new, obviously, but it's time that we start focusing on this aspect as well and start building manufacturing of these equipments which are required for machineries, for mining activities. Now, after this, there are some call to actions that should be implemented. I will just briefly touch upon them, considering the experts here would be more experienced working on the ground, and I expect to learn from them and receive their feedback. But these call to action are bucketed in three categories: building the capacity, strengthening the existing ecosystem, and building competitiveness. The first bucket consists of focused research and development for innovative critical minerals technologies. Some of them I have mentioned before. Specific upskilling programs suitable for industry requirements, and harnessing secondary resources to recover critical minerals. The next one is upgrading the existing infrastructure for mineral co-processing. As I said, these minerals coexist in the same deposit. Utilizing the existing mineral processing expertise which we have to recover and process those critical minerals. The next is enhancing the energy efficiency in the existing mineral processing technologies, global collaborations for technology and knowledge transfers, and promoting transparency in the critical mineral supply chain. With this, I end the presentation. These are some of our recent presentations. Thank you for listening to me. I am happy to receive your feedback or some questions that you might have. Thank you.
Thank you, Sunil. I know some of you were praying silently when this session will be over, when we'll have lunch. So God has listened to your prayer. An organizer has told me that the next speaker will be shifted to post-lunch session. So, so we'll be closing this. I am reminded of one story of a person. So, कथावाचक हूँ तो थोड़ा लास्ट में कथा और सुना देता हूँ. Fancy word is storyteller. So once upon a time, a person was going to a different place. On the way, he saw many parrots on a tree. So he got hold of one parrot, took him to home, and the parrot was in cage. After few months, he was again going to the same area. So he thought that he will convey to his friends and family members how this parrot has been. And he told, I am going to the same place again and I will convey that you are here. So he went to that area and there were many parrots on a tree. So he told that, your friend is with me, he's okay, no issue. All of them sympathized, no, it's good, but then he's in cage. We have a great sympathy for him. Then he saw one parrot who was little away on tree. Then he thought, let me tell him also. So he went to the parrot and told that your friend is, your family member is with me in a cage. After listening this parrot collapsed. And this guy was mesmerized. I mean, how close he was. That, by listening that he was in cage, he collapsed. So he came back and he told that I met your family members. Many of them sympathized and they told that please take care of him, give him food. But there was one parrot who was little away. Probably he has a great longing for you. And the moment I told him about you, he collapsed. And this parrot also, after listening to the story, collapsed. So this man was, surprised, aghast. So he thought, now is no more. He opened the cage and took the parrot out, and this parrot flew. And he told all those were sympathizers. This one gave me the clue how to come out of it. So I am making this to all my presenters who made this presentation. So they were not giving you, they were not sympathizing with you. They were all giving you clue how you want to use critical minerals, how you want to develop critical minerals in your company. So with that, I thank all my presenters who came. They were prepared. To the audience who were awake, and to my friend who accompanied me, thank you very much.
Thank you. Thank you so much, sir. What a wonderful way of ending this session. This story will definitely stay with us. I would like to thank all the speakers of the session for their valuable insights. Our sincere gratitude to our moderators for the session, Mr. Pankaj Satija, Executive in Charge, Tata Steel, and Mr. Rama Raman Satapathy, Executive Director, Exploration and Beneficiation, Lloyds Metals and Energy Limited. Thank you for not just steering the sessions with such depth and clarity, but also for infusing it with rich narratives from mythology and the gentle reminder of something as simple yet powerful as a smile. You truly made the session memorable. Thank you so much. I would now like to request the moderators to kindly present mementos to the speakers of the first session.
So this is the beauty of conference. Usually in organization, you work for 30 days, then you get your salary. In conference, you get instantly. Please do come.
May I please invite Mr. Aditya Singh, Manager Consulting, Deloitte India. I'd now like to call Mr. Keshav C. Mandal, GM Concentrator Plant, MCP HCL. May I please also invite Dr. Abdul Rauf Sheikh, Principal Scientist, CSIR, IIMT Bhubaneswar.
So the printer can check the memento. Otherwise, IBM would have given you stones from their mineral processing lab.
I invite Ms. Chandrakala Kari, Lead Scientist, Metals and Mining, Hindalco. May I now request Mr. Abhinav Sen Gupta, Associate Director, PwC 1 Consulting, to kindly come on stage. I request Mr. Niroj Kumar Panda, Head Planning and Management Services, AMD, to kindly come on stage. I invite Mr. Gajanan U. Kapure, Head Ferroalloy Minerals Research Group, Research and Development, Tata Steel, to kindly come forward. I invite Mr. Sudhir Panda, Superintendent Geologist, Oil India Limited, on stage. We have on stage Mr. Aditya Singh, Manager Consulting, Deloitte India. And lastly, I invite Mr. Sunil Kumar, Research Analyst, CEEW. Thank you so much. It is time for felicitating our moderators.
I thought you will say it is time for lunch.
I'll say that briefly, sir.
You can postpone this after lunch also.
I would like to invite Mr. Abhay Agarwal, Controller of Mines North Zone, to kindly present mementos to our esteemed moderators as a token of our appreciation and sincere gratitude. Thank you so much, sir. Now it's time that we pause for lunch. I kindly request everyone to return to their seats by 2:45, at which time we will reconvene to continue with the session. Also, I would like to request the speakers of the second session to kindly give their presentation at the designated area on the right side of the stage. Thank you.
6 presentations, and the time is very short because we are already lagging behind. So I will request all the presenters to please keep their presentation within a period of just 8 minutes. 2 minutes we can keep for some question and answers. So I invite the first paper, which was a spillover of last morning session, that is mining waste as a potential source of critical minerals. Chief Scientist / Professor, Head Environment, Emission and CRM Section, CSR Simpar Dhanbad. So I request Shri R. Ebin Masto to please take over your presentation.
So very good afternoon to all. At the outset, I thank IBM and NMDC for giving me this opportunity. Thank you, moderator sir. I'm associated with CSIR, Central Institute of Mining and Fuel Research. So our institute take care of the entire supply chain starting from coal mining to coal utilization, coal gasification, coal cleaning, and recently into coal to methanol. And very recently, CSIR Simfer started working on critical mineral because coal is one of a potential source for many critical minerals. Almost all the elements of the periodic table are present in the coal. So this can be manifested either in the terms of fly ash, can use fly ash as raw material for extraction, or the OB, or even acid mine drainage. Okay. Globally, recent years, there's a lot of efforts in extracting critical mineral from fly ash. There are advanced stages in US. Some startups are working on that. But in India, we have limited information, particularly even in the mapping stage. So far as whatever the data we have, it says coal contain almost 300 ppm ppm of rare earth element, but lignite, particularly the Neyveli lignite, we have almost 3000 ppm of rare earth element. There are few studies from GSI, they say the gallium content is quite high, as well as lithium content in some coal. But the challenge is till date, we don't have any comprehensive database encompassing all the coal fields throughout the country. And thanks to CMPDA, they have recently started working on that. Okay. Why? Almost a century back, a German scientist has published a paper in American Chemical Society that coal could be a valuable source for extracting rare earth. They have highlighted on germanium. In fact, I want to say there are some plants available in Russia and China for germanium extraction from coal and coal ash. They modified the power plant itself so that the germanium get concentrated in particular fraction of fly ash. And the beauty is the combustion phenomena is used for beneficiation. The particular fraction of the fly ash is used for germanium and gallium extraction. So when you talk of secondary source like fly ash and germanium, fly ash and OB dump, we must focus on certain elements whose concentration is comparable with the commercial ore. We can see scandium is a good candidate, germanium, gallium. I will not say the entire rare earth because lanthanum and cerium are quite high in the ores, but scandium is a good candidate for extraction from secondary source. So quickly, what are the work we did? Simfer is started mapping on different coal and coal-based product. And as I said, I'll be presenting in detail. And in lithium, in some mining waste associated with mica also, lithium is quite high. Potash is also high. When you talk of mica, both lithium and potash could be extracted, and we developed some flow sheets. And we put up a pilot plant at one of the industrial site for extracting potash. It's a critical mineral from an sugarcane-based ash. It is a spent wash incineration ash. And since the time is short, I'm going a little fast. Lithium, we did a complete mapping of lithium in Indian coal, but unfortunately, we didn't get much lithium. The maximum is within 40 ppm in the Indian coal, but Chinese, they mentioned up to 100 ppm, and it get enriched in the fly ash. But our exploration should not stop, because all these lithium enrichment is not a generalized phenomena. There could be some anomalous enrichment in some mines, because GSA has found out in some coal seams of WCL area, the lithium concentration is more than 100 ppm. So we did the lithium mapping in the OB dump also. We could get only 70 ppm of lithium, but in mica waste it's more than 1000 ppm. Okay, so quickly we'll go. My presentation will be three-part: rare earth as well as other major critical elements. Rare earth, as I said, fly ash could be one of the potential source for extraction of rare earth. We collected fly ash from different plants across the country. We did analysis and we did some good quality control, quality check. And this is a convention. We can divide the rare earth into critical, non-critical, maybe lighter rare earth or heavier, heavier or more critical. And the Chinese have developed a outlook coefficient. If the coefficient is more than 0.7, this fly ash is a commercial, can be commercially exploited. So when we did the mapping, most of the Indian fly ash, this is more than the outlook coefficient. Maybe the concentration is less, but the critical elements are more in fly ash. And this is the map shows most of the thermal power plants as 450 or 500 ppm of total rare earth element. Particularly the Neyveli, the lignite has more than 1000. Again, in the Neyveli, there are two kinds of mines, mine 1 and mine 2. Mine 2 has almost 3000 ppm rare earth element concentration. And even in the mine 2, there are two combustion technology. One, they use a pulverized firing, another one is a fluidized bed. In fluidized bed, the concentration is particularly enriched in certain part of the fly ash. So I guess this is due to the monazite deposit in this belt, because in Barmer we didn't get that. But though Barmer is a lignite, we didn't get the rare earth element. Okay, coming into the chemistries of rare earth in fly ash, it's a case with lignite and it's a case with coal ash. In lignite, it is easily soluble. We can use any simple acid and extract it, because most of the rare earth are associated with the inorganic, that is oxide bound. But in case of coal, this is associated with the green lines, associated with the hard matrix, that is aluminum silicate matrix. Either an hydrothermal treatment is needed with alkali to extract the rare earth from coal fly ash. Okay, again, other than rare earth, the another important element is gallium. If you see the mapping of gallium, okay, it's slightly less than what we are getting from the Bayer process, but there are concentration up to 60, 50s, and again, Neyveli, it's 100, 80, 100. Could be a potential source for extracting gallium. One more interesting thing in gallium is, if you see the bulk ash, the gallium is only 30 ppm. But you know, in thermal power plant, the ash is collected in different hoppers. The ESP hopper 1 to hopper 10, or sometimes hopper 8. The particles are finer when you go from the first hopper to second hopper. So thanks to power plant, they are enriched and beneficiated in the power plant itself. The concentration goes from 20 to 140, 150 ppm at the power plant itself. So my suggestion for the industry is preserve those ash from the last hoppers. Don't dump it in the landfill or into concrete that are permanently blocked. The valuable minerals. This is not only from one plant, from many of the plants we are getting this trends. Okay, coming to overburden material for today's seminar's interest. When you talk of overburden coal, it's really a complex scenario. We'll get coal, we get sandstone, we get shale, and there are many incidents of igneous intrusions in the coal mines. We get igneous mask and cooked coal or baked coal, we call it a jama. That's because of the high temperature of the igneous intrusion, the coal get transformed, and we get even altered, heat altered sandstones also. These are the big, good material we can expect, rare earth as well as critical minerals. So we did some mapping in major coal fields like ECL, that is Eastern Coalfield, BCL, CCCL area, as well as in Singrauli area. The major challenge is how we are going to collect a sample from a OB dump. So we propose a two-phase sampling. The initial phase, we grab the samples based on the rock type, like sandstone, take coal, jama coal, take shale, or igneous intrusion or basalt, whatever that rock, it's major rock, we can see with your virtual eyes, you take it and do the analysis. That's the first phase. In the second phase, we can go for consider a OB as a deposit and we go for a detailed sampling. So we get very interesting result for 3 group of elements in OB. Rare earth, obviously it is there. Gallium, germanium, as well as potassium, magnesium. This is a good fertilizer material because both potash and magnesium are used as a major fertilizer. And we did sampling in Mugma, Rajmahal, Pakri Barwadi, Sohapur, and Singrauli. Quickly, I'll say only the interesting results. First, coming to potash magnesium, as I said, this is the igneous intrusion, the baked coal or jaman, and wherever there's igneous intrusion is there, the potash content is very high. It is more than feldspar, it is almost 8%, accompanied with magnesium also more than 15%. So in commercially KMG fertilizer is available, and in some European country, they simply pulverize this rock dust and sell as a fertilizer, as a rock dust fertilizer. We don't have that process. It can be easily processed and get an economic income out of these rocks. And you see, this is the dolerite, igneous intrusion. Above is altered stone, that is heat altered sandstone, and this original sandstone. Okay, and this is some of the result for CCl obidum. Iron is also quite high, but lot of variability. And magnesium, potash is there. And looking into chemistry, again, most of the potash is associated with the silica aluminum matrix. It is very difficult to break it, and we have to develop some hydrometallurgy technique to extract potash and magnesium from these rocks. This is a challenge. Coming to rare earth, again, I am presenting a base of the rock-wise. Heat-affected rocks, 350 milligram is a maximum, and scandium is less than 50. Shales, it's a very good source, more than 50 milligram of scandium. Total is there, but total it may not compete with the monazite, but when it targets scandium, it could be a good reserve. And sandstone, the concentration is quite less. Coal is very interesting. Scandium is 20 in coal, but when it gets burned in the power plant, it gets enriched because the ash content is 30 to 50%. So mass balance, if you see, the concentration increased by twice. And again, in the power plant ash collection system, it increased by another 5 to 6 times. Okay, it's a summary slide. See the red one or the sandstone, the concentration is not very high for rare earth, but in coal it's high, but again it get enriched. Coming to shale, it's really 1500 ppm in a particular mine, Sohapur, near Singrauli. And again, Singrauli, dolerite also, these are 2 igneous intrusions. Among the igneous, there are 3 types of igneous intrusions, basalt, dolerite, and lamprophyrine. Lamprophyrine has good amount of rare earth. And wherever rare earth is there, it's accompanied with high content of potash and magnesium also. Okay, if we have time, I can go through the data. Okay, fine. So there's good amount of data is available. Okay, what's the challenge now? How do we get a representative sample? Maybe SIMFAR will will report some result. Tomorrow IBM will do a different sample strategy and we'll get a different result. So GSI has initiated a core group on developing an SOP for sampling overburden dumps. We need to really brainstorm it, how to do a sampling. As I said, coal and associated coal mine waste rocks could be a good source for critical mineral, and it can be enriched in fly ash as well as in the overburden material. And the other advantage is it's a non-radioactive. If you want to extract from monazite, it's a radioactive, but fly ash, coal ash is not radioactive, it's quite easy to extract it. And more policy and detailed deliberation should be focused on how we are going to do the sampling and extraction strategy. Thank you. Thank you, sir.
So thank you, Dr. Masto, for your wonderful presentation. As you know that Central Institute of Mining and Fuel Research is one of the pioneer research institutions in mining and mineral sector of India. And in his paper, he has highlighted that all the elements of periodic table can be available in coal, and that's why the coal can be a potential source of our extraction of critical minerals. So thank you very much, and if any questions are there, we will take up at the end of the session. Would you like to comment?
Good afternoon. Now the second speaker is Mrs. Shiva Masruwala from Hindustan Zinc Limited. She is head of R&D division. The topic is potential for critical minerals extraction from tailings. A general overview. Madam, please. Time is limited. Kindly complete your presentation within 8 minutes. Thank you.
Good afternoon, all. So I would like to highlight some new points because since morning we are listening to what are the challenges and what could be done. So I will try to, keep my presentation in lines with what new points could be added to the since morning what already has been discussed. So just the prospect of critical minerals in India. These are the references I have taken from the Deloitte report. So thanks for that, I would say, to Deloitte. So I wanted to highlight that these are the what are the projected requirements, and definitely we need to work on cobalt, nickel, lithium, REs definitely, and we are very much import dependent on these critical minerals. This is just an overview of our processing, but yes, I wanted to highlight more on the quantification and the phase characterization, because that is the need of the hour, that we analyze and see where the characterization is being done, and based on that we think that what should be the technology which needs to be deployed. Coming about the challenges in the critical metal extraction, since morning we are discussing it, so we wanted to highlight that the mine tailing compositions, that has to be characterized very properly, and based on that the technology is done. So technological shortcomings is also the one of the thing, that unsuitability of the existing technology is what we are aware of. Mainly it's related to high grade ore, and what we are having are the very low grade ore. So what should be done, the tailor-made processes should be there. Need of self-sufficient process running. I think Sunil has highlighted this from CEW, that it should be self-sustaining. It's not that we are dependent very much on the type of technology with respect to the reagents requirement, like a lot of solvent extraction is required, but we are still dependent on the reagent availability on China or other countries. So that it is required that we become self-sufficient in these resources also. Economical feasibility, definitely this is the main point, that it should be economically feasible. I would just like to highlight the example of cobalt, that being from an R&D from Hindustan Zinc, we have worked a lot on cobalt, and we were able to generate some residue having about 40 to 50% of cobalt. But what happened, the prices just dropped. It was done in 2018, which were the prices was around $80,000 or something like that, and then now it dropped to 30 to 25, and then it doesn't become economical. So those things are also one of the aspects that we need to work on. Environmental concern, of course, with tailing, these are the issues, of course, and specialized skill unavailability, because it's very much required that the specialized skills and the requirement are available. We are very well aware of what is required to extract these minerals. This is just an example of some of the tailings, selective tailings, which contain these critical minerals. So highlighting cobalt, if you just see, if it's visible, it's like even in that mine tailings, about 4% of zinc is available, zinc is there. Along with that, the cobalt percentage is about 1.15. So that is the type of tailing being available. And here, if we talk about, maybe in it is being taught that it is available with zinc and all, but when we try to analyze it, and the numbers that we have seen, it's really like less than some 20 ppm or something like that. So it's very much important to see that what is available, and based on that we decide that how the extraction should be there and what characterization should be deployed, and based on that we have some technology for extraction. Now, I just wanted to talk about the advancement in the quantification techniques, because right now we are relying more on, FESM related and ICP related type of things, but there are not many non-destructive techniques like what I've pointed out. It's like the micro-CT computed tomography, spectral CT, and LIBS and XS. Each technology has, the quantification has its own benefit and all. So just like micro-CT, it is ideal for grain size and fracture analysis in tailings and ore. For spectral one, if we say it is useful in distinguishing mineral faces with similar densities. And the 3D image is being created, and based on that we can decide on that what should be the best characterization thing that we have to employ. LIBS, it's a laser-induced breakdown spectroscopy. So in which the laser ablates a small amount of material and plasma emission is being analyzed. So it's useful, very much useful in identifying in situ detection of the critical minerals like lithium and rare earths also. X-rays, it gives a chemical state and determine the oxidation state and the coordination environment. And this is very much valuable when we talk about arsenic, zinc, and copper in tailings. All these are mainly the non-destructive type of techniques that can be employed for the characterization. How competent India is or our teams are, it has to be seen that we can do all these techniques can be employed. Based on that, we analyze what type of tailings we have, we characterize it, and then we think of the extraction. And this requires, of course, collaboration and a huge investment that needs to be done, just for the characterization and understanding that what is available in tailing. Some of the technological advancements, some of my colleagues has already talked about it. So some of when we talk about hydrometallurgy, acids are available, chloride, leaching, ammonia. But when we talk about, solvent extraction related things, of course, what I have said earlier also, that these reagents, we are very much getting dependent on other countries also. So that has to be seen that we are, self-sufficient in terms of availability of all the resources that is required for extraction. Pyrometallurgy, again, if we are very much dependent on, equipment-related things and some other technology, then again, we are not that self-sufficient. Bioprocesses, there are some case studies in which bioflotation, precipitation, hydrometallurgy, all these things are talked about. And these are very much utilized for when we have, very less ppm of materials, elements in that. Flotation, of course, for flotation being in Hindustan Zinc, we are working on zinc clad flotation a lot, but that the similar thing when we talk about rare earth or something specific, it's we are not that much capable. We can definitely accept that. So that is the thing we have to work on. Also, based on quantification, we have to see what should be the sequence, because these technologies are available. But what is the major sequences, how it is to be aligned so that it is economical for our process and make the complete value chain economical, that has to be seen. Now, these are some of the case studies on critical metals. Already some teams have talked about it. But yes, if we see the highlighted one, that is the efficient bioreduction acid leaching, which is done for the waste rock. Battery-grade lithium was extracted from waste rock plant in USA. And some of with respect to tailings, if we talk about a flotation process to recover copper from the tailings. Lead zinc mine in China, they have worked on it so that they can recover copper, lead, zinc, and iron using sulfide precipitation bioleach. So there mainly the highlights are with respect to bioleaching. Even for the last point, if we can see on the right, that is the strong magnetic separation, flotation, followed by treatment in iron tailings, from which they were extracting vanadium. We also tried at lab scale for generating of vanadium from the spent catalyst. There was a project along with the animal team. So we did it, but the cost was very high. So, as such, the resources are available. The speaker just before me talked about that the fly ash has like the periodic table, and it's much more viable to, extract from that. So we have to see that from which tailing or which type of waste rock for which should be utilized and economical to take out the relevant critical mineral. This is just a chart showing that along with which type of ore or mineral, what more critical minerals could be coming. So for lead and zinc, if you can see, there are talks that, in some of the ores it is available. We have cadmium, germanium, gallium, all those are available. But looking at Hindustan Zinc as of, we are very much focused on, zinc recovery from our tailings. So Rampura Agucha is the highest grade of zinc available in that. So about 12% of zinc is there. So that tailing is having about 1 to 1.5% of zinc. And still we are struggling in identifying the technology that can be helpful to recover that zinc. So talking about furthermore minor critical minerals and minor metals in that is of course a second story to look upon. And definitely after this seminar, there are many thoughts which are coming along with all the speakers, that what all could be done for those extraction. So this is just a mineralogical example of Rampura Agucha tailing, that even for the zinc, that we know that it is having this much of zinc, it's in a very fine, we have to go up to 18 micron or further sizes. That has to be done. A fine grinding has to be done just to recover then. And then the flotation process will be there to recover that zinc that's spellrite in that. So complete technology has to be upgraded in that sense if you are planning to work on the tailing side. One more area majorly I wanted to talk about, which I think since morning we have not discussed, is how to use AI for this. Because when we talk about a specific type of characterization that is being done, a whole investment will be done, and we will be getting the characterization, how the changes has been done in tailing, how the minerals has been moving along over the period. So those things get impacted, and for that, artificial intelligence will be used. So for the first one, the blue one chart, which is mainly showing how we use AI in the existing model. Still, this is not in that mature stage. We are using some process controls and all, but it is important that we utilize it in the full nature. Similarly, it can be used for critical minerals. So whatever is being done at, whatever data is being generated, right now we are working a lot on this, and there are a lot many frameworks being developed and the policy is making. So we should be working that how to utilize artificial intelligence in these cells, whatever data is available, how to utilize it for the extraction also. So that would be very helpful. And that's all from my side. Maybe just I would like to conclude that at this point, when we are talking about the framework and policy, we should definitely consider the economics and the market price fluctuation that I have talked about, like in cobalt case. Right now, what I can see from morning itself, we were discussing that we have a matrix for India, that what is the requirement for critical minerals. But right now, when we are discussing about whatever technologies are available, what we can generate, some estimations have been done. So it's important that we talk about the capability matrix also of Hindustan Zinc, superimpose this capability matrix on our requirement matrix, and then we decide on what should be the strategic goal and prioritize on what are the real elements we have to work on and work on the extraction. Thank you. Thank you, sir.
Thank you, Ms. Shiba. A very good presentation. Ms. Shiba is a head of the R&D unit in Hindustan Zinc Limited, and she has highlighted what are the potential for extraction of critical minerals, especially from the non-ferrous tailings. She has presented in her paper challenges for metal extraction from the mine tailings, then what are the advancement, and she has also emphasized the use of artificial intelligence, which is now the era of AI. So AI can be useful for extraction of critical minerals. So they are also working on these aspects. And thank you very much, Ms. Shiba. Now we will go to next paper.
Yeah. Next paper is by Dr. Manish Chandra Srivastav, R&D, Vedanta Aluminium. The paper is Critical Mineral Extraction from Fly Ash and Red Mud. Please go. Time is 8 minutes, please.
Yeah, thank you. A very good afternoon. Well, I'm from Vedanta Aluminium. We are into aluminium business. Basically, I'm from aluminium side, and I'm posted at, I'm looking for sector aluminium, and I'm in Jharsuguda at the moment, Odisha. And well, I would be talking about fly ash and red mud, but this has been the topic from since morning, I've seen. So maybe a lot of you might be feeling a bit bored, but I will not take long. I will try to finish it so that it fits in well with the program as well. Yeah. So just 1 minute, I will just take about my company. We are having interest in aluminium, copper, zinc, lead, silver, oil and gas, iron ore, steel, commercial power, and we are getting into semiconductors as well. So we have a huge plans, and we have a huge, our chairman has a huge dream, big dream, and he challenges us, and we are very much into that. And we recently we are getting into expansion program as well. Our businesses are getting also divided into different sectors. So that has already come out in the news. And we are getting into more and more into green aluminium as well. We are getting into, as our smelters are operating on electricity, so we have our own captive power plants, but we are getting into green powers and try to reduce our carbon footprint and those stuff.
These are some of our just aluminium business. We are into Korba, then Jasugoda, and we are into around 1.8 million tons. We are producing aluminium at Jasugoda. We have a Lanjigarh refinery. We are getting into expansion mode there as well. In Balco as well, we are coming up with a new pot line with a higher amperage. So that's a quite big thing. So what I'm going to talk about is fly ash and red mud. We also call it nowadays, it's a bauxite residue. A lot of people are calling red mud as bauxite residue. So the critical minerals, if you see that if we get some ores out of that, so we get out from, take out the material from there. Otherwise, we have secondary source, we have tertiary source, we handle the batteries, we handle whatever we have used it, we just recover those things. So I will just touch upon this fly ash and red mud. So these are some of the, these all of you know, and we have discussed it in very detail, so I will not get into that. But the things which are of interest, and this fly ash, we burn this coal. As we have heard, we have different grades of coal depending on the mines where we get from. And that in turn has different kind of rare, and the amount of the rare earth materials, okay. So some people say it's 400, 500, 600, even 1000. But that's a very thing that we have to see. We have two types of ash, fly ash and the bottom ash. And that also it's a bit different. And what we can see that from our some analysis that we can get gallium, germanium and scandium. This could be the source. We have a lot of huge piles of fly ash. We are using it in different, we are using it as a minefield, we are using as a cement replacement, we are using in agriculture also we are evaluating how to use that in the construction, in the bricks. So these are some of the areas, but if we can get some value out of that in terms of gallium, germanium, scandium, that would be a great thing. And as you know that gallium and germanium, it has to be used in electronic solar cells, so that is all known. And scandium is one of the things which we can use as an aluminium producer, and then it can be used as a very, in aerospace alloys, you can say. So it's a very good element if we can able to use that scandium into that as well, apart from the electronics and the mobility sector and those stuff. These are some of the typical analysis if you see, but typically fly ash has around 20-25% alumina. Some people, some of our colleagues were talking about getting alumina from the fly ash. That also is a good thing. Yeah, we would like to have that as well. So I will not take much of your time. So this is basically how does it, we try to get gallium and germanium. This is just based on some of the studies. Like we would leach it. Leaching is the very common thing what they do, either alkali or acid, they leach it, they try to dissolve your gallium and germanium into that leachate, and then they use the solvent extraction. For that you have different multiple stages, and then you need to have those kind of specialized reagents that could be used in your extraction part, in your stripping part, and then you're getting into the precipitation part. So it's a whole lot of organics involved into this, and a lot of literature is available, but still we are, in India, we are hanging around. Still we are waiting to see that some commercial process takes off. We have been in touch with some of the Chinese manufacturers, but still they are also quite reluctant on because of our contents are quite lower side from what they have at their process. They are very much interested, but somehow they are telling that commercial viability is an issue. So we have to be indigenous on this, and we have to develop on our own. This is one of the process. There are several processes, but the idea is same. You dissolve it, you leach it, you then use solvent extraction. So these are some of the things. This is one of the pilot plants they have worked on at Spain. So this is what they have multiple reactors, and then they do in stage wises. So they are able to generate it. But one of the main thing is that this has to be customized You have to rework the flow sheets so that it is adaptable to the low concentration fly ash which we have. So this is some of the things which we are working on. So still, so then I will just come back to bauxite residue. Here also we are into a consortium which we are working, that it was mentioned that along with IMT, NML and Hindalco and NALCO, National Aluminium Company, we are all working, and still we are yet to see that whether we are going to the next level or how do we go about that. So this is some of the typical analysis. So these are some of the rare earths which are present in the bauxite residue which could be of interest: scandium, cerium, lanthanum, niobium, yttrium, and it varies a lot. It varies a lot depending on the source from which it's a central India bauxite, or it's eastern India bauxite, how it is that, or we are getting it from outside Indonesia or some other place. So that is a different thing. These are some of the typical levels of scandium, lanthanum, cerium. Some, it could be more, less. So we have to develop technology which suits this, and then only we can see that how we move forward on this. There are many work which is done at the lab scale. So it is very important that now is the time that we need to come out of this. We need to see how we put all our resources, all our expertise, which are at different pockets. We have to consolidate all that, and we have to help each other, actually. So that all those things which are talked about, there is a gap between academia, industry, government policies. So we need to, if we need to come out of this crisis, we have to come together. And definitely, if we come together, we can definitely make it. It's nothing a very big deal, because all those processes are in the, it's there in the literature. Only thing is that we have to optimize it as per our natural resource, as per our inputs, whatever we have. Again, here also in red mud, same things come together. Many people are into this. They produce just iron out of that. Around 30% they produce iron. But that doesn't give commercial viability to the process. We have to have the rare earths if we want to get into the commercial viability. We have a lot of dumps of red mud, bauxite residue. So we need to have that, we have to get into this. There is also, the titania could also be taken out, but it involves a lot of, like if you see how do they take out rare earth and titania from red mud, they use a lot of concentrated acids. And then acid baking and those things at temperatures 400 degrees centigrade, H2SO4, very concentrated. So it's a totally different game. We have to, if we have to, we have to be interested into this. We need to, okay. Okay, no problem. So this is what, these are some of the main thing is that it's not so easy. In the analysis, we see the alumina is this much, Fe2O3 is this much. So we see, okay, I will separate this, I will separate this. But mineralogically, if you see, they are quite interlocked in each other. So that is the game, how we have to understand how each, the ores of each area, how they are interlocked. We need to see that we get the, we can separate them in commercially viable way. Yeah, that's all I think. Maybe if we meet sometime next, we will try to get more deep into this. Thanks a lot. Thank you.
Thank you, Mr. Deepak. There is a concept of industrial ecology. So one waste material of one industry can be a input material for another industries. Likewise, yeah.
I'm Manish.
Yeah, I'm Dr. Manish only I told. Yeah. So likewise, this concept of industrial ecology, we need to rethink that fly ash, which was once upon a time a very environmental hazard. Now it is being used as a input material for making cement industry. And also this fly ash, there is a guideline from Ministry of Environment, Forest and Climate Change that this fly ash is being used as a backfilling material in abandoned mines. But if you look that the fly ash can be a potential for extraction of critical minerals, we may have to rethink on this aspect. So thank you, Dr. Manish. for presentation, and then we'll go. Yeah, please.
Dr. Manish C. Srivastava has to leave due to some prior engagements. Therefore, I would request our moderators to kindly present memento to him. I'd like to call on stage Dr. Manish C. Srivastava, Head Research and Development, Vedanta Aluminium.
We now invite Sri O.P. Somani, Vice President Explorations, Ramgarh Mineral and Mining Limited, Balgota. The topic is Tin Slag from Bastar, Malkanagiri Pegmatite Belt, a source of niobium and tantalum. Please come.
Good afternoon all. My name is O.P. Somani. I work for Balota Group. Previously, I worked in Atomic Minerals Division, Government of India as scientific officer. Regarding our company, it's an iron ore mining company. We have a pelletization plant and setting up a steel plant now in Koppal, district of Karnataka. We have also invested in exploration, mineral exploration, primarily in rare earth and gold. So we have developed one rare earth deposit in Barmer district of Rajasthan, and also developed this gold prospects in Gadag Cyst Belt, that is also in Karnataka. So I will be speaking on this topic. This is my work when I was in AMD. This work is the result of my Bastar assignments from 1990 to 2000. So this is the geological map of Bastar pegmatite belt. It's 80 kilometer long, starts from Dantwara and ends in the Malkanagiri district, Odisha. A very small part is in Odisha, mostly it is in Chhattisgarh. The width is around 10 to 20 kilometers. The beauty of this pegmatite belt is a museum of minerals. I have walked all through 80 kilometers and length and width. I found number of tin-bearing pegmatites, number of columbite tantalite-bearing pegmatites, number of lithium-bearing pegmatites, and beryllium, and all these things, rare metal and rare earths we can think of, these all are there. But unfortunately, this area is now eclipsed with the insurgency. No one can enter. If you find lithium, lithium will be there. So this is the problem the exploration geologist is facing. So this is difficult to explore in present days. At that time, some problem was there, but not that much as we have now. So these are the, this is actually the map, detailed map from this Kawargaon in the northwest to southeast. We have the Odisha, this Mundagoda sectors. Number of innumerable pegmatites are there, and they all contain mostly 70 to 80% pegmatites are mineralized pegmatites. Some are very high, very rich, and some are medium, some are very poor. But something, all these pegmatites are all fertile pegmatites. So we have done some sampling. I mean, we have done a lot of exploration, but from this present topic, we found some importance of niobium tantalum apart from primary pegmatites in the tin slags that is actually being smelted. That time it was smelted by MP State Mining Corporation Limited. All this tin concentrate was brought to their plant in Raipur, and they were smelting it. So we sampled those tin slags. So before that, I will like to show you that how exactly the pure cassiterite has this, chemical composition. We have niobium, good concentration up to 0.6 to 7.9 and 8. Tantalum is very high. This pasture is, totally tantalum-ferrous pegmatites, we can call it. Tin is there, of course, it's tin mineral, and some amount of tungsten is also there. Uranium and thorium is there sometimes because of the niobium tantalum associated with the tin. So we have actually analyzed this tin slags. So we found that this niobium and tantalum in tin slag is very high, just like we find in some of the minerals. You can see here niobium 6.2, 4.6, 3.9 like this. So average is 5.18 and tantalum 14.95. And tin is also there because of some inefficiency in the smelting. Uranium and thorium are also reported because of this association of the atomic minerals in that particular tin belt. So these things will come in the tin slag. So if you look at some other minerals like ixiolite, columbite, woodkinite, and tin slags, so there actually this slide is to show, apart from niobium tantalum, we also found a significant amount of scandium. So as we heard today, the scandium is very important metal, particularly for defense aerospace. Defense people are always looking for scandium. So this, some of the minerals in Bastar pegmatite belts contain very high scandium, 0.48%, 0.33%, 0.52%. This is how the analysis goes. And the tin slag subsequently is also given very high scandium, that is up to 92 ppm. So this is can also become a good source of scandium apart from niobium and tantalum. So now how actually important the area is. So we also analyzed that whether this melt or the particular minerals, the rock forming minerals, apart from the minerals which are like multiple oxides, niobium, tantalum minerals, ixiolite, columbite, tantalite, other rock forming minerals, say muscovite. Muscovite also contains very high scandium. Some of the granites also contains up to high scandium, that is 10.7 ppm like this. So this area is fertile for tin, niobium, tantalum, as well as scandium also. Apart from lithium, lithium is also there. So now we compare this tin slag from the various countries. We have tin slags reported from Australia, Zaire, Thailand. We have added India here. So all these tin slags contain niobium, tantalum, but the Indian tin slags is found to contain highest niobium, tantalum, because the source itself, cassiterite itself, contain niobium and tantalum, and associated columbite tantalite with the tin concentrate when it goes to the tin smelter. So this is how this tin slag is becoming important. Now this is a flow sheet. Actually, I wanted to highlight how this tin slag can be treated for extraction of niobium tantalum. The process is same like we have the treatment of columbite tantalite. You have to go for solvent extraction first by leaching. That is a high, high acids, we call hydrofluoric acids, or very high concentrating acids required, because this niobium and tantalum minerals are refractory minerals, so you require very high, concentration acid like HF. Then it will be leached through, then solvent extraction using tributyl phosphatenol. And it comes in the organic phase, and then from organic phase it is to be brought in the aqueous phase, and then it is precipitated. So this is how the flow sheet is. This flow sheet is very simple. It's not very complex technology. So now we talk about how much resources available in the Bastar pegmatite belts. GSI has worked in major clusters like Katakalyan, Tongpal, and Bacheli sectors. So they estimated some 20,000 tons of tin. But that tin they estimated only in alluvial and colluvium placers. They have not touched any primary pegmatite. You can imagine the alluvium or the colluvial deposits contain this much of cassiterite, how much will be there in the primaries. So one has to go into the exploration of the primary pegmatites selectively looking into the size of the pegmatite. If they are big pegmatites, they should be drilled fast. Like this, one has to plan the exploration, provided we are able to enter that area. So as I said, there's a huge potential of niobium, tantalum, tin, lithium, and beryl. Then scandium as a byproduct, as I said. Now this is, just to show you what is the use of niobium and tantalum. Niobium is actually used as a ferroniobium. So it's a structural material of ferroniobium, and then why it was atomic mineral? Because it is used in the nuclear industry to make zirconium. So zirconium plus some amount of niobium makes zirconium, which is used for cladding nuclear fuel in the PHWR reactors. And tantalum is, as you know, it's very high performance capacitor. It's very costly metals, almost $200 per kg. Scandium is very useful, as I said, for defense aerospace. Our country is looking for scandium, very costly metal. I learned from somewhere that 1 gram costs $500, the scandium metal. So one should look for scandium. So this is the actually result from, presentation is from our presentation we have published in the Current Science in 2000 and then 2005. So, thank you.
Thank you, Shri Somani Sahab. It was a very good presentation. Actually, you know that the Bastar region of Chhattisgarh state is the only potential for extraction of tin in our India, and there is a possibility of extraction of niobium and tantalum like critical minerals from this tin slag. So this research can lead to a good discovery. And thank you for Somani sir for your good presentation. Now we'll move to the next presentation.
Yeah, now invite Sri Saurabh Kumar, Ferroalloys Minerals Research Group, Research and Development, Tata Steel. The topic is extraction of critical minerals from tailings and overburden dams. An investor's perspective. Please limit your time to 8 minutes.
I will try to that. So my designation is a bit changed. I'm head raw material strategy, so it has been wrongly written there. So I'll be covering a few perspective of investors, right, related to critical mineral, right from the auction to the extraction that we are facing. So our discussion will go in the manner it has been shown, a brief introduction, then where we stand and the factors which are determining the critical mineral ecosystem. So if you see the growth and demand, the import that we are getting from FY21 to till date, it has increased almost 2 times. And as per the report, the critical mineral is going to have 4 times growth and 4 times demand will be there. So if you see the entire value chain, the critical mineral right from the exploration to mining to processing, then advanced manufacturing and the recycling. So investors are, some of the investors as per their expertise and as per the whatever expertise, they will be investing in the value chain. Some will be confined to the exploration, some to the mining. Some may have a standalone processing unit, some on the entire value chain. So based on their expertise, they will invest in the value chain. So we will be seeing what are the challenges that they are facing in the entire value chain. So there are many regulatory changes that has already been there. So it has actually helped in investors also to come up for this investing in this critical mineral. There are many focus drives by the Geological Survey of India, and then many friendly policies are already been there. Then government is securing overseas assets, but there are some gaps which we are still seeing in the critical mineral in aspects. This is related to an auction a bit slight different from what it is. The topic is in the auction that we are facing. That if you see, this is one of the block that has come for auction, and the data that we are getting is for G4 stage with no numbers of, there is no subsurface information, there is no resource, and there is no data on the land. So if you are asking us to invest in this type of asset and doing the valuation, that would be a very difficult for any investors to go and auction and participate in the auction. And that we have seen in the lithium that is there, the most famous lithium deposit of Kashmir. Then going forward, there is no report, no feasibility study, no liberation study that is being provided. Let it be a critical mineral, let it be the iron ore. So that has been a challenge, where to invest, how to evaluate these deposits. So we are still facing and still puzzled whether we have to invest or not. This is the type of blocks that we keep getting. A block having road passing through this block, electrical transmission line is there. So sometimes the resource is so huge. Just for give you an example, in iron ore, it has been said that there is a 200 million ton of iron ore is there in this block. And when we get into the reserve, it hardly 40-45 million ton is there because of the blockage that we get because of this highway, because of the transmission line. And if government is not helping us in diversion of these things, then the natural resource will be tapped as we will be going forward. Now, coming on to the policy framework related to the tailing extraction. In the morning also, many have told that there should be a mapping of the resource that is there in the form of tailing. What is the quality and other aspects should also be there. There should be a repository which would say how much secondary resources are there in India. Secondly, in the economy of scale perspective, there are some there are many deposits which are having deposits. There are many mines which are having the tailing, but they are not very huge. So establishing a processing unit or refining unit in each of these mines would not be economy. So there should be a centralized unit where we can have this processing and extraction facility. So investment on these need to be there. So there should be a supply chain robustness so that a centralized unit can work in a economical point of view. On the regulatory and statutory framework, there is still not a clarity on the policy how the tailing need to be transferred from existing mines to a person who has got the expertise. Let's say, just to give you an example, if someone is having a coal mine and they want to give that tailing or the overburden that is there to the third party who are expertise in extracting that ore, how these things need to be transferred is still not clear. If a captive coal mine need to transfer that, he has to give all the royalty, DMF on the tailing, along with the additional amount that has to be paid. So it is just increasing the cost of the tailing that we are going to extract. Secondly, if it is an auction mine, then bid premium will always be there. If we are going to take out any of the tailing from a mine and dispatch it, then it will attract the same amount of bid premium that has been there. So having a primary mineral and then the secondary mineral, both of them attract the same type of bid premium. So this has to be reformed so that more economical perspective should be there in this format. Then on the waste management, if you see, we have faced a challenge that we have a plant-based beneficiation unit. There, if we want to extract more of the low-grade material from that tailing, then how the waste that is getting generated, how to dispose that material. There is still not much clarity on the policy, how this has to be, this waste has to be managed. So this is a major challenge that we are facing. Then again, this waste, this has to be, there is always a buzz that a dry disposal of waste need to be there. But still there is a lack of technology how to have a dry disposal of this waste. And since if the dry disposal is not there, then a dam has to be prepared, and then again the issue of environment will be there, issue of the land would be there. So these are some of the issues that we are facing in the waste management perspective. Many technologies perspective have also been given. So there should also be a repository where we need to understand what type of technological point of research is going on. So there should be a central repository related to the technology. We also think that if there is some scaled up technology across the world, then it has to be simply implemented, and there should be a means how this can be directly implemented and given to the, means it has to be implemented in India. So that this timeline that is there in getting a technology in-house will be reduced. And also, if there are some institutes which are doing the technological R&D, so how much that technological readiness is there, that should be there, and what is the timeline when these technologies are getting scaled up. That has to be put up in a repository so that the investors can have an idea of where and how the technological R&D is going on. So these aspects need to be these gaps should be filled up. On the analytical support, we feel there's many laboratories are there. There are good laboratories already there, but more laboratories has to be established, because we have seen the cycle time is very huge. If you give us some sample to do the analysis and other feasibility study, the cycle time for getting the report is very high. It almost takes 6 to 8 months and sometimes more than that. So more laboratories need to be there. And last and not least, there should be a vertical integration is required to have a business case, and government should make some offtake arrangement around that. So these are some of the points that we feel that as an investor, there should be there in the policy framework. That's all from my side. Thank you.
Thank you, Shri Saurav Kumarji. So far, we were listening from the scientist point of view that what are the potential for extraction of critical minerals. But this paper, in his paper, he has presented what is the investor's perspective, how to, what are the challenges being faced by the industry and how to overcome. So it was a very good paper. We can to think for policy changes. Thank you, Mr. Saurav Kumarji.
Thank you, sir. This concludes our current session. I thank all the speakers for their contribution. We are grateful to both the moderators for moderating this session with such depth and direction. I kindly request our moderators, Dr. Y.G. Kale and Dr. K.C. Brahma, to present mementos to our speakers. I would like to invite on stage Mr. R. Eben Masto, Chief Scientist, Professor Head, Environment Emission and CRM Section, CSIR. I also invite Ms. Shiba Mashruwala, Head R&D, HZL. I invite on stage Mr. O.P. Somani, Vice President Explorations Ramgarh Minerals and Mining Limited, Baldota. I also invite Mr. Saurav Kumar, Head RM Strategy, Tata Steel. Thank you, sir. Thank you so much. To express our gratitude, may I please request Mr. Pukhraj Nainiwal, Controller of Mines, East Zone, to please present the mementos to our moderators, Dr. YG Kale, Controller of Mines, Central Zone IBM, and Dr. KC Brahma, Project Director, Copper Project, GMDC. Please give a huge round of applause. Thank you so much, sir. We now take a brief tea break. Kindly ensure that you're back by 4:30 p.m. so we may continue without delay. Thank you. You're requested to please proceed to the refreshment area. I invite our moderators to kindly come on stage. May I please request Mr. Sudhanshu Patni and Professor Kriti Kumar Randive to occupy their seats on the stage. Thank you, sir.
Good evening, everyone. So we are in the last session. I hope all are still fully energized. Am I correct? Am I get some response from? That's great. Still, some of them are waiting to be more energized with the speech from Dr. Upendra Singh. He is going to present on extraction of critical minerals from secondary waste. I am very sure it's going to be a very interesting topic. I invite Dr. Upendra Singh.
Dr. Upendra Singh Saab, for those who stay in Nagpur, they don't need his introduction. He is very well accomplished scientist. He is working extensively on extraction of REs, and he handles the big projects. And he is the person who is instrumental in setting up very nice facility at JNRDDC. And through our personal discussions with Dr. Upendra Singh, it's always very enriching. I always learn new things from Dr. Singh, and I'm very sure that all of you will enjoy his lecture.
Sir.
Dr. Upendra Singh, please.
Sir, thank you so much. A very good afternoon to the audience, respected moderators, sir, honorable audience, and my friends. So, after listening since morning on critical minerals, it becomes very critical for me to talk something more on critical minerals. So, so now I will try to distinguish between whatever presentation has been made in the morning session and afternoon session. But most of the things will be common, except some of the things which we have done in our own research center, Jawaharlal Nehru Aluminium Research and Development Center, which I think it will be new for you, because we are in the basic research for the extraction of critical mineral from different wastes. So that is why the title is the secondary waste, is the extraction of critical minerals, which is we have taken around 5 critical minerals, and these are almost each and every mineral is as a project. It's not like we are working in a silo. We are working different as a project, and I will show one by one. Since time is a limiting factor, I will try to finish quickly. So introduction part I don't think needed, but one thing I would like to tell you that Government of India and Ministry of Mines has initially identified 30 critical minerals, but out of 30, 24 has been selected for the auctions. So now what we are talking about 24 critical minerals. So that is what the need of our, and why it is important, critical minerals, because of not only it was not known, we are working on these minerals, but we are not known as a critical. Now it is critical because of some reason which I will talk in the slides. So why it is declaration is there? Because of the strategic and economic importance, one had to think that why it became critical. So one reason is economic, another is strategic. I think you might have seen for the last 2-3 days our technological advancement and the border side, because there was a S-400 and all these things. So these are the things which are need of our, that how we will be independent from these minerals. these minerals we are importing from outside. I think we are 100% import dependent on these kind of minerals. Only some of the minerals which are there and we are able to produce for our domestic requirement. So you can see US has put, it is already done by outside the country. Like US, you can see 50 minerals they have decided, they have identified as a critical. Japan has 31, UK has also 18, and India has just identified 30 2 to 3 years back, and now 24 is being in the auction phase. So this is how, this is a periodic table, but you can see the brighter one is selected for the our purpose in India requirement. Next is you can see that the import dependency. You just see these slides might have not shown by others, but if you can see lithium is now, I think resources are there. Some resources has been recently found in Kashmir region, but still not in the stage that extraction is possible, or maybe viability is not there, or maybe some more research is required. So 100% import on lithium, cobalt, nickel, vanadium, niobium, germanium, all these series of critical minerals which are not there in India for our own use. So that is why one has to think, and why Ministry of Mines and Government of India has initiated this particular area. Everywhere you can find, even today we are organizing this seminar maybe 2 months back. GSI is also going to organize similar kind of program, that is critical mineral extraction. A seminar on critical mineral extraction using primary and secondary sources. Now you can see the production wise, worldwide you can see China dominance, everybody knows in every critical minerals. But you can see yellow one is the mustard yellow one. You can see lithium, nickel, cobalt, graphite, cathode, anode, battery production, everywhere their dominance you can see in this particular slides. Since time is limited, I will go very quickly. So this is how you can see that China is leading in all the critical minerals and playing hand and ball with the other country. If they, actually one news was there in 2009, they were trying to stop the supply of some rare earths to US. And from there it started that one has to think for their own resources and try to extract out of that. So that is why this has begun, and now it is in the stage that every country is fear of the shortage of or supply chain issue related to the critical minerals and rare earths in particular. This is what I was trying to tell, that what is GNRDC initiative in this particular area. We have taken a scandium project, niobium and tantalum project, nickel project, and one gallium project. These all 5 projects are of around 10 crore rupees, and we are working on it for the process development and from extraction stage to the final product. But there is a very big gap of the technology in India itself. So we are still under some pilot or something like scale up stage. So now I will talk one by one, very short because slides are less. So I will talk in very short, but you can understand the what we are trying to do. So one program where I think 2 persons were also talked about, that is one is Hindalco and another was Vedanta. Manish-ji was there and madam was there. So what we have started with working in scandium, it was a Niti Aayog project. It started 4 years back only. But what was the topic? Utilization of and development of process for recovery of strategic rare earth from industrial well. That is a complete utilization called, it's a holistic kind of utilization where all the 4 or 5 major constituents to be recovered, and out of that if anything is left over, that is rare earth, and rare earth means scandium. Lanthanum, cerium, etc. has no meaning, means even if you are recover, value is very less. That is why scandium has become very important, in particular red mud issues. Like red mud is content, if you go with the Central India and East Coast bauxite, Central Indian bauxite usually contain more than 50 ppm, more than 30, 40 ppm, whereas in case of East Coast bauxite, it is coming to be 20 or something like that. But if you processing, where bare process is being used, in bare process what happens, it get doubled into the red mud. Because if you see the process whole mass balance, it is doubled. So in East Coast bauxite, it is coming to be around 35 to 36 ppm, milligram per kg. Whereas in case of Central Indian bauxite, like what Muri and Aditya Birla group, like Renukut is doing, they are having around 70 to 75 milligram per kg as a SC. I am talking about elemental concentration. So if you calculate based on SC203, it will be more than around 100 and more than 100 also, 110. So this project was started with Hindalco, Vedanta and Nalco, and we three institutes like NML, IMT and JNRDC. So each and every parts, every role was decided in that particular project, and this project took 4 years for completion, but we are in the stage that we can say that we have developed some process. Maybe after commercial, when you try to develop a commercial plant or set up a commercial plant, we will have some problem, but at least there is a know-how that we can set up a plant. So we are going to demonstrate a 100 kg plant, maybe in Nalco, Damanjodi, so that every industry can take a look of it and take advantage of that particular development. So that is what first one is there. And second one is triazine derived carbon nitride, graphitic carbon nitride. This is a compound which is synthesized very recently, only 13 years back only, and this was used for the separation of scandium and niobium. Some person was telling it is a very simple process, but I am telling you that it is one of the most toughest, process for separation of scandium and tantalum. Why? Because if you go into the chemistry of tantalum and even tantalum and niobium, you see physico-chemical property. Chemical property is almost close to each other. Physical property also, even ionic radii, if you see, that is 64 picometer, which is same to the niobium and tantalum. But because of this reason, separation is become very difficult. Whether you are using, maybe solvent extraction is there, ion exchange is there, but still we are in the situation that we are not able to distinguish. But I am telling you, and most of the abroad people are working on the fluoride, HF base, that is fluoride process, and that once you are talking about HF means process gone, because it is very difficult to handle. So we are, sir, yes sir. So I will go quickly. So this is the process which we tried, and this is a flow sheet which is being developed at this stage, that from red mud to titanium recovery, alumina recovery, and rare earths scandium is there specifically. This project has been completed. Now the process what we have involved, this is the flow sheet. I am not going to into detail. So this is the flow sheet we have developed, and there is started with beneficiation, and that value is also there, how much scandium in this lanthanum and cerium, and what is the final flow sheet. This was the flow sheet we have developed in our laboratory, and scandium, mixed scandium oxide with titanium and lanthanum and cerium is there. Though its purity is not very high, but we are still satisfied that if we can purify, we can get a high quality scandium oxide, mixed oxide. This is again triazine based, which we are talking about, niobium and tantalum. The process we have adopted like non-fluoride based. So this process is actually we tried, and one, I think Somani ji was presenting that tantalum niobium percentage. I am very satisfied that the value of what he was showing is correct. We have also found around, in niobium and tantalum, tin ore, and then tin slag. We have melted in our own laboratory, and we found that niobium is 9% and tantalum is maybe around 20%. It was there in that particular, that tin slag. So we have compared with commercial, means whatever product. One company is there in Chhattisgarh, Bastar area, that is precious metal, I think. From there only we took the sample and we characterized and we started working on it. So this is what the process we adopted. This is what the leaching, what we have done, non-fluoride process I am talking, because This is one of the most difficult part which we are dealing with, and we have achieved 90% of niobium and 75% of tantalum in our leach liquor. And if it is there in the leach liquor, it can be separated because solvent extraction is there. So this is another waste which is called EAF, electric arc furnace waste of steel industry, which is nickel is there, and we have adapted the process in our laboratory, and we have developed a process flow sheet, and I will show you the concentration where in one there is a batch wise generation of the dust, and in one case it was 15%, another case it was 4-5%. So we have developed the process for recovery of nickel, and then nickel is, you can see in the box in the double, it is coming to be around 85-86%. Now we are purifying, and most probably we will be able to get battery kind of purity 99.1 or 2, something like that. This is again a gallium project. We are working with NIST Trivandrum, and this is a combined project. And in this project, what we have developed a process. It is a waste material which is coming out of the titanium industry, pigment industry. So that also contains around 50 ppm, 50 milligram per kg. So that process also we have adapted. Here, different process we have adapted, like we have developed a it's a kind of separation material which are used for as an ion exchange material. So this is what we have done. That is gel and beads, and that is called, I think, molecular sieve kind of thing we have developed. This development is done by means NIST, and we are trying to separate in our laboratory. So this is what the progress we have done. This is a 6-month only progress in our laboratory. So we are very hopeful that in coming year we will be able to develop a bench scale process for the scandium, tantalum, niobium, and gallium. Another is a potash, which is now so many people have talked about the overburden. So we have collected once. Actually, we are doing one testing kind of thing for moil overburden. In moil overburden, we found that potash is in very high concentration, around 5 to 6%, some cases 8%. So average concentration, we found that it is coming to be 5 to 6%. So now potash is also in critical mineral category. So we are also working upon, and we have a very good results. Mass balance is there. So we are trying to make a bench scale process for the recovery of potash from the moil overburden. So this is how we are trying. So sir, time is yours now, and thank you so much for listening. If anything is there, I am there for you. Thank you so much.
Thank you, Dr. Singh. Lot of data has been generated from your team. So it's really going to be helpful for the coming period for the industry. Thanks a lot.
Actually, this scandium, tantalum, niobium, and so these are very important metals to recover. And the process they are developing, which is, someone is interested, they can go and see his facilities also. He has developed very nice facilities, especially for the young ones. If they want to go, please visit his lab. So next one, please. I think next one is from Shri Muhammad Dastagir Sahab from the VJML mine tailings. He is giving his own perspective on that and how important that extraction of the critical minerals from his mine tailings. He will be discussing that with us.
Yeah. Good afternoon to all. Thank you, sir. I am Dastagir from MECL. So today my talk is on BGML mine tailings, a potential source for extraction of critical minerals, opportunities and challenges. So my talk mainly focus on the available resource position of BGML, and second thing is the test works done by various agencies and their key findings and its potentiality for recoverability of precious and critical minerals. And third one is a global scenario and the adaptation of a new modern technology for material characterization. And third one is possible opportunities, challenges, and a way forward. So, since time is limited, so I try to finish on time. So this is a presentation outline. Yeah. So BGML stands for Bharat Gold Mines Limited. It is located in the historic Kolar gold fields of Karnataka. A more than century of gold mining operations generated large volumes of tailing dumps in BGML. So these tailing dumps are potential source for valuable, precious, and critical minerals. So with the growing demand, national and international demand for strategic and critical minerals, so these legacy tailings are emerging, are valuable secondary source for metal recovery. Now come to the brief note on the geology and mineralization and mining aspects of this BGML. So geologically, the KGF is a part of Kolar schist belt of eastern Dharwar Craton. So mineralization point of view, the gold mineralization occurs in this area as quartz lodes, and it is mostly associated with quartz veins and with sulfides also. So we can say that the gold is here occurs as a free milling type as well as a refractory type. So mostly it is about 95% is free milling type and the remaining 5% is a refractory type. So, so since gold mineralization occurs in this area in a very in a very large volume, so mining operations also done extensively in this area. So over 100 years of mining activity in this area generated large volumes of tailing dumps, and during 1883 to 2001, about 51 million tons of gold was mined and milled, and around 803 tons of gold was produced. As I said, these tailings, mine tailings, are important source material for the precious and critical minerals. If we see the composition of the tailings, is mostly contain silica-rich gangue, and residual gold varies from 0.03 to 1 gram per ton, and also sulfides, mostly pyrite, arsenopyrite, pyrrhotite, and some iron oxides and other trace and associated elements. So if we have a look at the previous work done by the GSI, BGML, and MECL, so all these studies indicated that the recovery is a key factor. So the recovery of gold from these tailings indicated about 55 to maximum 60% gold recovery. Apart from this, the studies also indicated the presence of tungsten and some critical minerals like arsenic, vanadium, manganese. The problem is all these processes were based on the cyanidation process. So in the cyanidation process, the problem is the recovery. The recovery is quite low, that is around 50 to 60% maximum. Because the process, the limitations involved in this one, that is the reason recovery is less. Now subsequently, NFTDC carried out R&D work on these BGML tailings. And the key findings of NFTDC was two key findings were there. One is the presence of gold along with PGMs, that is palladium and rhodium. And second one is high recovery rates. The presence of gold, they reported the presence of gold in tailing dumps of BGML varies from 0.6 gram per ton to 1.2 gram per ton, and palladium 0.9 to 2 gram per ton, rhodium 0.4 to 0.9 gram per ton. So they have conducted one pilot plant study of 500 kg per batch. Based on the hypochlorite process, they have reported the recovery rates for gold as 82.1%, palladium 76.2%, and rhodium 70.6% in concentrated form. If we look at the scenario, global scenario, there are some more key players working on this hypochlorite process. It is a hydrometallurgical process to recover the gold as well as other precious metals. So one is the DST Canada, Quebec, which developed a proprietary chlorination-based gold extraction process utilizing sodium hypochlorite, and it is capable the catalytic amount of bromide. So the key the key thing in this one is a high recovery, that is about 95%. Then second one is a cyanide-free alternative and environmental friendly. The second one is, sir, the research initiatives, Mexico. They have also carrying research on this, and they reported that this oxidative pre-treatment with calcium hypochlorite followed by conventional cyanide improved gold recovery rates. So this study also shown about 96% of recovery. And another one is a University of Mines and Technology, Ghana. They have also carrying out research on this. And finally, another one is a Mintek, South Africa. They have also designed their process for small-scale minerals, and implemented in regions like Gotek, South Africa, and Tanzania. They have reported 99 high purity, that is 99%, and this process is eco-friendly process. So in line with the critical mineral mission, so these reprocessing of these tailings will not only align with the objectives of India's critical mineral mission, but also offers an opportunity for environmental remediation, reduce import dependency, and economic revival of the KGF region, and a step towards circular economy practices. So I would like to highlight the contributions made by MECL in the exploration of critical minerals. So as of now, MECL has successfully completed G4, G3, and G2 stage of exploration work in 62 critical mineral blocks till date under MOM and NMET funding. So it is already it has also contributed 2,672 million tons of critical mineral resource to our country. Moreover, 35 number of blocks for critical mineral are under evaluation. So MECL also involved in the evaluation studies of BGML tailing dumps. So MECL is having ultra-modern chemical laboratory facilities for energy minerals as well as non-energy minerals. So highly sophisticated instruments like ICP-MS, ICP-OES are equipped with the MECL laboratory for high precision analysis, which includes digital core scanner, one of its kind. It is the application of digital core scanner is the creation of a digital core library. So recently, sir, MECL procuring two advanced laboratory analytical facilities. One is a hyperspectral core scanner with XRF, and another one is a LIPS core scanner. So these two instruments are capable to map the mineralogy as well as geochemical profiling, elemental profiling. So all these instruments will be helpful to for material characterization. So come to the end, the opportunities. So we have opportunities on this subject matter. So the reprocessing of BGML tailing dams offer a strategic opportunity to recover precious and critical minerals. So in case an FTTC process is commercially proven, then the valuation of tailings may increase threefolds. High economic potential given current gold prices and other precious metals. Explore possibilities for commercial saleable bricks using reprocessing tailings is also another option. So environmental rehabilitation of legacy mine sites, job creations, and support circular economy and strategic metal supply. So these are the opportunities. And of course, we have key challenges also. So whatever an FTDC study indicated the presence of gold, platinum, gold and palladium, rhodium, these are all reported in a concentrated form, but not extracted in pure metal form. So further detailed study, further research study is required to extract these metals commercially. So scaling up pilot plant studies for commercial operations. So apart from gold and PGM, economic viability studies for extraction of tungsten is also is required, because tungsten is reported in the tailing dams. So other key challenges may be the legal disputes over the land and assets, and some environmental hurdles, and high initial investment and infrastructure needs, and some encroachments are also there. So these are the key challenges. So in conclusion, we can say that the BGML tailings are valuable but untapped resources. So we have risks and rewards. So modern technology and strategy policies support can enable successful resource development of BGML mine sites. Finally, we have one way forward, sir. To realize the full potential of BGML tailings, a multi-pronged approach is recommended, which includes the systematic, detailed resource characterization of tailings and pilot-scale metallurgical testing to develop eco-friendly, commercially proven technologies, and comprehensive techno-economic evaluation. In addition to that, government may consider to allocate or auction these tailing dams to technically capable agency for the development of recovery plants. Finally, the collaboration among public and private agencies, academia, and research institute, supported by policy initiatives under Critical Minerals Mission, will be vital for sustainable resource development and import substitution. Thank you very much.
Thank you, Mr. Dasgir. It has been a really interesting and I think one of the foremost with reference to IBM's mineral conservation point of view. And I hope similar thing is being done with Hatti Gold Mines also. Yes. We have some representative from Hatti Gold Mines here also. I was also part of Hatti Gold Mines for a brief period. So this is going to be really very challenging and very interesting for the mining industry if we can get some benefit from the tailings, which is a huge quantity because the gold is extracted only in ppms.
Yes, sir.
So it's really going to be very interesting. Thank you. Thank you very much.
Thank you, sir.
The lectures of this kind, they definitely tell us that we must search each and every tailing ponds, the dumps, even the soils of the mining areas, because they will be the sources for future. Now coming to the last presentation, that will be by Rama Satpathy. Shri Rama Satpathy Saab, she will be talking about the extraction of critical minerals from tailings and overburden dump. So over to Shri, sorry, okay, extraction of minerals, please excuse me for this. Extraction of minerals from BHQ. That sounds very interesting by Shri Rama Satpathy sir.
Yeah, very good evening on the dais, moderator and all my IBM officials and all my colleagues. तो अंत भला तो सब भला. Okay, तो मेरा last है. So this is whether this presentation is all about the banded hematite quartzite. It is a hematitic lean grade iron ore where the Fe is vary between 20% to max of 40%, or average we can say 30 to 35% Fe here. So it's a case study, and belongs to Loyal Metals. So we are going to coming with this beneficiation plant in this Bidharva region in the district of Gadchiroli. So that case study I am going to present here. And there will be lot of slide which is as you know, so I will finish on time. That's my, definitely I will finish on time. So as you know, whether this BHQ is coming under critical or not, I am leaving to all of you. You decide in the end of presentation. So as you know, 10 trillion is the national target. हमारी भारत की ये target है, and जिसमें power and mining plays a major role. Again, this is also, as you know, the national tails policy 300 by 2030 and 500 million ton per annum by Amritkal 2047. And this is one of the indicator of Viksit Bharat. To achieve that, your national mineral policy, national exploration policy, all already has been integrated and has been initiated to achieve this top goal of the country. So again, still scenario of India, as you know, in the right hand side top 300 and 500, but the way we are going, the greenfield project and the brownfield expansion in the steel sector, most likely will end 255 to 260 million ton per annum by 2030. Still then it is a good step. So again, when entire people related to things, so again it is, as you know that ki hematite, and but here the thing, we are having a resource of 35.29 billion ton. When I am talking resource, this is more than 45% Fe iron ore. In that resource there is hematite or magnetite, but hematite is morely dominating that resource, and there are certain information regarding that. We are the second steel producer in the world, and China, between China and India, the gap of steel production is huge. But we are seventh in the iron ore resource. Just remember this slide when I will speak in forwarded slide. Again, this is, if you see production, India is almost in the 4th position, where Australia is in number 1, China is number 3. I'll come to China. I spend a lot of time along with my team at China and Australia. Will come in the conclusion what is their philosophy and how we are approaching philosophy. And this seminar is exactly hinting towards that, how we can catch this. Again, I'm not going much detail to that, but thing is that our iron ore production, just remember, is as max as 6% year-to-year average, but as low as 2% year-to-year overproduction, iron ore production. And this is the one interesting slide where our goal is to achieve 300 by 2030 and 500 million ton steel. For that, we required an iron ore of almost 830 million ton. That means 0.8 billion ton, more, it's close to 1 billion ton. And by 2030, we are, let's assume that we will achieve 255 or 260 million ton, then you required around 0.5 billion ton, where if you see our resource, I have told in the previous slide,
it is 35.29 more than 45. And out of that, if you see, around 40%, which is more than 55%. Today, to produce all the steels in India, our steel producer, including us, we are very selective. More than 55, we are mining more than 45. 45 to 55, we are telling it is a subgrade. Less than 45, it is a waste. And we are producing this steel. That means in the course of operation, we have generated a lot of 45 to 55% AP, which has kept in the mines, and less than 45, it is a waste, either kept in the waste dump or it is in situ untouched. And there is a gap of steel production and the iron ore required for the steel production. So there is a sufficiency of iron ore for the steel production, which was taken as a national target, is also a challenge. So this is what is the benefit. Why I am telling you less than 45 Fe content is the future. Otherwise, if you actually use all the way we are using the iron ore, then in next 15 years, our more than 55 iron ore will finish, and by that time, we may achieve the 300 million ton, but 500 million ton will be shortage of iron ore. We'll import the iron ore. That early indication has come in last 3 years. We have already, India has already started importing iron ore. The early indication has already been started. So that's why I'm thinking you all will decide whether this will come under critical or not. Today it is not. So these are the challenges of why less than 45 or low grade iron ore is untouched. There are several reasons. Beneficiation technology is costly. There are some policy required for that. But if you see in the recent past, in last 1 year or last couple of years, our regulatory authority and policy makers they are coming with a lot of new changes to those policy, which will encourage the low grade beneficiation of iron ore. So early indication import is there, and already some policy changes is taking place. Now it is the role for the miners to act on that. I am not spending much time on that, but yes, these are the things which is required, and in all the boxes job has started. All the boxes job was started by this policy maker, by the Regulatory Authority of India. This is some of the policy already telling the West how to create value from the iron ore, because in one side challenge is decarbonization of the steel. Decarbonization steel not only technology. While in technology a lot of R&D is taking place, but decarbonization also required. You required a very good quality of iron ore, where alumina plus silica should be less than 3. If it is less than 2, it is very good. In place of 240 to 200 kg of slag, you will only generate 120 kg of slag, and the fuel consumption, which is coke, will be drastically reduced, and that actually helps in the carbon emission. So for that you require plus 65. That's why import is taking place, plus 65% Fe import has started. So these are some of the slides where government is also now, this you see where I have my figure is updated up to 23-24, but this 24-25 also 0.5, that means around 5 lakhs already imported plus. So indication has come. India is a large deposit of iron ore, then why this import? This import is, we are very selective, and still good steel, decarbonization still required a selective quality of iron ore. Then this case study I am coming to, then this BHQ, BHJ, BMQ, all this will play a role. Because here the alumina, by nature alumina is negligible, 0.2, 0.3, 0.4 max. Phos is 0.001, 0.002. So very good. Only thing you have to reduce the silica, which is the main impurities. And while you are reducing the silica, your Fe will definitely upgrade, because mass balance is there. Everything has to be balanced. So this is where the Lloyd's metals we have started this joining in 2022, and we have done a lot of exploration is the major thing here. We are not exploring nowadays this BHQ, BHJ, because the moment hematite is completed and it is touching, because exploration is very costly, 3 times. It's required 22,000 rupees per meter is cost to us, where the normal is 6,000 rupees. So exploration, then first is mapping, then the exploration, then exploitation, then value addition, then we talk about the supply chain, then to the market. So these are the things what Lloyds Metals in the Gadchirul district, known as Surjagarh iron ore mines, we have did. We have completed the exploration. We have also extracting, but only interburdens are extracting now. We have already in the doorstep of getting the environment clearance. So we'll go for a full-fledged extraction of BHQ, and our average FE is 32 to 33%. And we have did a IBM is here, JNRDC Upendra Sahib is here, who has did our all the analysis, and IBM is here, Kole Sahib is here. In the morning, Kanungo Sahib was here. From Tata Steel, who has been guided us in the exploration and how to do the core and sampling and QAQC, Pankaj was here. And there are certain international, IIMT Bhubaneswar is here. They have also done a lot of help to us. Scientist Ramana and all, they have worked very closely with us. So we have also having partnered some of the international bodies. Everything was come very well. The result was good. Then we have R&D scale flow sheet was developed by modern mineral processing unit of IBM here at Nagpur. Then we have come with a pilot plant. We have established our own pilot plant of 5 tons per hour in our mines, and the results are, and from July continuously we are operating this pilot plant, and from 32 to 33, initially we have gone to 63, then to 65. Nowadays we are operating with 67% Fe. Alumina plus silica is less than 2. That means when this particular thing will convert to pellet, and that pellet will go to the Indian steel market, then the slag reduction, the fuel reduction will definitely. We are coming with our own steel plant also. So this is a simple process, like other process. There is nothing copy-paste in this case, because each mines are different mineralogy of BHQ, BHJ, mineral characterization of BHQ, BHJ. So everything will require a different process. But technology is this. These are the technology. Something will use first, something which is later stage. But here, one more thing. Here, while your yield will be 25 to 30% on max of 35%. In 100 ton, you will get 35 ton of this particular BHQ concentrate. But still then, it is good. And it is, there is just iron ore shortage, which will fulfill that. In that fulfill, we will get a good steel, which is less carbon emission steel. So, and from there, you can, because of fossil slate, you can get a very high-end steel alloys, which can be used on defense or all other precious steel production. This is a roadmap. So first circuit will start in 25, 26, then 26, 27, and by 27, 28, our entire 3 circuit will be completed, and it will be 45 million ton per annum. Maybe the highest in India, definitely. In India, maybe the BHQ nobody is doing, and it will be the second highest in world. And it is coming in this Vidarbha region. So I think I must thanks to our strategic partners, because this is not only open a new era for the iron ore industry, also for steel industry, and that will start from this Nagpur region, from this Vidarbha region, and from the Gadchirul district, which was one of the critical district in India. You know that Gadchirul, how critical it is. So critical districts, around less than 45% Fe, which will go to the steel plant with a 66-67% AC. Silica plus alumina less than 2. Phos is negligible. so you can know what kind of a revolution it will bring to the Indian steel industry. So thanks also to IBM Nagpur, JNRTC Nagpur, GSI India, Tata Steel Consultancy, AB Global Mining South Africa, RPM Global Australia, our R&D partners, as I told, Modern Mineral Processing Unit, IBM Nagpur, IMT Bhubaneswar, FL Smith of America, and Metso Minerals. We sincerely thanks. I think in another maximum 16 to 18 months of time, this India will see this BHQ beneficiation plant, which will give us this kind of a concentrate to the Indian steel industry. Thank you very much. Thanks. Thank you, sir.
Thank you. Thank you very much, sir. Very interesting that Lloyds is involving in beneficiation of the low-grade iron ore, which is going to be the backbone of Indian steel industry for the next decades. Thank you, Mrs. Satpathy.
Although this is where the today's sessions are being concluded, this was a small session, but then this was the part of the great phenomena that has occurred for today. Everyone, I can see from the first presentation, keynote address up to this point, most of the participants are present here. So the topic is very relevant, and the discussions that how we can extract the important critical minerals from the mining wastes. So that has been the highlight of this, which is very well taken. Passing my comment is that we are looking for lithium and all that for the energy minerals. But then the technologies are changing, because we know that lithium resources are limited and we cannot depend on that, whereas a lot of scientific research is going on how the sodium can replace it, and it is very viable that the sodium and then maybe potassium will take over. So we have a lot of that. The crust is full of these metals, so things will happen. And then there is one very well saying by Raymond, देखी बड़ेन को लघु न दीजिए डार, जहाँ काम आए सुई कहाँ करे तरवार, ऐसी एक कहावत भी है. So the point is that the critical minerals, we are looking at the critical places, but at the same time we have to make sure that research continues in all the domains. Although this topic of seminar is very well focused and very well displayed and presented, but then it is a joint work of the geologists, of the mining engineers and all. So once again I thank you on behalf of Dr. Saab that being given us a chance to be moderators of this session. Thank you very much.
Thank you, sir. Thank you for ending this session with a very apt saying. I thank all the speakers for their insights. I also extend gratitude to the moderators for their valuable presence. May I please request our moderators, Mr. Sudhanshu Patni and Professor Kriti Kumar Randive, to present memento to our speakers. I would like to invite on stage Dr. Upendra Singh, Senior Principal Scientist and HOD, Analytical Division, JNARDDC. I would also like to invite Mr. Mohammad Dastagir, Manager Geology, MECL. I'd like to invite on stage Mr. Rama Satupathy, Executive Director, Exploration and Beneficiation, Lloyds. Thank you so much. To express our gratitude, may I now please request Mr. VJK Babu, Controller of Mines, IBM, to present mementos to our moderators, Mr. Sudhanshu Patni, President, UG Mines and Projects, Balasore Alloys, and Professor Kriti Kumar Randive, HOD, Department of Geology, Nagpur University. Thank you so much, sir. Thank you. As we draw the curtains on today's enlightening and engaging sessions, I thank each one of you for your dedicated participation and active engagement. We are immensely grateful to all the speakers who took out time to share their knowledge with us today. We also extend our heartfelt appreciation to the esteemed moderators of each session who guided the discussions with precision. I would like to take a moment to acknowledge the collaborative effort of the Indian Bureau of Mines and National Mineral Development Corporation Limited. Now, we will commence with the valedictory session. For the valedictory session, I have the honor of inviting our esteemed guests. Please join me in welcoming Mr. Piyush Narayan Sharma, Controller General, Indian Bureau of Mines. Dr. Sanjeev Kumar Sinha, Director Operations and Mining, Hindustan Copper Limited. And Dr. Y.G. Kale, Controller of Mines, Indian Bureau of Mines. We are privileged to have the distinguished leaders with us this evening. Your presence truly adds prestige to this closing ceremony. Let us take a moment to formally welcome our guests who have graced this seminar with their esteemed presence. We now extend a heartfelt welcome to Mr. Piyush Narayan Sharma, and for that I would like to invite Mrs. Jyoti Mathur to offer our greetings. We are deeply honored to welcome Dr. Sanjeev Kumar Sinha, Director Operations and Mining, Hindustan Copper Limited, and I invite Ms. Shreyasi Das to extend our warm welcome. It is my privilege to welcome Dr. Y.G. Kale, and to invite him, and I would like to invite Mrs. Garima Singh to do the honors. Thank you. As we wrap up this landmark event, it is time to hear from our esteemed dignitaries. May I first request Dr. Sanjeev Kumar Sinha to kindly share his closing thoughts. Thank you.
Honorable Sri P.N. Sarma Sahab, Controller General, Indian Bureau of Mines. Honorable Sri Y.G. Kale sir, Controller of Mines, IBM, and my dear friends from industry, Indian Bureau of Mines, institution, research institution. I am very much thankful and stand proud of you to speak on this concluding session of one-day seminar on critical minerals. As we are discussing the whole day on the recovery of critical mineral, we from a mining industry perspective, from a copper miner, we are generally generating lot of tailings. So as of now, Hindustan Copper is producing around 4 million ton of copper ore. And out of that, around 4 to 5% we are recovering as a concentrate, which we are supplying to different smelting and refinery unit within the country. And 96% is going to the tailing ponds, 95 to 96%. these are having some valuable minerals, sir, but time to time on the quarterly basis, we are sending the sample to different institution and getting it checked by different authority. And whenever we find that something important is there, we are offering others also to come and partner with us so that we can recover the valuable mineral. In fact, Hindustan Copper is having a very glorious past when we developed a lot of units in Khetri Copper Complex and Musabani, where we have recovered precious metal like gold, silver, nickel also. And in fact, we have transported slimes from our Khetri mines also to Mau Bhandar plant to recover gold, silver also, but that was the past. But with time passes, the economy has not supported us. Lot of big units has came. Our plant unit was having a capacity of around 18,500 tons only at Musabani and 31,000 at Khetri. So financially, it was not viable for us to run all those units. So management decided to sell the concentrate and left it to the smelting plant like Hindalco and Adani to recover the precious metal. And they are doing it, sir. It is not going in the waste. So almost if we see that Hindalco capacity, smelter capacity around 5 million ton, Adani is coming with around, 5 lakh ton, and Adani is coming with around 1 million ton. So they require around 150 million ton of ore, whereas we are producing around 4 million ton. So overall, our supply is restricted to only 2 to 3%. Whereas in case of reserve and resources, India is having only 0.2 million ton of total resource of the world in case of the copper. Even though we are trying fast and we are having around 80 million ton of tailings in our copper project at Malajkhand. And whatever the fresh tailing we are producing, we are filling in the stopes of the underground mines, because you know Malajkhand Copper Complex has been converted into a underground mines only 2 years back. It was a open cast mines. Now we have converted into a underground mines, and seamlessly we have converted it, and also we have our production remained constant, even it is higher in underground mines. So production was not affected when we went to the underground mining, only because of the new paste fill technology, where we are utilizing the slimes only for paste filling along with GBFS and cement. So that has been explained by our colleague in the first half. But we are having sufficient tailings to offer you for testing. I invite all the research laboratory to come forward and guide us. We can have a joint venture, and we are ready to discuss for any joint venture and commercial exploitation of the remaining tailing and upcoming tailing in the Hindustan Copper Mines. Sir, we are already having discussion with Uranium Corporation of India for our tailings in Musabani area, where they have offered to test the tailing for recovery of any uranium material. Codelco, the biggest copper mining company from Chile, we have signed a MOU with them, sir. Only last month only, in presence of the Honorable President of the India and Honorable Prime Minister, we signed a MOU for technology transfer. And Codelco team will be coming to India in the last week of June, starting from 23rd. So we will make it sure, sir, that we bring the Codelco team into IBM headquarters also, because we will be taking them into different institutes, like we have planned to take them to IIT, ISM Dhanbad, IIT BHU also, and our projects also, so that we can study how we can improve the recovery. Like we have problem in Khetri mines in recovery of copper. Lot of copper is being wasted in the slime. So we want to recover those copper also. So for that, Codelco team will be coming and will be supporting us also. So mostly what I can conclude that we have to identify the most viable extraction method. We have to ensure compliance with the regulatory standard also. We have to ascertain the profitability also, because without profitability, the system cannot run. And we have to engage the community also. We need new technology for which we can invite the international partner and Indian partner also. Sir, on Tuesday, the next week, we will be having a MOU with IMMT Bhubaneswar also, in presence of Honorable Minister Sri Jitendra Singh, where we are signing a MOU for technology transfer with IMMT Bhubaneswar also. So all those efforts we are taking from the Hindustan Copper. I congratulate IBM and NMDC, my past company. So all efforts have been made by NMDC and IBM to bring all together us to discuss on this burning issue. And the last presentation was about the Lloyd Steel. I would like to make it a point over there that NMDC has also planned to treat BHJ from its Donimale plant and developed the flow sheet in R&D center of NMDC. And that was quite commercially viable. But for some site location only, it could not be converted into a commercial plant. I hope NMDC will take note of it and again work for it, because when Lloyd is coming forward, NMDC as a big iron mining company will also come forward. I assure you, sir, that on behalf of Hindustan Copper, we will take every effort and will take your guidance to improve ourselves, our recovery in copper and critical minerals, if any present in the slimes. We are ready for any joint venture with any company. Thank you for giving this opportunity.
Thank you so much for your words, sir. May I now invite a luminary whose presence has elevated this event. I request Mr. Piyush Narayan Sharma to kindly address the gathering. Thank you.
Thank you very much. This is really heartening to note the presence of all of you, those who are interested in listening to the different point of views. And this is remarkable that all of us, we are here. Otherwise, it so happens, it starts with a bang, and then gradually we diminish in number. Most of us, we are loitering here and there, least interested to listen to what the experts they say. And at the outset, I raise my hand, sincerely tender my apologies to get out of my, limits and what I say, to get out of my clothes, by unnecessarily shouting on some of the people, those who were loitering out. Believe me, I was under the impression that because they were my people, my means from my own department. And I really took it like, those who have come from so far of the places to give us their knowledge. And we are just not taking it seriously. That hurts me the most. And I really, this is not the way, but I can't sometimes control upon my emotions and everything. So this is the one thing. Then I just heard about these are the critical minerals, and I don't think that these are the minor minerals we were talking about. Last में आपने एक कहा रहीमन देख बड़े इनको लघु नदी चेड़ार. So सबसे बड़ी चीज़ ऐसी है कि जो ये छोटी छोटी संख्या में हैं, बहुत they are in a very minute quantity, but they are very important. Their importance is enormous. उसके लिए सिर्फ एक ही चीज़ मैं कहना चाहूँगा कि सतसैया के दोहरे जो नाविक के तीर देखन में छोटे लगे घाव करें गंभीर. So this is a very important aspect we are dealing here today. And I never take paper, but today I have taken a paper because I'm not good at remembering all the names. After all, I am getting old. But I am indebted to all of them. They brought, I understand, I can very well, take the names of everyone, one and all. It was like heartening to hear from Mr. Abdul Rauf, then Madam Chandralekha, wonderful things. And I tell you, Abhinav is a young lad, and I'm always a fan of him. I've been I'm listening to him, and he sends me a wonderful, informative snippets on the WhatsApp. It's always wonderful to be in the company of youngs. I always feel like running with them. I don't know whether I can or I cannot, but I will definitely not leave trying to. So it's good. Mr. Panda, always a wonderful person. Now he is also taking all the efforts to take up his own department to the next levels, and we are in close touch with him. We had with us Mr. Gajanan, and Mr. Satija aptly said that he should have been the starting point of this thing, being Gajanan. So wonderful to hear you. Mr. Sudhir Panda and Mr. Sunil Kumar, I tender my apologies because during that time, I was with the Times of India people, and probably I could not hear you, but I make it a point to go through your papers because that will be available on our website as well. Mr. Masto, he brought all his experience and his work. Madam Shiba Mashruwala, wonderful in a sense that she focused only, जिसको कहते हैं ना कि सार सार को गही रहे थोथा दे उड़ाए. तो ये कुछ ऐसा था कि जो the points which were discussed, she left it and she focused on the issues which were untouched, a proper utilization of the time. Wonderful. We have then Mr. Somani, Saurav Kumar, and of course Mr. Upendra Singh, known to us through Dr. Agnihotri, Shri Mohammad Dastagir. These are wonderful presentations, and of course, last but not the least, our friend Mr. Satpathy. And I tell you, because I'm a great fan of the work which they have put in, I have little information about what they are doing, and I understand that the kind of work they are doing in that remote place, it is really wonderful. If you have a time, please go there, visit their sites. You'll be thrilled to see what they are doing. It's a wonderful job in making. Still, they are going through the different phases. And I have absolutely no doubt that this is going to be another steel hub of India, probably larger than the Jamshedpur in the time to come. That too in the Vidarbha, very close to Nagpur. And this is a wonderful beginning from them. And I tell you one incident. We had a Mining, Environment and Mineral Conservation Week. We were there, and I was introduced with the 6 girls, the local girls. They were from the Gadchiroli area only. I was thrilled to meet them. It was like I'm meeting a rock star. They all were for me, as a matter of fact. All the girls, they were the daughters of that soil. And I was told that they are operating the heavy earth moving machines. And they wanted a photograph with me. As a matter of fact, I told that I feel privileged to be photographed with you, and that is a fact. So, if I sum up the entire proceedings of today's, I really tell you, everyone from this chamber is going back to their respective places, little more knowledgeable, little more informed, and as a matter of fact, they must be appreciating the fact that they came into contact with the people, those who are working very significantly in their own chosen fields. And these fields, their work is going to create many milestones in the years to come. Today, you may feel that this is a very humble beginning. We don't have much to showcase as far as the critical minerals are concerned. As far as our extent of exploration is concerned, our technological advances to extract the material and the metals from ores is concerned, but it gives us a hope of a bright future, a hope where we see that our small steps turning into the big journeys which will yield wonderful goals, wonderful achievements, and probably in the years to come will feel that how significant these small steps were. Because any journey, it starts from a very small step, but then unfolds a whole lot of wonderful story to be told, not only to be shared amongst us, but at the same time to be told to the generations to come. And this is how the great nations are built, the great societies are built, and the foundations of the future are laid. I understand, and it is my belief that India has no dearth of commitment, talent, innovation, and to do something which is different from the run-of-mill type things. The only thing is that we need to nurture all these wonderful people. We need to provide an atmosphere for them to grow. And this is what our honest duty is all about. I again thank you, all of you, for your magnanimous and gracious presence. You have come during these tough times from all across the country. I especially thank to all the Nari Shakti, those who have come. I really appreciate your presence in every field of our life and at the same time our progress. And it depends largely upon you, because all they say is that even every male who is present here and is doing some kind of a thing, there always is a female behind him. So you are all over the places. You are the leaders. There is no doubt about that. And I really thank to Srishti as well, leading from the front and keeping all of you engaged. And I understand it was all wonderful. And I again bow down in front of all of you to your knowledge, to your patience. And of course, I understand that when you will go back, you will go back with a smile and with a contentment. Thank you all. Thank you for your presence. Thank you all our partners like NMDC and of course Lloyds, all my team, all my officers, all of you. It was wonderful to be with you. Thank you.
Thank you so much, sir. That's really very encouraging, and what an unconventional address. I would once again request Mr. Piyush Narayan Sharma to kindly present memento to Dr. Sanjeev Kumar Sinha as a token of our heartfelt appreciation and respect.
Very good evening to everyone. Sorry to intrude, but this is certainly required. As we come to the end of this wonderful event, we have had the chance to hear from every speaker, every presenter. But there's one voice we have heard throughout, guiding us, engaging us with her warmth, charm, and energy. Though not coming from this background, she stepped on very short notice and making sure not a single detail was missed. For that, I would like to request Shri P.N. Sharma Sir, Controller General, Indian Bureau of Mines, to present a memento to our amazing host. Ladies and gentlemen, please give a big round of applause for the host of the event, Ms. Shristi Singh, Assistant Editor, Indian Bureau of Mines. Shristi, please. Over to you, Shristi.
Thank you so very much. I'm overwhelmed. But now, as we draw this meaningful seminar to a close, it is time to acknowledge all those who made it possible. Thank you so much, Vikas, for doing this for me. May I now request Mr. Y.G. Kale, Controller of Mines, to kindly deliver the vote of thanks. Thank you.
A very good evening to all. At the outset, I would like to extend my heartfelt thanks to our guiding figure, Shri Piyush Narayan Sharma Sahab, Controller General, Indian Bureau of Mines, for making this idea into a reality. So I am very thankful to him, and I extend thanks from all of you, on behalf of all of you. So kindly give a big thumbs up to Shri P.N. Sharma Sahab. I am also thankful to Shri Pankaj Kulshrestha Sahab, Chief Controller of Mines, who is also a guiding figure for us. And he was also instrumental to organize this seminar in a very short period. So I am very thankful to him and extend my warm thanks to Shri Pankaj Kulshrestha Sahab. Today, in the morning session, inaugural session, we had chief guest, and I extend my heartfelt thanks to all of them. And in the today's seminar, we had around 17 papers, a very knowledgeable paper. I extend my sincere thanks to all the faculty, presenters, who have made very great efforts to prepare their technical knowledge and summing up in the form of technical papers and present here. And in a very short period, we have invited papers because we don't have much time for making preparations, but all the presenters, they have made it point to present here in a hot summer of Nagpur and making presentation, a very lively presentations. A man behind organizing this seminar is Mr. S.K. Adhikari, who is a chief mining geologist. Previously, we had planned to have this a workshop type seminar on critical minerals, but he floated an idea that instead of workshop, we should have a grand seminar. And within a period of, I think, 15 days time, we had, he made it possible to coordinate with all the agencies, all the authors, and to organize the seminar in a grand manner. So I am very thankful and very grateful to Shri Adhikari Saab, Chief Mining Geologist, for making this seminar in such a grand scale. Thank you very much. No seminar can be held without the financial support. I am thankful to management of National Mineral Development Corporation, who had readily agreed to co-host this seminar. And I am also thankful to management of National Mineral Development Corporation for making associated with Indian Bureau of Mines to organize this seminar. Thank you very much, sir. I am also thankful to all our sponsors like Lloyds Metal and Energy Limited and other sponsors for extending financial help to organize this seminar. So I extend my thanks to all my sponsors and etc. And lastly, I extend thanks to all my colleagues from regional and zonal offices of IBM, who has also contributed, and they have licensed with all the agencies to put their efforts to make this seminar successful. And also I am thankful to all the delegates who have come from all the entire part of the India, in spite of challenges, because you know that since yesterday there is a great challenge in the northwestern front of our country. But in spite of that, they make it possible to have their presence here and to share their knowledge, dissemination of knowledge, and etc. So I am thankful to all the delegates present here for attending this seminar in a very short time. And lastly, I am thankful to all the team of IBM who directly and indirectly contributed, and also to the management of this Hotel Radisson Blu for making this available, this beautiful hall and all logistic arrangements. So thank you very much, and thank you. And let us hope that all these R&D work, what we have presented here, it is migrated to the commercial scale for exploitation of critical minerals. Thank you very much.
Good evening, respected dignitaries on dais. Though everything has been concluded, but for me, minerals can be critical, but applauding cannot be critical. I request all of you to please give a big hand to Shri Adhikari Saab for organizing this seminar. For the first time, I have seen a seminar being organized by IBM in a Radisson Blu hotel. That is a 5-star hotel. Thank you so much, sir, for organizing it here. And my big thanks goes to our anchor. In the beginning, I thought that she is from some professional institute who is anchoring this function. But later on, I came, she's from our own organization, IBM. Thank you so much for anchoring this event. And last, thanks to all of you. Now, sir, we want to have a group photo, sir, with you. Sir, please. Group photo. I request all of you, please join for a group photo.